Hi and welcome to this Python Beginners Programming course. My name is Ayodeji and I am going to be teaching you and taking you through this course. So if you are freshly new to programming or you are trying to transition from a different programming language into Python, this course has been specifically designed for you, and it has been designed in such a way that it is very interactive and very helpful basically. So if you are looking to learn Python, this tutorial is basically designed for you. So we are going to be starting with the very basic fundamentals, so things like variables, variable naming conventions, loops, if statements, and things like that. And then we're going to even go into more advanced topics like object-oriented programming, classes, objects, polymorphism, and topics of that nature. We're also going to be looking at working with libraries and packages. We're also going to be looking at building our own libraries and packages. So it's a course that is packed for anybody who is looking to learn Python. So this course is broken down into several chapters. So each chapter covers some specific topics. So for example, I have a chapter in this course that teaches object-oriented programming. I have a different chapter which talks about functions. So each chapter the course has been broken down properly into different chapters, and each chapter covers a specific topic. So it just basically helps to keep the course structured. Now each of these chapters has each of them have their own activities and exercises, which kind of gives you a way to practice all what you've learned. So at the end of some chapters, you have some exercises and courses that you can use to practice what you have learned. Also, I would also like to note that the entire course content, that is all the code which we are going to be writing, is present using a link in the description below. It's going to be tagged course materials or course content. So every single line of code that is written in this tutorial is available in the GitHub repository. So you can just visit it using a link in the description below. I am excited to start this course with you, and I hope at the end of this course you would have gained a lot of experience. Thank you for watching. Let's start the course right now. In this section of this course, I am going to teach you how to, or show you how to set up your development or learning environment on your computer. So we're going to be installing a few softwares which we are going to need in order to proceed with this course. So the first thing that we need to install is obviously Python, because we are going to be writing a lot of code in Python. So we need to install Python itself and the interpreter. So in order to do this, all we simply need to do is just open your web browser and search download Python. Now, once you do that, just click the first link that pops up on your web browser. Now, once you do that, you'll be brought to this page where you can see the download button. So you can see that it has automatically detected my operating system, which is Windows. So what you just need to do is click download. Or if you are trying to download for an operating system and it isn't able to successfully detect your operating system, if you look down here, it says looking for Python with a different OS. Then you can just download from here. So we can download for Linux, we can download for Mac, and you could also check for the other versions that Python is available for. But for me, I will just click download Python. And then once I do that, you can see that it has started downloading. So I am just going to pause here and wait for it to finish downloading, and then we are going to get back. So once it has downloaded, I want you to just navigate to where the downloaded file is and open it. So what we actually just downloaded is the installer for Python. Now it says install Python 3.13.2. So at the point of making this video, this is the latest Python version 3.13.2. Now the first thing that we need to do is we need to click add python.exe to path. Now this is very important and we need to tick it, because when we want to write our Python programs, it is important that our computer is able to find where the Python interpreter and the Python executable is. So that is why we need to click add python.exe to path. So it's just going to help you set up the environment variables. Now, the next thing that we need to do is we don't need to worry about custom installation, as everything is already ticked. Now, all you just simply need to do next is hit install now. So once you click install now, it's going to basically just ask you if you want to allow the installer make a bunch of changes. Now you could just tick yes. Now once you do that, the installer is going to start installing Python for you on your computer. The next piece of software that we are going to be installing is our IDE, which stands for Integrated Development Environment. So this is essentially a place where, or the place where we are going to be writing all our Python code. So I'm going to be writing our Python code here, testing it and debugging. So the IDE of choice that I have gone with for this tutorial is Visual Studio Code. So I want you to head to your browser and open a new tab. Next, search download Visual Studio Code. Now, once you do that, just hit the first link that comes up. Now, Visual Studio Code is available for multiple operating systems. As you can see, it's available for Windows, Linux, and Mac. It's also available for different Linux distros, as you can see here. You have Debian, Ubuntu, Red Hat, Fedora, and so on. Now, it is also good to note that there are several other IDEs that you could use. For example, we have one called PyCharm. PyCharm is also a good option for writing, it's also a good IDE for writing your Python codes in. We also have um, a different IDE called Sublime Text. Now, Sublime Text is also a good IDE, but the reason why I have gone with Visual Studio Code is because it is very beginner friendly and it has a lot of features that will help you get started really, really fast. So this is why I recommend Visual Studio Code. It has a lot of features and it has extensions that make development super easy and super fast. Now, once you get to this page, just select what operating system you are using. So I'm going to select Windows because I use the Windows operating system. Now, once I do that, it's just going to start downloading Visual Studio Code for me. Now, once it has finished downloading, just make sure you run through the installer and install Visual Studio Code on your computer. Right now, we have installed Python and also installed Visual Studio Code. The next step that we need to take is to set up Visual Studio Code, as there are a few things that we need to install inside the IDE. So I want you to head to your search bar and search for Visual Studio Code. So once you see it, just open it. Now you are going to be brought to this welcome page. So the first thing that we need to install is the Python extension because it's going to make development super easy and fast in Visual Studio Code. So I want you to head to this tab right here that looks like four boxes. Let me just zoom in so you see it. I want you to hover over it and you can see it's called extensions. So click extensions. Now, once you've clicked extensions, what you need to do is head to this search bar and type Python. Once you type Python, just click search and it will list out a bunch of extensions which you can install. Now, the one that we want to install is the one by Microsoft. As you can see, it has the name of Microsoft and it's just called Python. Now, it says the Python language supports with extension access points for IntelliSense. Now, we need to install this specific extension. As you can see, I already have it installed, which is why it says disable and uninstall. But for you, I just want you to click install, and this is going to get it installed on your Visual Studio Code. Now, the next extension that we need to install is called Code Runner. I want you to type code space runner into the search bar, and I want you to click the first one. So the first one that comes up, which was created by Junhan, I might be butchering that pronunciation, but this is the one that you should select. As you can see, it's just called Code Runner. So I want you to install. So I want you to install this extension. Now, once you've installed that extension, we are pretty much good to go in terms of the setup for our development/learning environment. By tradition, the next step is to write your first Python program. But before we do that, we need to set up our folders and directories that is going to house all the Python programs that we are going to write in this course. Now, I'm going to create a folder, and inside that folder, each class or each topic is going to be broken down into their different chapters and sub chapters. So you are going to see exactly how that is going to work out. But I want you to create a folder first of all. So just click the open folder button and then I want you to navigate to where you want to place this tutorial. I'm going to go to my desktop and I'll create a new folder and I'm going to call it Python course. Python. Now, once you've created that folder, just press enter. Now, I want you to open that folder and click select folder. So once you hit select folder, Visual Studio Code is going to open that folder and we can get started with writing our first Python program. So I am just going to hit yes, I trust the authors. Now, once I do that, I'll close this welcome tab and then create a separate folder called chapter 1 because this tutorial is going to be separated into various chapters. Once the chapter has been created, I will just create a new file inside this chapter. In order to do that, you could first of all right click on the folder and click new file. Or the second way you could do is you select the folder and click this plus icon right here. And once you do that, it's going to bring out this field where you can type in the name of the file that you want to create. Now we're going to name this file first.py, first.py. So since we are going to be writing our first Python program, what we simply just want to do is we want to create the file first of all called first.py, and then we want to write our first program. Now, what exactly are we going to write as our first program? As a tradition in programming languages, once you're learning a new programming language, it's the tradition to just print hello world or display hello world to the screen when you start using the language. So in order to write our first program, we're just going to type print hello world. Sorry, print hello world. Now, once you do that, I want you to just hit save. So we have successfully written our first Python program. All we have to do to simply run it is just click this play icon. And once you hover over it, you can see run code is written. So just click the play icon, and then this terminal is going to open up where you see the results of your code. Now that it has run, you can see that we are successfully getting Hello World being printed out to the screen. Now, I also wanted to show you other ways of writing our program. Now, all through this tutorial or all through this course, we are mostly going to be executing our program by clicking this play button. And if you remember, the way we got this play button was going to our extensions tab. So it was by navigating to the extensions tab and searching for code runner. And if I just scroll down, this is a specific extension which we had installed. So after installing this extension, we got this play button. Now, this is the first way we would mostly be executing or running our programs in this course. I wanted to show you another way. So the second way you can execute your programs is you right click and scroll down, and then you see run Python. So when you hover over run Python, you can then go to run Python file in terminal. So once I click that, you can see that the file gets executed in my terminal and I can see the output. So we have successfully written our first Python program. Now we're going to move on to the next step. At this point, if you have any question, please feel free to create a new question below this course and I will reply you. In this section of this course, I am going to explain what variables and data types are. So the next thing that we need to do is first of all close this file, and then we need to create a new folder called chapter 2. Now remember that I had explained that each topic is going to be separated into its own individual chapter. So we're separating it this way so that everything is going to be arranged nice and clean. So you could come back weeks later and still understand the project as it took you from chapter 1 to chapter to whatever the last chapter is going to be, and each topic is going to be inside its own specific chapter. Now, once you've created chapter 2, what I want you to do is create a new file and call it variables.py. Variables.py. Now, we're just going to close this terminal window right here. Now, I am going to explain what variables are. So variables are basically a way for us to store data in our code. So they basically serve as a container or a placeholder to hold specific values in our code. So let's say, for example, I wanted to create a variable to store a person's name. I can say name is equals to Jane. Now, what we have done here is that we have created a variable called name and we assign this to a value called Jane. So therefore, the value of Jane is stored to is stored in the variable name. So if we ever want to access this value called Jane, we can reference it using the variable name. For example, I can just write a print statement to print out the name. So I can come here and say print name. Now, once I save that using Control S, I can just come here, click my run code button, and once I click run code, it's going to print out Jane for me right here. So you can see now that in order to reference the value of Jane, we had to access it through the variable name. Now, you might have some questions about how the print statement works. I understand, but don't worry, as we proceed in the course, we're going to cover every single area that needs to be explained. So I'm just going to remove this line. Now, it's good to note that variables can hold different types of values. For example, I could store a person's age. For example, I could create a variable and call it age, and I can equate it to 47. Now, it's the exact same principle that worked here, that works here. What we have done is that we created a variable called age, and we have assigned it using the equal to sign. We have assigned it to the value of 47. So an analogy that you could use for this is in like for mathematics students. When you want to solve for an unknown value, you can say let the unknown value equals x. Or for example, they could also give you a value like saying x is equals to 47, solve for x or something like that. So we're basically assigning the variable of age, or sorry, we're assigning 47, which is a value, to the age variable. So anytime we want to access 47, we have to make reference to the age variable. So for example, now, in order to access 47, I could also come down here and simply say print age. Now, once I type print age and I come to run it, you'll notice that 47 gets printed out in the terminal window. So a more explanation on the terminal window is that anytime you write your code and you want to run it, once you click run, the output basically gets displayed in the terminal window. So that is basically what a variable is. It just helps us to store some specific kind of data in our program, which we can access later on. So we created two variables called name and we assigned it to Jane. We created a variable called name and assigned it to Jane. And we created a variable called age and assigned it to 47. And if we ever want to access these values called Jane and 47, all we need to do is access them using their variable names because the variable names act like placeholders in our program. It is important to note that variables can be reassigned new values. So right here, I created a variable called name and equated this to Jane. I could also come down and reassign the variable called name to a different value. So for example, I can say name is equals to Solomon. Now what I have just done here is that I have reassigned the value called name to the value, I've reassigned the variable called name to a value of Solomon. So if I come down right now to print the value of name, let us see what it gives us. So once I run this code, you can see that it gives us Solomon. So why does it give us Solomon? Right here, we created a variable called name and assigned it to Jane. But we now came down here again to line 4 and reassigned the value of Jane and reassign the value from Jane to Solomon, which is why we see Solomon getting printed out here. So what we can do is we can add an extra print statement before the name variable gets reassigned. So as at this point, the variable name is assigned to a value called Jane, and we want to print it out. Then what we are now simply going to do is reassign that variable, and then we're simply going to print it out again to see the value. So let us save that, and we need to clear the terminal screen. So a shortcut that you can use to clear up your terminal screen is to type CLS. And once you type that, you can see that your terminal has been cleared. Now, all we simply just have to do is click the run icon. Now, once we click run, you can see that Jane gets printed out first, and Solomon gets printed out first. We see this because at this point, name was set to Jane, and then we printed out the value of name. But we now came down here to line 5 and reassigned name, the variable name, to a new value called Solomon. And then we printed out the name again. So that is why we see Jane printed out first, which is from here. And then after I got reassigned, we printed it again, which is why you see Solomon. So variables can be reassigned in Python. And so the next topic that we are going to talk about is data types. So I want you to go into chapter 2 and create a new file and call it data types.py. Now in Python, we have several kind of data types. Now I need to actually explain what a data type is before we proceed. A data type basically helps us tell Python what kind of data a variable is going to store. So for example here, we created a variable called age and we assigned it to 47. What we told Python is that we are storing an integer value, which is 47. We are storing that integer value in the age variable. So what that means is that age is storing an integer value. Now that integer value itself is a data type in Python. So we can represent different kinds of data using their data types in the Python programming language. If we look at this variable right here called name, it is assigned to a string. Now you might ask yourself, what is a string? A string is basically a sequence of characters. Now a character could be a single value like J, this could be a single value like a number like 9. But when you have a string of this, when you have a sequence of these characters, that is, you have a bunch of these characters which are joined together, that is when we now have something called a string. So a string is just a sequence of characters which have been joined together. Now in Python, when you want to create a string, you use these quotes. So let's head back to the data types file in order to proceed. So we have talked about the int data type, the integer data type, and the string data type. So if I want to store a person's age, I can create a variable and say age is equals to 180. Now what we're simply saying here is we are trying to store an integer value which is 180 in the variable called age. Now, this is for creating variables and assigning them to integer values. We could also create a variable and assign it to a string value, which we have talked about. So, for example, I could create a variable called car, and I can equate it to a car company like Toyota. Toyota. Now, I want you to take note of something. When you want to create a variable and assign it to a string value, you can do it in two ways. You can either use single quotes or double quotes, but you can never use a single quote and a double quote. So what I mean is, I can create a variable up here and call it country, and I can equate it to, let's say, Canada. If you look at this variable right here, or this string right here, it was created using single quotes. But if you look at the second string, it was created using double quotes. Now, these two approaches are perfectly fine, and you can pick whatever method you want. But what you cannot do is use one double quote and end it with a single quote. That will never work. It has to be one specific kind of quote that you use as the starting and the ending. As you can see right now, we are getting an error because Python is trying to tell us that this is breaking the syntax rules. So we can't use a double quote and a single quote. It has to be uniform, and we can only use a single quote or a double quote at the same time. Now, the next data type that we are going to talk about is the float data type. So right here, we talked about the int data type. So when we say 180, we're trying to assign age to an integer data type, but in Python, it's short for int. Now, in country and car, we created two variables and we assigned them to string values. Now, the short form is called str. Now, the next data type that we need to talk about is called the float data type. And the float data type basically just helps us to store floating point numbers, or you can look at them as decimal point numbers. So for example, I can create a value and a variable, and I can call it grade. And I can equate grade to, let's say, a student score in an exam. So I can say 70.89 or 70.6. Now, what we have done here is that we created a variable called grade, and we equated it to a value of 70.6. So you can see right now that in Python we can create variables and equate them to data types we can equate them to different data types. So here we have created a variable and equated this to 70.6, which means that we're able to store floating point numbers or decimal point numbers. Now, the final data type that we're going to talk about for now is called the Boolean data type. Now, the Boolean data type basically helps us to store true and false values. So what does that mean? Now, I can create a variable and I can call it uh, is human, and I can equate this to true. Now, because I am a human being, obviously, I am going to equate this to true. Now, what does this true mean? This true is a Boolean value. And in the binary sense of it, true represents 1, while false represents 0. So, for example, I could change this from true to false. Now, this is basically just a Boolean value. So true and false are both Boolean values, and we can store them in a variable. So this is just a different data type that we make use of in Python. And you are going to be making use of this Boolean data type a lot. In fact, you are going to be making use of all of these data types more times than you can count. So again, just to rephrase all what we've talked about so far, we've talked about the integer or int data type, which helps us to declare integer values. We talked about the string or str data type, which helps us to define or declare string values and assign them to variables. And we've also talked about the floating point. We've talked about the floating point or the float data type, which helps us to store floating point numbers or decimal point values. And we talked about the Boolean data type, which helps us to store true and false values. So if you have any questions so far, please feel free to ask. It is also important to note that Python is a dynamically typed language. Now, what does that mean? In a lot of other programming languages like C, C++, or Java, when you are creating a new variable, you have to specifically define you have to specifically define what kind of data type that variable is going to store. So if, for example, we wanted to create a variable in the programming language C, what we will do is we'll type int age is equals to the value of, like, let's say 20. Now, this is a way of creating a variable in a programming language like C, C++. You have to, first of all, declare what data type it is. Then you have to write the variable name, and then you have to equate it to 20. Also, if I wanted to create a string data type in C++, for example, I would say string of name is equals to, and then here I could say like is equals to Solomon. Now, this is a way of creating a string data type in Python, in C++. Now, notice that we had to first of all declare what data type it was. Then we had to create the name, type the name of the variable itself, and then equate it to the actual value. Now, this is what you call a strongly typed language, where you have to first of all declare what kind of data type the variable is going to store. But Python is a dynamically typed language. Now, what does that mean? When we declare a variable and say age is equals to 180, Python automatically is going to detect the type of the data. It's going to automatically detect the data type. So we don't have to always declare what kind of data type a variable is going to hold. We can just create a variable and equate it to any value we want. So for example, here, Python has already detected that we are storing an integer value in the age variable. Also here, Python has detected that we are trying to store a string value in the variable country. Here, Python detected we are storing a floating point number in grade. And lastly here, Python detected that we are storing a Boolean value. Inside this is human um, inside this is human variable. So Python is a dynamically typed language, and you don't have to specifically declare it, or you don't have to explicitly declare the data type which we are trying to assign to a variable. In this section of the course, we are going to talk about something known as comments. So I want you to just create a new file in chapter 2 and call it comments.py. So let's talk about what comments are in Python. So comments are basically notes in our code which get ignored by the Python interpreter. So it helps for documentation purposes. Now, what exactly does that mean? So let's say you've written a piece of code and you want to explain what that piece of code does. What you can do is you can leave a comment, like a description message or text on that piece of code. And the Python interpreter is going to ignore that specific line because it sees it as a comment. So I will give you an example. So let's say we create a variable called name, and we say name is equals to Solomon. What I can do is, if I want to explain what this line of code does, I can write a comment to explain what this line of code does. So it helps in documentation and explaining. Now, there are two types of comments. The first type is the single line comment. And in order to write a single line comment in Python, all you do first of all is put in the hashtag symbol. Now, once you put in the hashtag symbol, any single thing that comes after this hashtag symbol automatically becomes a comment. So I can write a description. I can say the code below creates a variable called name and assigns a value to it. Now, once you look at this comment, you can see that it is a description as to what this line of code does. It just says the code below creates a variable called name and assigns a value to it. So this is a way of writing descriptions and documenting your code because you might run into a lot of cases where you are working with several other developers or several other programmers, and then you are going to be reading programs and code that even other people wrote. Now, it is very helpful when you have descriptions in the code like this, which help to explain what some piece of code does. Now, I can print out this name just to prove that the Python interpreter is going to ignore this first line. So I can just come down and print name. So once I run this, you will see that Solomon gets printed out. So Python completely ignored this first line because it just saw it as a comment. And the Python interpreter ignores comments because it is seen as a way of documenting code. Now, a different thing or a different approach that you could even use comments for is, let's say, for example, you have a piece of code that you've written, but you don't want to necessarily delete it, or you just don't want it to run. What you can simply do is you can comment it out. So you can just put the hashtag in front of that piece of code, and this automatically becomes a comment, and Python doesn't run it. So once I run the program, you'll see that nothing gets outputted because we had commented out this print statement. But the moment I remove it and click run, you can see that Solomon gets printed out. So that is basically what we can use a comment for in Python. Now, the second type of comment that I would like to show you is the multi-line comment. So if you look at this is a very long comment. And in order to view the rest of it, I have to slide right. As you can see, I have to slide right to see the rest of this description. Now, that isn't very helpful because imagine the comment is very long. Like it could go on and on and on, and you have to keep sliding to read each line. I'm sorry, to read the entirety of it. But an easier way to do it, or a more legible way to do it, if you are going to be writing a lot of documentation, a more logical way to do it is to use a multi-line comment. So I'm just going to create a few variables here, and I'll call this adult is going to be equals to true, and I'll say grade is equals to 78.6, and then I'm going to say balance is equals to, let's just say, 1,000 to represent like $1,000. Now let's say I wanted to write a comment for these three lines right here. I could technically use a one-line comment to do it, but that would be a very long comment, and I want everything to look very nice and formatted. So because I'm going to be writing a lot of comments or a lot of documentation for a piece of code, what I will simply do is use a multi-line comment. Now, the way we create multi-line comments in Python is we type out 6 quotation marks. So it could be single quotes or double quotes. Now, I'll show you an example and I'm going to use double quotes. So you type out 1, 2, 3. Now, the moment you type out the third one, you see that Python automatically, you see that the remaining 3 quotes gets automatically generated. Now, once you've typed out these 6 quotes, I want you to go to the middle of the 6 quotes and press enter. Now, whatever thing that you write within these quotes becomes seen as a comment by the Python interpreter. So for example, now I could write a comment right here and I could write a comment right here describing what these 3 lines of code does. So I can say the code below, I can say the 3 lines of code below basically help to define a few variables and store certain values. Now, if you look at this form of documentation or of comments, you can see that we're able to write multiple lines within these quotes. And anything that is within these quotes automatically gets seen as a comment in Python. So the Python interpreter is just going to completely ignore this line. If we wanted to write this in a single line, we would have to do this, and then we would also have to do this. So you can see that in order to see the remainder, we have to keep scrolling just to see the remaining documentation or the remaining comments. So it is just better, it's just a better practice to use a multi-line comment anytime you are going to be writing a description for something which is really, really long. So it just makes more sense and it's cleaner and easier to read that way. So these are the 2 types of comments that we have in Python. Now, I would like to show you a shortcut if you are using Visual Studio Code. Remember that I had explained earlier that if you do not want Python to run a specific piece of code, or if you want the interpreter to ignore it, all you have to do is just simply comment it out. So I could come here and put a hashtag, and then this gets commented out. Now, if you want to do it using a shortcut, all you have to do is place your cursor at the point where you want to comment out. And if you're on Visual Studio Code, this is the only way this works, by the way. I want you to hold Control and /. Now, once you hold those 2 key combinations, you can see that it automatically gets commented out. Now, I can do the same for multiple lines. All you have to do is select all the lines you want to comment and just Control /. And you can see all of these lines have been commented out. So this is exactly how we can write comments in Python. It is also important to note that you can write comments right beside an expression. So for example, I can write a comment beside this print statement. And I can say this is a basic print statement. So once we run this file, Python is going to completely ignore this comment right here because again, it sees it as a comment. So what I can do is I can just simply run this program and you will see that Solomon gets printed out. So Python completely ignored every single comment. So that is all we're going to talk about in this section. If you have any question, please feel free to ask. In the next section of this course, we are going to talk about variable naming conventions. So I want you to create a new file inside chapter 2 and call it naming_conventions.py. Now, after doing that, I would just like to explain what variable naming conventions are. So variable naming conventions are basically rules that we need to follow when we are creating variables in our program. Now, these naming conventions are going to cut across just variables themselves. As we proceed, we are going to talk about things like functions and classes. And we are going to see that these naming conventions also apply to functions and classes. You don't need to understand what functions and classes are now, as we're going to talk about them further in this course. Now, the first thing that I would like to explain is that when you are creating a variable, you can't start that variable name with an integer. So for example, I can't create a variable name and call it one car is equals to like Camry. Now you can see that uh, Python is already giving us an error because we can't start a variable name with an integer. So that is going to give you an error. What we can do, however, is we can have that specific integer come after the first letter declaration. So that one can come here. We can put the one here. We could even put it in between as you are seeing here. But you can never start a variable name with an integer as that will give an error. Now, we are going to discuss a few variable naming conventions. Now, the first convention that we are going to discuss is called the snake case. Now, for the snake case, this is when words are lowercase and are separated by underscores. Now, these are commonly used for naming variables in Python, and you will see them a lot. In fact, as you proceed in your Python journey, you'll probably use snake case usually or more. Now, in order to use a snake case or demonstrate how to use a snake case, let's say, for example, I wanted to store the first and last names of a user. So in order to create two variables that are going to store these names, I'm going to write the first variable called first underscore name is equals to John. And then last underscore name is equals to Do. Now, once you look at this, you see that all the words in the variable are separated by a single underscore. So we have first underscore name, and then we have last underscore name. So using snake case, every single word in the variable is separated by a single underscore. Now, there's something I would like to explain. It is good to note that you cannot create a variable that has space in between. As you can see, it's already giving you an error. The variable must be connected together and form a single like name. And we can connect it using an underscore, which is called the snake case. So if you want your variable to have multiple words in it, you can just separate it by underscores. So I could add more words. For example, I can say first name of user. So you can see that all of this is still, all of these are words separated by underscores, and they are a valid, and they come together to form a valid variable name. So we cannot separate each of these words using white space. So white space is basically this empty space that exists in the program. So we cannot separate it using white space because we are going to get several errors. So this is the first naming convention that we are going to discuss. Now, there's also something I wanted to let you know. When you are creating a variable, it is very, very important that you give your variable name. It's very important that you name your variable something that makes sense and is readable. So, for example, if somebody looks at this first line, they know that John is going to be the first name of a specific user because the variable is called first name of user. But if I were to replace this first name of user with a variable like X, once you say X is equals to John, we understand that we're trying to store the value of John in the variable X, but we don't really understand the relevance of X. So where we now specify the relevance is when you give the variable a very descriptive name. So once I do first name of user, you immediately understand that John is the first name of a specific user that you are working with. So it is very important that you always give your variable names very descriptive names. Now, there's also something that I would like to explain. A variable name, like I said earlier, can't start with a number. If not, you get an error. But what it can start with also is an underscore. So you can start a variable name using an underscore. That will still work properly and it won't give you an error. So that is just what I wanted to explain. So I'm going to write a comment here and I'm going to explain that this is a snake case variable naming convention. So you can see that we can start making use of comments to write descriptions in our code. So I will just say below is an implementation of the snake case convention. So when somebody reads this code, they are going to see this description explaining that the two lines below are just basically how to implement the snake case variable naming convention into your program. So a lot of times, this is the variable naming convention that is preferred in Python. Now let's move on to the next variable naming convention. So the next one is called the camel case. So in camel case, the first word of the variable, the first word in the variable is lowercase, and the subsequent words are capitalized. So let's just give an example. If we wanted to use a camel case, sorry, to create this variable, what we would say is first name is equals to uh, John. Now let's analyze it. The first word of the variable has everything in lowercase, while the second word of the variable is the first letter is capitalized, so it's in uppercase. So anytime you want to create a variable using the camel case, all the letters in the first word are always going to be lowercase, while subsequent words that come after are going to have their first letters capitalized. So let's say, for example, I wanted to add more words. It would be first name of user. Note that every single word after the first word has their first letter capitalized. So name has the N capitalized, O is capitalized, and U is capitalized. So this is the camel case naming convention. So I'm just going to write a comment here, camel case convention, right? So I would also encourage that you do the same so that when you come back, you can understand exactly what each naming convention is. Now, this naming convention isn't really popular in a language like Python, although it's popular in programming languages like Java. So in Java, you would typically see something like this. So we are going to move to the next naming convention, which is the Pascal case. So I'll just write a comment and I'll call it Pascal case convention. Now, in the Pascal case convention, every word in the variable starts with a capital letter or an uppercase letter. So let's say, for example, I wanted to, again, create this variable, but using the Pascal case. What I am simply going to write is first name of user, of user, and this is going to be equals to John. Now, if you take a look at this, every single word in this variable has their first letter to be capitalized or to be uppercase. So the only difference between Pascal case and Camel case is that the first word in Pascal case is capitalized. Sorry, the first letter of the first word in Pascal case is capitalized as with every other word. But the Camel case, the first letter of the first word is lowercase, unlike every other word in the variable. So these are the three basic variable naming conventions that we are going to talk about. So for this Pascal case that we see right here, it is mostly used when you want to create a new class in Python. But you don't need to understand what a class is right now, but we are going to understand eventually. I just wanted to drop that there. So these are the naming conventions that we are going to learn about in this section of the course. Now, I also wanted to mention that for these naming conventions, for this theory that we talked about, only two are majorly used in Python. And the major two which are used in Python are the snake case and the Pascal case. Now, the snake case is typically used for when you're creating variables or function names. For example, when I wanted to create a variable here, I made use of the snake case. So when you're creating a function or a variable, the snake case is usually used. But the Pascal case is usually used when you are creating a class in Python. Now, you don't need to understand what a class is right now, but we are going to discuss it eventually in this course. But I just want you to have it in mind that the two main naming conventions which are used in Python are the Pascal case, which is mostly used in declaring classes, as well as the snake case, which is mostly used in creating or declaring variables and functions. In the next section of this course, we are going to look at type conversion, and we're also going to look at basically how to change the data type of a value. So what I want you to do is create a new file and call it type conversion, type underscore conversion dot py. Now, first of all, what we are going to do is we are going to declare three variables. I'm going to say age is equals to 37, name is equals to John Doe, and then balance, like for, or no, let's say height. Height is equals to 7 points, or let's say 6.2. So let's just assume this is 6 feet 2 inches. Now, what I want to show you is exactly how to check the data type of a specific value. So right here, we have assigned, we have created a variable called age, and we assigned it a value of 37. Now, to us humans, we can easily just look at this and say, okay, yes, 37 is an integer, and we have assigned an integer value to the age variable. But there is also a way to programmatically determine what kind of value has been assigned to a variable. Now, this is an inbuilt function or an inbuilt method that Python provides us. Now, you don't really need to understand what that means for now, but we're also going to look at it in a future video. But I just want to show you that we can actually check the data type of a specific value. So what we are going to do right now is we are going to check the data type of the values that have been assigned to each of these variables. So what I will say is print, after typing in print, in between the parentheses, I want you to write type. And inside type, I want you to pass the age variable. Now, you don't really need to understand what type is for now. But all I'll tell you for now is that it is an inbuilt function or an inbuilt method that Python gives to us. And what it basically does is that it takes a variable or a value and it returns what kind of data type it is. Now, let's say, for example, we wanted to check the data type of the age variable. We wanted to check the data type of the value assigned to the age variable. This is exactly what we need to do. So once I run this program, you are going to see that it gives us a class int. So what exactly does that mean? Python is telling us that this variable called age belongs to the integer data type. It's an integer data type, I mean. So that is exactly why we see the class of int. So you don't really need to worry about what this class means. What you need to focus on is what comes after the class. So it's just trying to tell us that the value assigned to the age variable is an integer. So let's clear out my screen and do the exact same thing, but for the name variable. I'm going to replace this with name because we want to print out the data type assigned to the name variable. So once I run this file right now, we are going to see that str gets printed out. So that is because the value that has been assigned to the name variable is a string data type. So that's why we see str when we print out the type of the name. Now, lastly, we're going to check for the height. So I'm just going to say print the type of height. So once I save that and come back here to run this program, you are going to see that it gives us a class of float. So that's just trying to let us know that a floating point value, or if a value that is that has the floating point data type, has been assigned to the height variable. Now we could also create a different variable to store a Boolean value and get its type. I'm going to create it and I'll say is adult, and I'm going to equate this to true. Now I'm going to print out the type of is adult just to show you what this gives us. So once I run it, you can see it gives us a class of bool, which is short for boolean. Now remember that I had explained that boolean values are either true or false. So that is why it gives us a class of bool, because is adult is storing true, which is a boolean value. So now that we understand exactly how to get the data types of specific values assigned to variables, what we simply now need to do next is we are going to talk about how to convert specific data types, how to convert values from one data type to the other. So for example, now, let's say we wanted to convert um, a a floating point number to a whole number, like an integer. We can definitely do that using some inbuilt keywords or inbuilt functions that Python gives to us. Now, again, you don't really need to have a clear picture of what a function is, but you are going to understand it eventually as we are going to talk about it. So what I will just do is I will just write a comment here, and I'm going to write getting the data type of a value. So I will not erase it. Now, what I will just do next is I'm going to show you how to convert an integer to a floating point number, how to convert a floating point number to an integer, and how to even convert a string to both integer and floating point numbers. So basically, we can pretty much convert every value from, we can be pretty much convert floating point values, floating point values, integer values, and string values. We can convert all of them between each other. So what I'll do is I am going to first of all show you how to convert a floating point number into an integer. So what I will do is I will create a new variable and I'll call it new height. And I'm going to equate this to int. And inside this int, I am simply going to pass in height. Now, what exactly are we doing here? We have created a variable at the top called height, and we assign this to a floating point value of 6.2. Now, what we want to do is we want to convert this 6.2 into an integer. So I created a new variable and called it new height, and I equated this to the int function or the int method. This is inbuilt, it comes with Python. And then all we simply need to do is pass in the value that we want to convert to an integer. Now, because the value 6.2 has been assigned to height, we're just simply going to pass in height. So what I will do after this is I will print out new height just to show you that the conversion worked successfully. So I am going to run this program. And once I run it, you can see that 6 is getting printed out. So 6 is getting printed out because Python took this 6.2 and converted it into a whole number, an integer. So it's basically stripped the point 2, which was assigned to the floating point number before. So this is basically a how to convert a floating point number to an integer. And we could also do the same. We could do vice versa. So what we can do is we can convert a an integer into a floating point number. So I can come down here and say new age is equals to float, float, float of age. So what we're simply just doing here is we're trying to convert this age into a floating point number. Now, since it is 37, once we convert it into a float, it should return back to us 37.0. So what I will just do is I will come down and print new underscore age. Now, once I save that and run it, let's see what it gives us. So I have an error here. So my bad, this is meant to be opening and closing parentheses. Now I'm going to clear the screen and run this program again. Now, once I run it, you can see that it gives us 37.0. So we are sure exactly that the conversion is working between integers and floats. Now, there is something else that we could do. We can we can convert strings into integers and into floats. As long as the value contained within the string is a numeric value. So I'm going to explain exactly what that means. So proceeding with converting a string into an integer or a float. Like I said earlier, it will only work when the value in the string is a numeric value. For example, if we try to convert this name variable right now to an integer, it is going to give an error because there is no single value in this string that is an integer. So in order to convert a string into an integer, all the values in the string has to be numeric values. So I can just create a new variable right now and I can call it car year model. Car year model. And I can equate this to a string and type in 2024. Now, because all of these are numeric values, I can now come down and say new model is equals to the int of per year model. Now, once I do that, I can print out new year, I can print out new model. Now, once I save that and run this program, you are going to see that we get 2024 getting, we have 2024 getting printed out. So as at this point, we were successfully able to convert the string 2024 into an integer. Now we could also do the same for float. So we could convert this into a float instead of an integer. So once I run this program, you see that we get 2024.0. So it was successfully able to convert this string into a floating point number. Now, if for example, I decided to add a letter, like any random letter, once I save this and try to run, you'll see that we get an error because it says could not convert string to float. So the reason why we're getting that error is because these characters are not numeric values. So the only way we can successfully convert a string to an integer or a float is if the values are actually if the values in the quotes are actually numerical values. Now, lastly, I am going to teach you how to convert a floating point number or an integer number into a string. Now, just like how we've been converting between integers and strings, we also have an inbuilt function to convert values to strings. Now, let's say, for example, I wanted to convert this age into a string. What I can just do is I can come down and say uh, age to string, age to string is equals to str of age. So what we're just simply doing here is we are getting this age and we're trying to get the value of age, which is 37, and then we're going to convert it into a string, which is by using the str inbuilt method or inbuilt library. So Python gives this to us by default, and we are able to convert we're able to convert values from one data type to a different data type. In this section of this course, I am going to teach you about input and output functions in Python. So most especially, we're going to be discussing the input function, which helps us ask the users for data. So users are going to be able to input data into our program. So what I want you to do is create a new file inside chapter 2 and call it input underscore output dot py. Now, once you do that, I would just like to briefly explain. Now, remember that when we had been working with variables, all we had to do to declare a variable was just write the variable name and equate it to the specific value. But here, all we're doing was we were declaring these values directly in the code. But what if we wanted a situation where we wanted a user to impute these values themselves? Now, what we can do is we can make use of the input function, which is inbuilt into Python. It helps us collect data from the user or collect input from the user. So let's say, for example, we wanted to store the name of a person. All we are just going to say is name is equals to John Doe. And then we could come down and just print that name, right? So once I run this program right now, you'll see that the name gets printed out, John Doe, as you can see. Now, what if we wanted the user to impute the name themselves? Well, all we're just going to do is we're going to make a simple change. Now, once we say name, once we type the variable name called name and we put the equal to sign, all we're simply going to do is type in input. As you can see, Visual Studio Code is already suggesting it for me. So you can see that this is an inbuilt function. Again, we are going to discuss exactly what functions are, but I want you to just follow on with me and you understand this eventually. So once you type in input, now what exactly do we want to now put inside this input? What you need to do is you need to display some text which the user will be prompted by. So what I mean is when you go to a website and you want to log in, you are going to see an input field. And in the input field, you are probably going to see a placeholder that says enter username or enter password. Now we want to do the exact same thing here, and all we're just going to say is enter name. Now, whatever text you write in here or whatever string you write in here is going to be displayed in the same format in the terminal. So I'm just going to save this right now and we are going to run it. Again, if you want to collect inputs from the user, you first of all have to create a variable that is going to store whatever the user has entered. Then once you create a variable, you equate this to the input built-in method or function. Now, once you do that, you are just going to open this parentheses. And inside the parentheses, you have to put your quotes there. And after you put your quotes, you have to like enter a prompt text, which will tell the user exactly what they are inputting. So once I save that and run this program, you are going to see that the program is asking me to enter my name. So I'm just going to enter like the Ayodeji. Now note that in the program we had already written this line of code to collect the name from the user. Now, all we're simply doing next is we are printing that name. And once I type IODJ, I'm just going to hit enter. Now, once I hit enter, you can see that the name has gotten printed out in the terminal. So how exactly, or what exactly happened here, you might ask? The moment you type in any value into this input, the value gets assigned to this variable, to whatever variable you have equated the input function to. So when I imputed IODG, that value got assigned here to the name variable as a string. Now, this is very important. I want you to note that anytime you are making use of the input method, it always collects inputs from the terminal as a string data type. So if, for example, you wanted to collect a number if you wanted to collect a number from the terminal, what you are simply going to do is you can either do it in two ways. You can wrap this entire input function inside the integer function, which we had talked about in type conversion. So you could either do this, or the second way to do it would just be to come down and let's say you could even create a new variable and call it new name or something, and it's equals to the int of name. Now this will still perfectly work. Now to show you that this collects data as a string, what I will just do next is I'm going to print type of name. Remember, this type is coming from the last lecture where we talked about type conversion, and it helps us know exactly what data type a value is. So once I run this program right now, we're going to see that it says enter name. So I'm just going to enter Solomon, for example. So you can see, okay, Solomon. You can see Solomon gets printed out, and we can see that it is a class of str, indicating that it is a string which was entered. Now, again, I said that we could always convert this into an integer. So if, for example, I wrap this around the int method, once I clear my screen and run it, once I enter a number like 7, you can see that it says class of int, because the moment that value was entered here, it was then converted into an integer using this int method. So we could also convert this into a float if you decide to. So we could wrap this in a float method. Now, if we do something like this, I want you to note something. Once I run this program and I enter something that is not a numeric value like Solomon, I want you to notice how the program crashes. So the program crashes. It says value error, invalid literal for int with base 10 Solomon. So what that means is that the int keyword got a string as an input, which it can convert a string to an integer from what we had talked about in the last class. But the string has to be or has to contain all numeric values. So because I entered Solomon, Solomon is not a numeric value, or all the characters here are not numeric values. That is why it crashed. Whereas when we enter 7 or any other number, it is going to run properly because all the values in the string are numeric values. So this is basically how to collect inputs from the user. All you have to do first of all is you type in the name of the variable, right? you type in the variable name, and you equate this to the input method. And inside this input method, you just type in the text that you want to be displayed that prompts the user. So for example, I can say enter your full name. So once I save that and run this program, you can see that it says enter your full name. So whatever text you type in here becomes the prompt that gets shown in the terminal. So I can just say Ayodeji Solomon Adeshola. So once I press enter, you can see that that name gets printed out because we had told this to print those values here. Now, the next thing that I would like to explain to you guys is the output function. And we have been using this since we started this video pretty much, and that is the print function. So the print function basically, as you have seen, helps us output or display or even print data to the terminal window, as you can see here. So anytime you use the print function, it's going to take whatever value you pass into it, and it's going to print it out or display it in the terminal window. So I'm going to show you a few things that you can actually do with the print function. There is something I would like to explain before we proceed to using the print statement itself, and that is what I call a formatted string. So I'm just going to come down here and I'll create a new variable, and I'll call it introduce. And this is going to be equals to, hi, my name is Solomon. Now, I created a variable called introduce, and it simply says, hi, my name is Solomon. So I will just comment these two out for now, and then I will just print out introduce. So once I do that, I will run the program. And what do you see? Hi, my name is Solomon. Now, there's something that we can do called a control string or a formatted string. Here we have the name statically defined, or what that means is that it is permanently defined in the program. Now, what if we wanted to dynamically pass in the name of somebody? So once the program runs, it's going to ask you to enter your name, and it's just going to say, hi, my name is your full name. Now, there's something called string formatting. Now, string formatting helps us pass in variables into a string which has been declared. Now, I'll show you exactly how we can do that. So what I will do next is create a new variable here at the top. I'm going to call it Solomon. Now, once I type Solomon here, name equals Solomon, what I can then do is I can come down here to introduce and format this string. So all you simply have to do is type F right beside the string that you are trying to format. Then once you type F, what you are now going to do is open this, type this open and closing curly bracket, and you pass in the variable that you are trying to add there. So I'm just going to pass in name. So what Python is going to do is it's going to come here and say, okay, this guy has declared a variable called name and assign this to Solomon. And it's going to come to line 6 and say introduce. And it's going to see that you are trying to format this string because you have used this F keyword, which stands for, the string formatter. So it's going to say, hi, comma, my name is name. So it's going to take whatever value has been assigned to this name variable, and it's going to put it in here. So let's just run this program to see how it does. So once I run it, you can see it says, hi, my name is Solomon. So we could even change this to say Solomon Grundy, for example. Now, once I run this program, you see it says, hi, my name is Solomon Grundy. So what that means is that we can pass variables into strings as we have just explained. And you can pass in any number of variables that you want. So I can create a new variable and I can call it age and say age is like 39. And then I can come here and say, hi, my name is name, and I am curly bracket age years old. So what Python is going to do is it's going to come here and say, hi, my name is, then to grab the value from name, and I am age, to grab that value from age and say years old. So I'm just going to clear the screen and run this again. So once I run it, you can see it says, hi, my name is Solomon Grundy, and I am 39 years old. So that's just what I wanted to talk to you about using string formatting or string formatting. Now that we know how to format strings in Python, what I will just do is I will first of all remove this value or this variable, and then I will remove this variable also, and I will remove this print statement, and I will uncomment this. So now what we want to do is we want to write a program that will ask the user for their name, their age, and their, let's just say, country of origin. And it's going to print out, hi, my name is name. Okay. Let's just write the format that is going to print it out in. It's going to say, hi, my name is name, and I am, and I am, let's just say, for example, 78 years old, full stop. Then you now say, I am from country. So it's going to dynamically pass in the name, the age, and the country that user is from. So what we want to do first of all is that we want to write 3 input statements that help to collect this data from the user. So we're collecting the name here. All we simply need to do next is collect the age. I'm going to say age is equals to input, and in here I'll say enter your age. And after saying enter your age, I'm going to say I'm going to create a new variable and call it country. And I'll equate country to input, and I'll say enter your country of origin. Now we have created these 3 input statements. All we simply need to do next is we need to create a string which will combine all of these into one formatted string, and then we can print it out. I'm going to create the variable and call it introduce is equals to, I'll type in the F keyword because what we want to do is we want to format the string. It's going to say, hi, I am, hi, my name is name. Now remember, we're getting this name variable from here. And then what we're simply going to say next is, uh, and I am age years old, full stop. Then I am from country. So all we're simply doing here is we're trying to create a formatted string, which is going to grab all of these values and put them into a full string or a full sentence. So all we're simply going to do next is print introduce. So I will run this program right now just to see what we have. So enter your full name. I'll just say Ayodeji Solomon Ishola. And then enter your age. I'm just going to say like 89. And enter your country of origin. I'm going to enter Nigeria. Now, once I enter all of these values, you can see that it says, hi, my name is Ayodeji Solomon Adishola, and I am 89 years old, full stop. I am from Nigeria. So this is exactly how to create a control string, and this is how the print method or print function works. Now, something else that you can do is, instead of directly passing in the variable name, what you could do is you could just take this entire expression, right? So let me copy that, and I could pass that entire expression into the print statement, and this will still work. So let's run that again. I'll just type in like test details, 67, Russia, and it says, hi, my name is test name, and I am 67 years old. I am from Russia. So the print statement itself doesn't just take in variables. The print statement, as you can see, it can also take in strings and what's it called, strings and expressions to print out. So I'm going to explain more on what I mean by expressions in a later video. But I want you to understand that the print statement just basically helps us output data to the terminal screen. And it doesn't just print variables, it can also print formatted strings and even more complex data types, as you are going to see in future videos. So that is all we're going to talk about in this video. If you have any question, please don't hesitate to ask a question below. In the next section of this course, we are going to, or the next chapter rather, we are going to be talking about operators in Python. So what I want you to do is create a new file or a new folder, I mean. So just head to your folder section, and then we are going to create a new folder called chapter 3. Now, inside chapter 3, I want you to create a new file called arithmetic operators.py. So arithmetic, arithmetic underscore operators.py. Now, let me talk about operators a bit. So there are four operators that we are going to be talking about in this Python course. We're going to talk about arithmetic operators, then we're going to talk about comparison operators, then we'll talk about logical operators, and finally assignment operators. So operators in Python just allow us perform some very specific important tasks. And the first one that we're going to talk about is the arithmetic operators. So they are used to basically perform, like mathematical operations. From the name arithmetic, they used to perform arithmetic operations like addition, subtraction, multiplication, division. Now there are also some extra arithmetic operators that we are going to talk about, and that is the modulus operator and the exponentiation exponent. Let me just call it the exponent operator. So that will help us perform exponentation of numbers. So like think 2 raised to the power of 3, 6 raised to the power of 13, so things like that. Now, the first arithmetic operator we're going to talk about is the addition operator. That is, like pretty straightforward. Now, what I will do is I'll create a new variable and call it addition, and I'm going to equate this to, let's say, 5 plus 6. So what we have done here is we have created a variable and we have equated this to the summation of two numbers, 5 and 6. Now we can just simply come here to print out the addition of, we can just simply print out the addition of these two numbers. So once I run this program, you see that it gives us 11 because 5 plus 6 is indeed 11. Now note that you could also create two variables to separate this. So I can say first number is equals to 5, and then second underscore number is equals to 6. And you can now create a new variable and say addition is equals to first number plus second number. So this is still perfectly okay. And once I run it, you can see it still gives us 11 in the terminal. But for the sake of this tutorial and to make the program short, instead of constantly creating variables for this, what I will just do is I will write the expression itself inside the print statement. Now remember that in the last tutorial, I said that we can pass in expressions directly into the print statement. Now that could be an arithmetic expression or even a logical expression. Now the arithmetic operation or expression that we're going to pass into the print statement right now is the addition of two numbers. So you can just simply say print 5 plus 6. And this is a valid expression. So once I run this, you can see it also gives us 11. So this is the arithmetic operator. So I'm just going to write a comment here. I'll call it arithmetic operator. Now the next operator that we're going to talk about this is the addition arithmetic operator. So I'm going to say addition space arithmetic space operator. The next operator that we are going to discuss is the subtraction arithmetic operator. So it's, we're just going to talk about the basic arithmetic operations that we can perform. I'll just write a comment here first of all, and I'll call it subtraction arithmetic operator. So all we're simply just going to do here is we're going to print out something like 10 minus 8, for example. Now, once I run this program, you see that we have 2 being printed out because 10 minus 8 is indeed 2. Now, this can also perform operations where the lesser number is subtracting the larger number. So once I run this, let's see what it gives us. You can see it gives us minus 80 because 10 minus 90 is indeed minus 80. So that is the subtraction arithmetic operator. Now, the next one we're going to talk about is the multiplication arithmetic operator. So I'll just write that here, multiplication. Okay, this needs to be a comment. Multiplication arithmetic operator. So this is pretty much the same thing. So I'm just going to print out, let's just say 50 multiplied by 46, for example. Now, once I clear my screen and run it, you see that we're getting 2,300 getting printed out. So that shows that we can perform arithmetic operations, sorry, multiplication arithmetic operations on different numbers and different values. Now, I want you to note that we could also add a different number here. So we could add 70 here. We could even add, like an extra number here and an extra number here. It's just going to perform everything at once. So it's not just limited to only two values. You can do as many values as you want. And once I run it, you can see we're getting we're getting these values printed out in the terminal. Now, the last basic arithmetic operation that we're going to talk about is the division arithmetic operator. So we're just going to write that here as a comment, and I'll call this division arithmetic operator. Now here, this just basically helps us to divide two numbers together, as you already know. I'm just going to print out the division of 100 by 10. Now, once you run this, it's just going to give us obviously 10 because 100 divided by 10, 10. Now, notice that it returns the value to us as a floating point number. So the division will always return to us the result as a floating point, as a floating point data type result. So anytime you pass in a number like say 200 divided by 10, that will return 20.0. Now, I'm going to move on to two other arithmetic operators, which aren't among the basic operators that we have discussed. Now, the next one we're going to discuss is the modulus operator. Now, what the modulus operator does is that it returns to us the remainder of a division. So once you divide two numbers, it's just going to return to us the remainder. So I'm just going to print out the modulus of two numbers. And I'm going to say modulus of 100 percent sign 10. So if you want to use the modulus operator, all you have to do is pass in the percentage sign. And Python is going to see this as the modulus operator. So once I clear my screen and run it, let's see what gets printed out. You see that we have 0 getting printed out because 100 divided by 10 is, obviously 10 and there is no remainder. But if I were to divide 100 by, let's say 17 now, we are sure to get a remainder. So let's run that. You can see we get a remainder of 15. So that tells us that 100 divided by 17 is going to be that's like 85, leaving a space of 15, leaving 15 as the remainder. So the modulus will always return to us the remainder of a division. Now I'm just going to write here modulus arithmetic operator. Now, the last one that we are going to discuss is the exponentiation. I hope I'm pronouncing that right. So it just helps us basically perform the exponent of two values. So let's say we wanted to perform the exponentation of 2 raised to the power of 3. What I would do is I am going to print out 2 double multiplication sign 3. Let me just put space between them here. So 2 double multiplication sign 3. And once I run this should give us 8, as you can see. So what Python does here is that it performs 2 raised to the power of 3. Now I can perform another popular one like 4 raised to the power of 2, which is 16. And once I run that, you see we have 16 getting printed out. So this basically helps us to just perform exponent calculations on numbers. I'm going to just put this as exponents arithmetic operator. So all these are really important and you are going to be using these a lot as you build on in like your Python journey. So these are very important, and I want you to take note of this modulus especially, as it is quite important. You might not use it as often, but it comes in handy a lot. So that is all we are going to talk about for the arithmetic operators. If you have any question, again, feel free to ask and I will reply you. The next operators that we're going to talk about are the comparison operators. So what I want you to do is create a new file inside chapter 3 and call it comparison. Comparison underscore operators .py. Now, once you've done that, just open the file. Now, you might ask yourself, what exactly is a comparison operator? Well, comparison operators are operators that are used to compare values. So they return either true or false, depending on what values we are comparing. So they return Boolean values, either true or false. So let's see examples, and let's look at the first example. So the first one that we are going to check is the equality comparison operator. So this operator helps to determine whether two values are the same or if two values are equal. So let's look at it. So first, what I'm going to do is I am going to print the equality of two values. So let's just say print 5 double equals 6. Now, in order to use the equality operator, we use the double equal to sign. So what this does is that it checks if the two values are equal to each other. Now, if they are equal to each other, it's going to return true. But if they are not equal to each other, it's going to return false. So let's run this. Now, once you run this, you can see that it gives us false because 5 is not equals to 6. But the moment I change this from 5 to 5, from 6 to 5, and I save it, let's see what it gives us. Once I run it, you can see that we get true right back. So what the double equality operator does is that it just compares the two values on the left and the right. So that's exactly what we're doing here. Now we could also create a variable here and call it is equal and equate this to 5 double equals 5. And what we can do is we can just print out is equal. And this will still give us the exact same result. So if I run this right now, you can see that it still gives us true because we are storing the expression, we're storing the value of 5 double equals 5 inside this is equal variable, and then we're printing it out. So remember that I had explained that we can just directly pass in expressions into the print statement. So this is exactly what we are going to do to make the code shorter. So I'll just write a comment here and I'll call this the equality comparison operator. Now, after doing that, the next operator which we are going to talk about is the not equals to operator. So what this operator just basically does is that it checks if two values are not equals to each other. If those two values are not equals to each other, then it returns true. But if they are equals to each other, it returns false. So you might be confused, but let's look at it. So I'm going to print 5 is not equals 6. Now, what do you think this is going to give us? You can take a pause and think about it. By printing 5 is not equals to 6. So anytime you want to make use of the not equals to operator, you first of all type your exclamation mark and then you put the equals to. So together they symbolize not equals to. So once I run this, you can see that it prints true because 5 indeed is not equals to 6. So this prints true. But if I were to change this from 5 to 6, we're trying to say, check if 6 is not equals to 6. So 6 not equals to 6, obviously, is going to be false because 6 indeed is equals to 6. So this operator not equals to just basically helps us check if two values are not equals to each other. If they are not equals to each other, it returns true back to us. But if they are equals to each other, then it returns false. I'm just going to come here and say the not equal to comparison operator. So I'm just going to save that. Now, the next operator that we are going to talk about is the greater than operator. Now, you are going to be using this a lot. In fact, you are going to be using a lot of these operators severally in your code, and they are very important. So it's really important that you understand these concepts. So the greater than operator basically just check if a value is greater than the other value. So it compares the size basically. So what I'm going to do is I'm going to print here. I'm going to print 5 is greater than 5. Now, what do you think this is going to give us? 5 greater than 5 obviously is not correct. So once I run it, it should give us false. As you can see, it gives us false because 5 indeed is not greater than 5 because 5 is equal to 5. But if I were to change this to from 5 greater than 5 to 5 greater than 2, let's see what it gives us. Once I run it, you can see that it gives us true because 5 is indeed greater than true. I'm going to put a comment here and I'll say greater than equality, greater than comparison operator. Now, the next one that we're going to talk about is, you can guess it, it is the less than operator. I'm going to print 2 is less than 8. And let's see what that gives us. Once I run it, you can see it gives us true because 2 is indeed less than 8. But if I were to change this to 19 and run it again, you see that it gives us false as the result. So I will just copy this description here and paste it. And I'll change this to less than comparison operator. Now, the next two and the final two we're going to talk about are the greater than or equals to and less than or equals to. So basically, these operators, these two just help us check if a value is greater than or equals to the other value. So what we can do now is we can print 5 is greater than or equals to 5. What exactly does this do? This just checks if this value is greater than or equals to this value. Now, if you look at this expression, you can obviously evaluate it yourself. And you should see that we are going to get true because 5 isn't greater than 5, but 5 is equals to 5. Once I run it, you see that the final value is true because this expression is actually true. So I'm going to change this to greater than or equal to, okay, this is supposed to be G, or equal to comparison operator. Let me just copy this. Now, the next one that we're going to work on is less than or equal to operator. So let's say we want to check if two numbers are less than or equals to each other. So I am going to print 2 is less than or equals to 5. Now, once we run this, this should give us true because 2 indeed is less than 5, but 2 is not equals to 5. So once I run this right now, you see that we get true as the final value. But if I were to increase this to like 10, for example, we should get false because those two conditions do not are not satisfied because 10 is not less than 5 and 10 is not equals to 5. So returns false back to us. So these are the basic comparison operators that we are going to talk about in this section of the course. These are really, really important because you are going to be performing a lot of comparison in your programs as as you develop more software and write more code. Next, we are going to discuss logical operators. So I want you to create a new file in chapter 3 and call it logical underscore operators .py. Now, what exactly are logical operators? Logical operators are basically used to combine multiple conditions and they return truth value. So what that means is that we're able to combine different conditions together. Now, once we combine them, we're able to evaluate all the conditions to return whether they are all true or false. Now, you are going to understand exactly how that works. So the first operator we're going to talk about is the AND logical operator. Now, the AND logical operator basically checks two conditions and it checks if both conditions are true. So if both conditions are true, then it means that the overall expression is true. So we're going to see exactly how that works. So I'm going to create a variable and I'm going to say is true So is true can be like it can be anything. So I'm just going to the variable can be called anything, but I'll just call it is true. And I am going to equate this to two conditions. So I am going to create the first condition and I will call it 5 greater than 3. And the next thing is 10 greater than 2. Now let's look at this expression. We have an expression on the left saying 5 greater than 3. And then we have another one on the right saying 10 greater than 2. Then in between, we have the AND keyword. So what the AND keyword does is that it's going to check if both conditions are true. Now, if both conditions are true, then the overall expression becomes true. So this is how Python is going to see it. So since 5 is greater than 3, this is going to be obviously true. Now, let me just put the AND here. Now, since 10 is greater than 2, this is obviously true. So since both values are true and true, it means the overall expression is going to be equals to true. So the AND keyword requires that both conditions are true. Now note that you could even add as many conditions as you want. So I could add another AND condition here, and I can say and like 6 greater than 3, for example. So you can add as many ands as you want. But although it is, it's best practice not to add too many ands. So you could add as many as you want. I just wanted to verify that. Now what I can now do is I can come down to print is true, is underscore true. So once I do that and run it, you see that we have true getting printed out because 5 indeed is greater than 3 and 10 is greater than 2. But if I were to change this from 2 to let's just say 27, for example, once I run this program, you are going to see that we get false. Now, why do we get false? We get false because this side is true, right? 5 is indeed greater than 3, but 10 isn't greater than 27, so this is false. Now, because both values aren't true, we get false. And that is why we had false printed out in the terminal. So you can see that we can write two conditions like that. Now you might be wondering why I wrapped these two conditions inside parentheses. It's just so that we can have everything, like look nice and separated. So if I run this, for example, it's still going to run, but the parentheses just made it look, better and made us understand that this expression is separated from this expression. So it's better for readability to write parentheses right there. So the next operator, which we are going to talk about, is the OR operator. So now, what exactly does the OR operator do? The OR operator takes two conditions, like the AND operator, but the difference is that it checks if either of them are true. So the OR operator only requires that one of the conditions are true before the overall expression is true. So I will just come here and write a comment, and I'll call this the AND logical operator. Operator, yes. Next, we're going to talk about the OR logical operator. So let me just put a comment here. I'll say OR logical operator. So I had explained that the OR logical operator just checks if two values. It checks if either of the two values are true. And if either one is true, it's going to return true. So let's see an example. I'll create a variable and I'll call it is OR expression true. So I'm going to equate it to, let's say 5 is greater than 3, right? Or 10 is less than 2. Now let's look at what we have when we print this expression. I'm going to print is OR of expression true. So what we have done here is that we have written a condition on the left side, which is 5 greater than 3. And we have written a condition on the right side, which is 10 less than 2. Now, what do you think this expression is going to print when we run the program? So let's run it and see. So once I run the program, you see that we get true being printed out. Now we get true being printed out because what Python sees is that this expression on the left is true, but this expression on the right is false because 10 isn't less than 2. But since we have an or in between the two conditions, all we require is that at least one of these conditions is true before all of them can be true. I'm just going to put a comment here, and I'm going to come here and write true. So let me just space that out properly. And in here, I'll write the or, and this is false. So since we require that only one value be true, all of this is just going to be equals true. Now, if I were to change this to like, sorry, if I were to change this to, let's say, 20. Now, since 10 is less than 20, this is going to be true, and this is also going to be true. Now, let's see what that gives us. You might get confused, but let's see. Now, once I run it, we still get true. Now, the OR operator is interesting because if both conditions are true, it returns true. If one condition is true, it also returns true. So all the OR operator needs is that at least one of the conditions are true. If both conditions are true, it also returns true. But if, for example, now one of the conditions becomes false, like if I say 5 greater than 8, sorry, I mean, if, for example, two of the conditions becomes false, if I say 10 is greater than 8 and 10 is less than, sorry, if 5 is greater than 8 and or 10 is less than 8, let's see what that gives us. Now, because both expressions are false, we are going to get false back as a reply because 10 is not less than 8 or 5 is also not greater than 8. So that is why we have false being printed out. Now, the last logical operator which we are going to talk about is the not logical operator. So I'm just going to come down here and I'm going to put a comment and I'll say not logical operator. Now, the not logical operator basically reverses the results of it reverses the results of a condition. So it gets the truth value of that condition and changes it to the opposite value, to the opposite of the truth value. So let's say, for example, I want to check if a person is an adult. I'll say is adult is equals to okay. So first of all, let's just create a variable here, and I'll say age is equals to 20. Then is the adult is going to be age greater than 18. Now, because this is going to return true, we should, since this condition is true, I mean, because 20 is indeed greater than 18, then it should return true. I'm just going to come here and print is adult. So let me just put a comment on this line so we don't get confused. So once I come here and print is adult, you see that we get true because age, which is a variable holding 20, is indeed greater than 18. Now, watch what happens when I say not age greater than 18. So let's see what happens. Now, once I run this, you can see we get false getting printed out. Now, what Python did was it first evaluated this expression, age greater than 18. Since age is indeed greater than 18, the value became, this expression resolved to true. Now, because we had put not right beside it, not is just going to get the truth value here and flip it. It's going to reverse it. So that true is going to become false. So if I were to change this from age is less than 18, since 20 is not less than 18, this should return false, right? But since we have the not or logical operator beside it, it's going to return true. So not just basically gets the it basically gets the truth value of the expression or condition, and it flips it and changes it to the opposite. It returns the opposite value. So that is exactly what the not operator does. So in this video, we talked about the AND operator, we talked about the OR operator, and we talked about the NOT operator. So if you have any question, please feel free to ask. Now, it's also good to note that we can combine all of these operators into a single expression, a single, even long expression. So let's say, for example, we have the variable of age equals 20, and we want to check if the person is above 20 but less than if the person is above 20 but less than a certain age, like let's say 40. So we can say we can just write a print statement here, and we can print out age is So let's put that in parentheses. We can print out age is less than, or sorry, age is greater than 18, right? So we want to check if the person is an adult, and age age is less than, let's say, 40, for example. So here we're going to print age is less than 18 and age is less than 40. So let me just comment this out so you can see it being printed out. So once I run it, you can see that we get true because age is indeed greater than 20. 20 is, sorry, age is indeed greater than 18. 20 is greater than 18 and 20 is less than 40. So we get true. The next operators that we are going to talk about are the assignment operators. So what I want you to do is, again, create a new file inside chapter 3 and call it assignment operators. Assignment underscore operators .py. Assignment operators are used to basically assign values to variables. Now, the simple assignment operator which we'll be using since the start of this video is the equal to operator. So I can say name is equals to Ayodeji Adeshola. Now, in this first line right here, the equal to symbol or the equal to sign is the assignment operator, and it is used to assign a value, which is this string, to this specific variable. So that is the first assignment operator which we are going to talk about in this section. Now, the second one is the plus equals to operator. So let's say I have a variable and it is x is equals to 9, for example. Now, there is a special kind of operator which we can use in order to add a value to 9. So we can look at it as an incremental operator. That's what I would call it, an incremental operator. So what we can say is, first of all, declare x and say x is equals to 9. So what we can then do is say x plus equals to 3. Now this plus equals to is an incremental operator. Now you might look at it and be confused. So what exactly does it do? So this x plus equals to 3 is a short way of saying, let me just write this in the comments. It's a short way of saying the current value of x plus 3. So what we're just simply doing here is we're trying to increment the value of x by 3. That is what plus equals to means. Now it can also be written as x is equals to x plus 3. So let me just remove this from comment and put it on its own line. So we can write it as x is equals to x plus 3. So what this line means is that guess the current value of x and add 3 to it. So this line is very similar to line 4, but line 4 is usually preferred over line 5 because line 5 is longer. So it's just a way of incrementing the value of x by 3. So what I can now do is I can come down and print the value of x. And once I do that, you can see that x is now 12 because x was incremented by 3. X plus equals to 3 is the same thing as saying x is equals to x plus 3. And these expressions are the exact same. Now, the next one that I would like to talk to you about is what I will call the decremental operator. Just like how we can do x plus equals to 3, we can also do something like x minus equals to 3. Now, what we're just simply saying here is subtract 3 from the current value of x. So what I will do is I will just copy this and print 3 immediately after. So I would just like to comment these out so that we can see them clearly. So once I say x minus equals to 3, we're just saying get the current value of x and subtract 3 from it. So let me clear my screen right now, and then I will save and run this program. So once I run it, you can see that we have 6 getting printed out because we subtracted 3 from x. Now we could also do the same thing using multiplication. So I can come here to say x times equals to 3. Now this is just going to say x, this is the same thing as saying x is equals to x times 3. So once I run this, you see we have 27 because 9 times 3 is indeed 27. Now we can now do the exact same thing with division and say x forward slash equals to 3, which is the same thing as saying divide the current value of x by 3. So once I run this, you can see that we have 3.0 because 9 divided by 3 gives us 3. Now you can see that we can use the assignment operator along with arithmetic operators, which we had talked about in the previous video or in the previous section. The other one that we can also do is we can say x mod equals to 9. Now remember that the modulus operator basically returns to us the remainder of the division. So what we are saying here is divide x by 3 and then store the value of x and store the remainder, I mean. So once I save that and run this, you see that we have 0. So we have 0 because saying percent equals to 3 means that we are saying get the current value of x, divide it by 3, and store the result back into x. That is why we get 0, because 9 divided by 3 is 3 and the remainder is 0. Now the last operator which we had talked about was the exponent operator. So we could also say x double times equals to 3. So what this means is get the current value of x and raise it to the power of 3. So once I save that and run this program, you see that we have 729, because what Python is going to do is it's going to say 9 times 9 times 9. So it's just going to raise it to the power of 3. So that is exactly what we have here. We are going to work on our first mini project of this course, and we are just going to combine all the concepts we have learned together into one single small project so that we can better solidify everything we've learned so far. So I created a file called miniprojects.py under chapter 3, and then I have this little task that we are going to perform together. So what you can do is you can first of all pause the video and attempt it by yourself, or we could just go along and solve this together. So the question says create a Python script that takes two numbers from a user and performs addition, subtraction, multiplication, and division. So now that we have read the question, you know that we had talked about all of these concepts, starting from declaring a variable to collecting inputs from the user. So the first thing that the question says is that create a Python script that takes two numbers from the user. So first of all, we're going to break this task down into different sections. So we know that the first thing we need to do is collect two numbers from the user. So I'll create a variable and I'll call it first number, or num1. You just say num1, and I can equate this to the input function. That's not that. The input function that Python gives to us. I'm going to say input, then enter first number. And then I will do the same thing for num2. I'll say num2 is equals to input of enter second number. Right. Now remember that anytime we want to perform, like operations like arithmetic operations, we can't perform those operations on strings because we can't add two strings together and expect to get a numerical value back. So what we need to do is we need to convert both into integers. Remember we had talked about the int, keyword, which helps to combine and which helps to convert strings to integers. So what we're going to do is we're going to wrap each of these inside int keyword. I'm going to say int, and I'll wrap this inside the int keyword, and I will do the same here. I'm going to put int there and wrap it inside the int method or function. So what Python is then going to do is it's going to get these inputs from the terminal, from the user, and it's going to automatically convert it into an integer. Now the next thing that it says is that we need to, after taking the inputs from the user, we need to perform addition, subtraction, multiplication, and division. So what we need to do next is we need to write out code which is going to perform 4 of these operations individually. So the first one is addition. I will create a variable and I'll call it addition, and I will equate it to let's say first number, or num1, I mean, num1 plus num2. So this is just going to help us sum the values of num1 and num2 and store it inside the addition variable. Now the next one is subtraction. So I'm going to say subtraction is equals to num1 minus num2. Then I'll do the exact same thing for multiplication. Multiplication. It will be equals to num1 multiplied by num2. And then it's supposed to be equals to. And then the final one is going to be division. I'm going to say division is equals to num1 divided by num2. So what we can then do is we can come and print out all of these values. So I can print out addition, I can print out subtraction, I can print out multiplication, and I can print out division. So I want you to take a look at this program and analyze it. So let's analyze it again. So the question said we should collect two numbers from the user. So it takes in two numbers. We have written the script which will ask the user to enter the two numbers right here using the input keyword. Then after using the input keyword, we converted it into an integer using the int keyword. Now, after doing that, we created four variables. Each of these variables are assigned to their own different arithmetic operations of these two values which we have collected. So addition, subtraction, multiplication, and division. And then after performing these operations, we're just simply printing them out. So once I run this script, it's going to ask us for the first number. I'm going to enter 56, and to ask for the second number, let's enter 4. So once it runs, it says addition is num1 plus num2, which is 60. 56 plus 4 is 60. Then the subtraction is 52. Multiplication is 224, and division is 14.0. So this is exactly how we can combine all of the concepts. Now, to even make it a formatted string, we could do something like this. We could put the F keyword, and in quotes, we can say the addition is, and in here we just pass in addition. So that way, when I run it, it will ask for the first number, 6, second number, let's say 3. And you can see that it prints out the addition is 9. So what I want you to do is, I want you to practice this. I want you to go through each of these print statements, and I want you to use a formatted string to print a formatted string just like the first one. So the second one is going to say the subtraction is subtraction, the multiplication is multiplication, the division is division. Now, to make it even a bit more complex, even though it won't be really complex, but to make it a bit more complex, I want you to add in the formatted string that will print it out in the format. The addition of num1 plus num2 is the result. So let's say, for example, it's going to say the addition of 6, the addition of 6 and 7 is 13. So I want you to print it out in this formatted manner. We are going to move on to the next chapter and talk about conditional statements. So I want you to create a new folder and call it chapter 4. Now, inside chapter 4, I want you to create a new file and call it conditional statement. So conditional underscore statements .py. Now, once you create that file, please just open it and navigate to it. So what exactly is a conditional statement? Now, conditional statements allow us give decision-making abilities to our program based on some certain conditions. So let's say, for example, now, a very simple example is when you want to sign up on a website, and the website requires that you are above the age of 18. Now, in that case, the user is going to input their date of birth, and the program is going to check. If the user is above the age of 18, then we want to register this user. But if the user isn't above the age of 18, we want to display an error to the user, letting them know they can't register. So that's like a very simple example. It's just a way of giving our program the ability to make decisions based on some certain outcome or some certain conditions. Now, the very basic syntax for writing an if statement is this, and I will give it to you right now. So this is the syntax. You have to write the if keyword first of all, and after writing the if keyword, you have to write the condition you are trying to check for. So I'm just going to write if condition. Now, the condition can be anything, as you are going to find out. So the syntax, first of all, is if, then you write the condition you're trying to check for, and you put a colon. Now, once you put that colon, the next thing that you need to write is the block of code that you want to execute if this condition is actually true. So what the if statement does is that it's going to test this condition. Now, if this condition is true, it is going to evaluate whatever block of code is inside this if statement. That's why you can see there's some space. So whatever I type here falls under this if statement. So if this condition is true, we're just going to perform some task. Now, what we can also do in Python or generally in programming is that if the first condition doesn't hold true, that is, if this is false, then we can create multiple other conditions that follow. So it's just a way of creating, like, you can call it a chain of thoughts or a chain of possible decisions based on some certain outcome. So what we can now do is we can say else if there is another condition. So in order to do that, we're going to say ELIF, which is short for else if. We're going to say else if another condition, and we're going to put a colon, and again we'll say perform some task. So what exactly does this mean? What we're simply doing here is we're going to check, first of all, if this condition is true, then we're going to perform this task. But if this condition isn't true, we're going to jump to the next condition to check if this is true. So basically what Python does is that it will check every single if condition. And the moment it finds one that is true, it is going to execute whatever block of code exists inside it. So we can have multiple else if conditions. So I can even put an elif right here, and I can say another condition. Then in here, I will say the same thing and perform some task. So you can see that we can have as many else ifs as we want. So it's just a way of giving your program multiple multiple conditions, and it checks and it executes some specific code based on whatever condition it is. So if this first condition is false, it will jump to this next condition. If this condition is false, it will jump to this next to this next condition. Then if this is false also, sorry, if this is true, it's going to execute the program that exists inside it. Now, the last conditional statement that I would like to let you know of is the else condition. So the else condition means if every other condition that came before it wasn't true, that is, if all of them were false, then it means that the else condition will run by default. So this will run some task if all conditions were false. So this is supposed to be conditions. So it's like the last result that Python is going to make use of. It's going to check each and every one of these conditions. If they are not true, then the first condition that will run is the else condition. So this is like the basic syntax for how an if statement or how conditions work in Python. But this is just the like pseudo code. Let's write the actual code, which is going to enable us actually give our program the ability to make decisions. Now, the first thing we're going to do is we're going to write like a simple grading system. So we're going to ask the user to enter a score or a grade. So the score is a numeric value. So we can say like enter a score, and you could enter like 70, 55, 60. And based on what the user enters, we are going to give back the user's grade. So first of all, we need to collect the score from the user. So we're going to make use of the input statement. So I'm just going to simply say score is equals to input, and inside this input I'm going to say enter a score. Now, because it's it's going to be a numeric value, we need to wrap it inside the int keyword so that we can properly convert it into an integer. Now, once we do that, All we simply need to do now is check if the score, we need to check if the score is greater than some certain numbers to get their grade. For example, if the score is greater than 90, then we're going to tell the user that you got an A. If the score is greater than 80, we're going to tell the user that if it's greater than or equals to 80, we're going to tell the user that you got a B. And if it is greater than or equals to 70, we'll tell the user that you got a C. So this is a very simple basic program, and let us go with it. So like I explained earlier, the simple syntax of an if condition is you write the if keyword first, then you write the condition you are trying to check. Now, if you remember from the comparison operators, we talked about the greater than operator, greater than or equals to operator. Now, this is where we are going to be making use of it. So when you're writing if statements, a lot of the time you're going to be working with if statements as well as various comparison operators. So you are going to see how all of this will come together. So what I can say is if score, if score is greater than or equals to 90, then if the score is greater than or equals to 90, what do we want to do? We just want to print your grade is A, right? So this is exactly what we want to print. Now let's analyze this statement. We have written the if keyword, then we passed in the condition. Now remember that the condition is just a comparison operator, which we had talked about earlier. So we're trying to check if the score which is entered is greater than or equals to 90. If it is greater than or equals to 90, then the program is going to print out your grade is A. Now we want to check if the score is greater than or equals to 80, we want to print your score is B. So here we're going to use an else if statement, or ELIF, LIF for short. So I'm going to say L if score is greater than or equals to 80. Then what do we say? We're going to print your, we're going to print your grade is B. Then the last thing we want to do is, or the third else if condition we want to, or the second else if condition, I mean, we want to add is, we want to check if the score is greater than or equals to 70, and that will give us a B. So we're going to say else if score is greater than or equals to 70, then we're going to print out your grade is C. I'm going to say your grade is C. Now, if the score that gets entered is not greater than 90, is not greater than or equals to 80, is not greater than or equals to 70, what do we exactly want to do? This is where we use an else block. Now, the else block is going to run if none of these conditions are true. So we're going to see exactly how that is going to work. Now, if all of these conditions aren't true, we just want to print you did not get A or B or C. You did not get an A or B or C. We're just going to save that. Now, let's just test the program, and we're going to walk through exactly how it works again. So once I run the program, it asks me to enter a score. So once I enter a score like 80, you see it prints your grade is B. Now, if I run it again and I enter a score like 75, you see it prints your grade is C. Now, once I run it again and I enter a score of like 50, you can see it says you did not get an A or B or C. So let's walk through the program again. We told the user to enter the score, and we converted it into an integer and saved that value in the score variable. Now, what we're simply doing next is we're writing an if condition to check if the score is greater than or equals to 90. Now, if the entered score is greater than or equals to 90, we're printing out your grade is A. Else, if the score is greater than or equals to 80, that is, if this condition isn't true, then we're saying else, if the score is greater than or equals to 80, then we want to print your grade is B. Else, if the score is not greater than 90 and it is not greater than or equals to 80, then we want to check if the score is greater than or equals to 70. If it is, we want to print out your grade is C. Else, if all of these conditions, if all these three conditions aren't satisfied, then we're just going to print out you did not get an A or B. So the else block is like the final result. It's the final block that will run if all the conditions aren't true. So that is basically how an if statement works in Python, and this is the basic syntax. So if you have any question, please feel free to ask me. I know that as things get more complex, you might have a lot of questions, but just take it step by step and break it down. In the next section, I'm going to teach you about combined conditions in a conditional statement. So what I want you to do is go to your chapter 4 and create a new file and call it combined conditions.py. Now remember that in week 3, we had talked about logical operators. Now we talked about the and, we talked about the or, and we talked about the not logical operators. And we also talked about the comparison operators, which are greater than or equals to, less than or equals to, the equality comparison operator, the not equals to, and a bunch of the other ones. Now, these are really powerful because you can combine logical operators, comparison operators, and if statements to form really powerful decision-making algorithms. Now, I'll give you an example. So let's say we have two numbers defined. I'll just call this num1, and I'll equate this to minus 3. And I'll create a variable and call it num2, and I will equate this to, let's say, 1. Now we can write an if statement to check if both numbers are positive. Now, how exactly do we do that? We are going to require two conditions. Now, if I told you to write a program if num1 is greater than 0, what you are just going to do is you are going to print, from what we have talked about, you are going to print num1 is greater than 0. Now, this is obviously going to either return true or false. So once I run this, you can see we get true. So let's see why we get true. Num1 is 3, so we should not. Okay, so we're getting true because this is meant to be num2. So I had come here and reassigned num1 to 1 instead of num2. So I'm going to rename this from num1 to num2. Now, once I run this program, you'll see that we're going to get false. We're getting false because num1 has been equated to -3. And printing num1 greater than 0 is obviously false because the first number is not greater than the second. The first number, which is -3, is not greater than 0. Now, what if we wanted to write an if statement to check if both numbers are greater than 0? We can combine two conditions, and I'll show you how. We are going to write the if statement first of all. Now, we're going to write the if keyword. Then after the if keyword, we need to write the condition we're trying to check. We are going to say if num1 is greater than 0 and num2 is greater than 0. So what exactly are we doing here? We're trying to check two conditions, the truth value for two conditions. Now remember that using the AND logical operator, we're able to combine as many conditions as we want. On this left-hand side, we're checking if the first number is greater than 0. On the right-hand side, we're checking if the second number is greater than 0. So if both numbers are greater than 0, we just want to print both numbers are positive. positive. But if this isn't true, that is, if this condition isn't satisfied, we're just going to write an else block. And in here, we're just going to print both numbers are not greater than 0. Or instead of that, let's just say both numbers are not positive. Now, once I save that, clear my screen and run it, what do you think we're going to get? You see that it says both numbers are not positive because it checks this first condition. Is the first number greater than 0? This is false. But if this is the second number greater than 0, this is true. Now remember that when we use the AND logical operator, it checks if both conditions are true. And if both conditions are true, it's going to return true back to us. So that is why this entire expression resolves to false. So we now jumped to this else statement, and the else statement ran because it was the last result. So this is how we can combine logical operators and comparison operators using an if statement. Now this could get as complex as possible. You definitely will write very complex if statements eventually as you go on, but this is a simple way to combine multiple conditions together while making use of comparison operators and logical operators in Python. Next, we are going to look at the concepts known as loops. So I want you to create a new file inside chapter 4 and call it for_loops.py. So before I explain what a for loop is, we need to first understand what loops are. Now, a loop is basically used to perform a specific action multiple times. So it's just basically used to, in programming, it's used to repeat a block of code multiple times. Now, in Python, we have two kinds of loops. We have the for loops and we have while loops. Now, for loops are used to loop over or iterate over a sequence. Now, a sequence can be like a string, for example, because when we started this course, I explained that a string is a sequence of characters. For example, when we say name is equals to Solomon, this is a sequence of characters which are connected together and it makes it a string. So each item in this string is called a character. So S is a character, O is a character, L is a character. And when you join them together, we have a sequence of strings, which is a sequence of characters, which is a string. Now, using a for loop, we can iterate over sequences like lists, we can iterate over strings, we can iterate over ranges. Now, you don't really need to understand what a list is for now, but I am going to explain it eventually. So proceeding, let's look at how we can make use of a for loop. Now, I explained that a for loop is used to iterate over a sequence of characters, and it is used to perform a specific block of code while looping through. Now, if we wanted to loop through this sequence of characters, which is a string, it is actually very straightforward. All we have to do is make use of the for keyword. So I'm going to say for I in name. Now, what exactly does this mean? I is the iterator. That is, I is the variable that is going to go through every single character inside this string. So it is going to go through each character one by one, starting from S. So at some point, I is going to be equals to S. At the next point, I is going to be equals to O. The next point, I is going to be equals to L up until N. So we're just looping through this string. It means when we say we're looping through the string, it means we're going through each value or each character in a string one by one. When I say for I in name, the next thing that we now need to say is we need to write the block of code that we want to perform or the action that we want to perform. Now, what I'm just going to do is I'm going to print the value of I. So this is the action we want to perform. For every single value of I of the name Solomon, we want to just print out every single value individually. So once I save that and I run it, you are going to see that we get S being printed out. We get Solomon being printed as well. It is character by character. Now let's examine what it does. So first of all, we have a for loop. It says for I in name, print I. So what that means is that for every value that is present in this string called Solomon, we want you to print each value. So it's going to say for I in name, then to grab this first value called S, then it moves to the next line, prints the value of S, then it continues the loop because all the values haven't been exhausted. Then it goes to O, it comes to this line and prints O, then it goes to the next iteration, which is L. So it selects L, then I becomes L, then we print the value of I, which is L. Then it goes to O, prints the value of O, goes to M, O, and then N. So at this point, when it gets to N, it says it's now I is now equals to N at this point. So we print out the value of I here, which is N. Now, since that is the final value, or since that is the final character in this string, the program ends at that specific point and it doesn't continue. So a for loop is just used to loop over or go through an entire sequence. Now, the sequence could be a string, for example. It could be a list. It could be a range. Now, let me explain what I mean by it could be a range. So in this example, we had printed all the characters in this string called Solomon. Now, let's say we wanted to print out numbers from 1 to, let's say, 9. There is an inbuilt function that is called range in Python. Now, what range does is that it gives us, a range of values starting from one value to the last value that we declare. So let's see how that works. I'm going to say for I in range 1, comma 10. So what this range is going to give us is that it's going to give us a list of numbers starting from 1 up until 9. So when you type in range and you put the starting and the ending number, it's never going to give you the exact ending number. It's going to give you the ending number minus 1. So if I wanted to print out a list of numbers, if I wanted to get a range or a list of numbers from 1 to 11, I have to say for I in the range of 1, comma 11. So after doing that, what do I want to do? I just want to print out I. Now, once I do that, I should see the numbers 1 to 10 gets printed out in the terminal. Once I run this, you can see that we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gets printed out in the terminal. So that is exactly what the for loop does. It just helps to loop over a sequence. The sequence could be a list, it could be a range, it could be a string, it could be anything, like any item that we can loop through. It could be like a string, a sequence, a range. Now note that we can even perform some certain operations using inside this for loop. So for example, aside looping through this for loop, we can write an if condition to perform some specific block of code. So let's say, for example, we want to check if the number is even. That is, we want to print out all the numbers that are even in the range of 1 to 11. Obviously, we know that even numbers are numbers that when divided by 2 have a remainder of 0. So what that means is that we can make this program a little bit more complex. And since we want to find out if a number is even, what we're going to make use of is the mod operator. Now, if you remember, the mod arithmetic operator returns back to us the remainder of a division. Now, since we're trying to check if the specific number is even, we're just going to divide that number by 2 and get its remainder using the mod operator. So I'm going to use an if statement right here. So I'm going to say if I mod 2 is equals 0, then what do we want to do? We want to print the value of I. Let me explain what this is now. Now for I in range 1, comma 11, remember this is going to give us a list of numbers from 1 to 2, from 1 to 10, I mean. Now for every value of I, that is, we know that I is going to become 1, 2, 3, 4, 5, 6, 7, and up until 10. So for every value of I, we want to check if that present value of I divided by 2 has a remainder of 0. Now, since the modulus operator gives us the remainder of a division, that is why we are going to say if I mod 2 is equals to 0, then we just want to print that value of I. So what I'm just going to do is I will clear my screen and I will run this program. So what do you see getting printed out to us? You see 2, 4, 6, 8, 10. We see 2, 4, 6, 8, 10 because those are the only even numbers starting from 1 to 10. So you can see that using a for loop, we can also combine it with an if statement to make the program a little bit more interesting. So while looping through a sequence, we can decide to perform some specific task, or we can decide to check for some specific condition for each item in that sequence or for each element in that sequence. So I hope that is understandable, and I hope you understood that. If you don't understand it, you can always ask me a question again and I will go over it. And you could always watch the video again if you feel like you didn't really understand it. Now we're going to move on to talking about the while loops. So I want you to create a new file inside chapter 4 and call it while underscore loops. Oops, while loops.py. I'm just going to rename this .py. Now, what exactly are while loops? So while loops are used to execute a certain block of code as long as a condition is true. So while a condition is true, it's just going to keep executing the same block of code, unlike the for loop that just loops through a sequence and performs a specific task for each sequence. The while loop just continues executing while a condition is true, or as long as a condition is true. So I'm going to give you a simple example. So let's say we have a variable called number, and number is equals to 1. So what we want to do is we want to create a while loop that will always increase this number until this number gets to let's say 20. So we want to continue increasing the value of this number until it gets to 20. Now, obviously, what we could do is we could just say number is equals to number plus 20. Or for short, we could say number plus equals to 20. Now, this would be a very straightforward way of doing it. Or sorry, number plus equals to 19 to make it 20. Now, this would be a very straightforward way of doing it. But what if we wanted to increment it one by one? That is number plus equals to 1. Then we'll come here also and say number plus equals to 1. Now, we could do this using a while loop, and I'm going to explain exactly how we're going to. So in order to write a while loop, the syntax is pretty simple. All you have to do, first of all, is write the while keyword. So you write the while keyword, and then after that, you need to write the condition that you want to check for. So while that condition is true, it's going to continually execute the block of code which is present inside it. So I'm going to say while number is less than 20. What do we want to do? We want to increment the value of number. That is, we want to, first of all, we're going to print the value of number, then we're going to increment it. I'm going to print out number, and then after printing it out, I'm just going to say number plus equals to 1. Now, what exactly is happening here? So we're creating a loop, a while loop. So we said while, and the condition is that number is less than 20. So while the value that is stored in number is less than 20, this block of code is continually going to repeat and is continually going to run. So let me just run this program to show you what it looks like. So you can see that the program starts printing out from the value of 1, and it prints 1, 2, 3, 4, 5 up until 19. So the while loop continually repeated this block of code until it got to 19. But why did it stop at 19? The condition is that while the number is less than 20. So what the program did was, when it ran, we declared that number is equals to 1. Then Python came here and saw that, okay, this guy has written a while loop, and he said, while this number is less than 20. So what do we want to do? We want to first of all print that number. Then we want to increment or add 1 to that number. So what it does is that it print 1, then add 1. Then it now comes back to this condition to check, is the number less than 20? Since at that point, number has changed to 2, it is less than 20, which is true. It's going to print out the value again of 2. Then after printing the value of 2, it's going to add 1 to the number. Then number becomes 3. So what it now does is that it comes back to the top of this loop again, and it checks while number is less than 20. Now, number is currently 3. So while 3 is less than 20, that is true. And it's going to execute this block again. It's going to print 3, then increment the number by 1, and then number becomes 4. So it repeats this process up until when number is 19. So 19 gets printed out here, then we add 1 to number. So at this point, number now becomes 20. So it comes back to the while loop. Then it says, while 20 is less than 20. Is that condition true? No, because it's obviously false, because 20 isn't less than 20. So the condition isn't true. And once the condition isn't true, the entire while loop stops running and the program exits. So this is exactly how a while loop runs. It continues to perform a specific block of code while a condition is true. So we're going to write another example. So let's say, for example, we want to collect a number from a user. We want to collect a specific number. And as long as the user hasn't entered the correct number, we want to keep asking the user to enter a number until that number is correct. What we can do is we can combine a while loop. We can write a while loop and a comparison operation to actually check if this is true. If the number that the user entered is equal to what we want. So I am going to change this number to, let's just say, 30. Then I'm going to erase these two lines. Now, the condition is that I want to check if what the user has entered is equals to 30. So what I'm going to say is I'll create a new variable and I'll call it entered number. And I'm going to equate it to 0. So I'm just equating it to 0 because we want to simulate, at the point where we write the program, we want a situation where we want to simulate that the user hasn't entered anything. So we just want to create the variable first of all and equate it to 0. So what we just want to do is we're going to change this condition. we're going to say while entered number, right, is not equals to number. Now remember that we had talked about this not equals to operator, and it's basically checks if the value on the left hand side is not equals to the value on the right hand side. And if both conditions are not equals to, if both values are not equals to each other, then this operator returns true. So we're going to say while the entered number is not equals to the number that we want, then we want to run this block of code. We want to ask the user to enter a number. So I'm just going to redefine enter number right here. And I'll say entered number is equals to input. And what do I want to do? I'm going to say enter number. Now remember that we have to convert this into an integer. I'm going to wrap this in the int keyword. So I'm going to say while entered number is not equals to number, then we're going to ask the user to enter a number and convert it to an integer. Now, once it has been converted to an integer, we are assigning it to the entered number variable. So all we just have to do is clear the screen. Now I'm going to run the program. As you can see, it tells us to enter a number. If I entered 4, you see it tells us to enter a number again. I can enter 90, enter 23, enter 1. But you see that it keeps asking us to enter a number. But the moment I enter 30, you notice that the program ends. Now, it just basically told us to continually enter this number while we didn't enter 30. So we said while the entered number was not equals to the number which we had specified here, we just wanted to keep telling the user to impute the number. Now, this is useful in a case where, for example, you are building a particular software and then the user is trying to create an account and you want to continually tell the user to enter a new password if the password is less than 5 characters. You can use a while loop for that. So that is basically how a while loop runs. It just basically performs or executes a certain block of code while the condition, or as long as the condition is true. So the moment this condition isn't true, it just terminates the while loop. So that is how a while loop runs. If you have any question, please don't hesitate to ask me and I will reply. Next, I would like to explain to you loop control statements. So what I just want you to do next is, as usual, we are going to create a new file inside chapter 4 and call it loop control underscore statements .py. Now, what exactly are loop control statements? These statements basically help us control how the loop behaves. So let's say, for example, now, there's something that we call an infinite loop. Now, an infinite loop could be potentially dangerous, especially when you build like an enterprise scale software and the loop is supposed to do something very important. Now, an infinite loop is a loop that basically runs forever. It doesn't have any breakpoints. So I'll give you an example of an infinite loop. So I'm going to say number is equals to 1, and I'm going to say while number is greater than 0, what will I do? I'm going to print number is positive. Let's change that. Number is positive. Now, if you look at this loop right here, this loop is always going to be true because number itself is indeed greater than or equals to 0 because the value of number is 1. And we are saying while the number is greater than or equals to 0, what we want to do is we just want to print number is positive. Now, once I run this command or code rather, you can see that number is positive. It continually gets printed out. Now, this is an infinite loop because at no point in time is this program going to stop running unless it is manually stopped by, like the programmer or whoever is running it. So this is very dangerous, especially if you are building like a large scale software. Now, if I leave this to run for a long time, it probably might crash my computer because an infinite loop continually uses, it continues to perform this same operation repeatedly and it uses your CPU and your RAM and everything. So what we simply need to do, first of all, in order to stop this infinite loop from running, is on Visual Studio Code, just place your cursor in your terminal and press Ctrl C. Now, once you Ctrl C, it's called keyboard interrupt. It automatically breaks or stops the program that is currently running. Now, this is an infinite loop, and we need a way in order to stop the loop at some point. So what if we want to what if we want to increment this number, right? We want to increment this number up until 20. And then we want to check if the number is equals to 20. We want to break and end this loop. Now we can do that using an if statement in combination with this while loop. So the next thing that I will do is I'm going to say number plus equals to 1. So after printing out number is positive, we are going to increment the value of number by 1. And then what are we going to do? We are going to say if number is equals to 20, then we are going to use a keyword known as the break keyword. I'm not going to type break. Now, what exactly does the break statement do? The break statement stops the loop immediately when the condition is met. So the condition in this case is if the number is equal to 20, then we want to break. So the break is going to terminate this loop that is currently running. So what it does now is that we have an infinite loop called while number greater than 0. So this loop will always run because number will always be greater than 0 since we are starting from 1. Now we're going to print number is positive, and we're going to increment the value of number by 1. So starting from 1, it's going to check while number is greater than 0, while 1 is greater than 0. That is true. We're going to print number is positive, and then we're going to add 1 to number. Then after adding 1 to number, we're going to check if the current value of number is equals to 20. Now if it is equals to 20, we just want to break. But if it's not equals to 20, we're going to go back to this loop again. Now at this point, number is 2. So we're going to check while 2 is greater than 0, 2 is indeed greater than 0. So we're going to print number is positive, and then we're going to have number plus equals to 1. We increment number to 3, and it comes here to check if 3 is equals to 20. 3 is not equals to 20, so we're going to repeat this loop again up until when we get to 20. And it's going to check if the current value of number, which is 20, is equals to 20, then we're going to break. So let's run this program and see what it gives us. So you can see that its print number is positive 20 times, I can say. So this looks like 20 times. So it prints number is positive 20 times, and then the program breaks. Now it breaks because we have told this to stop running the loop when the value of number is equals to 20. So that is the use of a break keyword. It basically helps us control the flow of the loop, and it helps to break the loop when a certain condition is met. In this case, the condition was checking if the number is equals to 20. Now, this break keyword or this break statement is also used or can also be used in a for loop. So let's say, for example, we want to use the range function to loop through numbers from 1 to 10, and we want to search for the number 5 in a range of 1 to 10. So what we're going to say is for I. Now notice that when we say for I in range, let's just say 1, 10. This variable right here, this I, could be anything we want. So we could use J, we could use K, but in programming, the practice usually is I, or in Python, the practice usually is I or J. But note that that value can be anything you want. So in this case, let's just use num. We're going to say for num in range 1, 10. So this is going to give us the numbers, a list of numbers from 1 to 9. Now, what do we want to do? We just want to search for the value of 5. And if the value of 5 is in this list, what do we want to do? We want to break out of the loop. Else, if it is not in this loop, we just want to print out the value. I'm going to show you how we can do that. We're going to write an if statement. We're going to say if num is equals to 5, what do we want to do? We want to break out of this loop. But if it's not equals to 5, we just want to print out num. So let's run that and see what it gives us. So you see we have 1, 2, 3, 4 being printed out. It does that because we told us that the moment number gets to 5, then we want to just break out of it, and that eventually ends the entire loop. So for num in range 1 to 10, this gives us values from 1 to 9. And then we're looping through each of those values using this num variable. So at this point, num is going to be equals to 1 when it starts. Then after the first iteration is like a full circle in the loop. After the first iteration, num is going to be equals to 2. Then num is going to be equals to 3. At this point, for each value, it's checking if those values are equals to 5. Then it's going to check for 4. Then moment it gets to, okay, so when it's 4, it's going to ignore this line. It's going to ignore this if condition because 4 is not equals to 5. Then it's now going to come right here and print out the number. But once number is equals to 5, that means 5 is equals to 5, then we tell us to break the loop or exit the loop. So that is exactly how to use a break statement. It just basically helps to stop the loop immediately when a condition is met. And in this case, the condition is number equals 5. If the number is equal to 5, then we want to break out of this loop. So I would just like to put a comment here just for documentation's sake. I'm going to call this the break statement. Now, the next statement that we are going to talk about is the continue statement. So I'll just put a comment here. I'm going to say continue. What exactly is a continue statement? A continue statement is used to skip an iteration and move to the next one. So again, I had explained earlier that an iteration is like the current circle of a loop. So I'm sorry, not the current circle. I had explained earlier that an iteration is the current sequence or the current element that is being executed. So remember that when you have like a sequence, like a range or a string, we are going to loop through it using a for loop. So we can say for I in whatever sequence it is. Now for every single value or for every single element in that sequence, it is called an iteration. For every single item it goes through, that is one iteration. When it goes through a string that has 5 characters, it has 5 iterations. So that is basically what an iteration is. Now, for the continuous statement is used to skip an iteration and move to the next one. So what that means is that when we have like a string of 5 characters, if we want to perform some kind of action that skips over a character based on a condition, we can do that. Now, I'm going to show you exactly, I'm going to give you an example. Now, we're going to write a for loop, and then we're going to say for num in range 1, 6. Now, this is going to give us the range of values from 1 to 5, right? Because it doesn't give us the 6 itself. Now, after creating a range of 1 to 6 or 1 to 5 numbers, what do we want to do? We now want to skip over the number, which is 3. We want to check if the current number is 3, then we want to end this entire iteration and move to the next one. What I'm going to say is, I'm going to say if num is equals to 3, what do I want to do? I want to continue. And after hitting continue, I'm just going to print out, at this point, I'm just going to print the number. Now let's look at the structure of this program. Now we have written a for loop here. We said for I in range 1, 6. Then we're saying if the number is equal to 3, we want to continue. Now what the continue keyword is going to do is, it's going to end the current iteration for this loop, for this current element, and move to the next element in the iteration, in the sequence, I mean. So the program is going to start from 1. So it's going to say if 1 is equals to 3, 1 is not equals to 3. So it will skip this entire if statement and print out 1. And it's going to move to 2 because it is a range of 1 to 5. So it's going to start from 1 and end at 5. So it's a range of 1 to 6. So it will start from 1 and end at 6. So it's going to go to 2. And if 2 is equals to 3, 2 is not equals to 3. So it's just going to completely ignore the whatever block of code is inside the if statement. We're going to print out 2. Then next is 3. We're going to say if 3 is equals 3. Now, obviously, 3 is equals to 3. So this condition is true. Then we're now going to proceed to execute whatever is inside that if condition. Now, since we have a continuous statement, what Python is going to do is it will just completely break out of the current iteration and go back to the for loop. So it's not going to bother printing It's not going to bother printing the number called 3 because we have told this to continue at this point. So it will end the current iteration and move to the next one. So let me just save it. And I would just like to comment this out so that we don't get confused by the printout. Now, once I run this program, let's see what it gives us. You see we have 1, 2, 4, 5 getting printed out, just as I had explained. So what it did was it basically printed 1, printed 2, then when the next iteration was 3, it came here and said if the number is equals to 3, and at this point 3 was equals 3, and that is true. We just told this to continue. So it didn't bother executing any other code that came after it. It's just terminated the execution for the current iteration and moved to the next one, which was 4. Then it checks, is 4 equals 3? No, 4 is not equals to 3. And it's printed 4, and it's did the same for 5. So that's exactly how to use a continue statement. It just helps us end the current iteration and move to the next one based on a certain condition. The next statement which we are going to discuss is the pass statement. Now, it is used when a statement is required syntactically, but you don't want to execute any code for it yet. So I'm just going to explain what we have here. So we have a simple for loop, and we're going through a range from 1 to 6. Now, the 1 to 6 is going to return to us, 1 to 5, which we are discussing. Now we have an if condition here that says if the number is equals to 3. And right here we have pass. Now the reason why we put pass here is because there's some other action that we want to perform if the number is equals to 3. But we are not ready to write it yet. So we're just going to put pass. So what Python is going to do is if the number is equals to 3, that is if the current number in the iteration is equals to 3, it's going to come here and see pass. So pass is just basically telling the interpreter that you should just continue and ignore. Sorry, not continue. It's just telling the interpreter that you should ignore and move to the next instruction, which is print num. So it doesn't necessarily do anything. It's just basically a placeholder. It's used as a temporary placeholder. So what that means is that since we don't want to write anything yet, we don't want to write the code that needs to be executed yet, but we need this condition to be there. We're just going to put pass, and we can come back in future to write the program, to write the condition which is going to be executed. Now, like I said earlier, it is a statement that it is used when a statement is required syntactically, but you don't want to execute any code yet. So let's say we need to really check if the current number is equals to 3. And if it is equals to 3, there's some action we want to perform. But if we're not ready to write the code to perform that specific action yet, we can just put in pass. And what the Python interpreter is going to do is it's going to see pass and just move on to execute the next line of code. So once I run this program, you're going to see that we get 1, 2, 3, 4, and 5 being printed out. So we get 1 to 5 being printed out because when the number was 1, it came, is the number equals to 3? It said no, then it just printed 1. Then it did the same to 2, it's printed 2. And when the number became 3, it checked. If the number is equals to 3, then what do we want to do? We want to pass. Now, since the number indeed was equals to 3 at that third iteration, we just told this to pass. Now, pass means just move to the next line and continue executing the program. And then it's printed 3. So that is exactly how pass works. And that is how the pass, the continue, and the break statements work in Python. So in this section, we are going to be working on a mini project that combines all the concepts we've talked about. So the question says that we should set a random number and ask the user to guess it. Give hints if the guess is too high or too low. So this is exactly what we want to do. We want to set a random number in the program. So let's say we create a variable and say number is equals to 17. And then we want to ask the user to guess what number it is. And if the number the user enters is lower than the set number, we tell them that the number is less, that what they entered is less. And if what they enter is higher, we tell them that the number they entered is higher than the actual number. So when we're working on this project, we're going to combine different concepts that we've talked about. So we're going to use while loops, we're going to use a while loop, we're going to use if conditions. So you're going to see how that is going to turn out. So the first thing that we need to do is first of all create a variable. and then we need to equate that variable to any number we want. So I can say number is equals to 47, for example. Now, what we want to do is we want to ask the user to guess a number, to enter what they think the number is. So what we need to do is we need to now actually collect inputs from the user. So we're going to use the inbuilt input method to collect this number from the user. And so the next thing that we're going to do is we are going to create a while loop. Now you are going to see exactly why we are creating this while loop. So I'm going to say while true. So while true means that this while loop is going to run forever until a certain condition inside the while loop is met, and then we break out of the while loop. So inside this while loop, what do we want to do? We want to ask the user to input the number that they think it is. So I'm going to say user guess. I'll create a new variable called user underscore guess, and I will equate it to the int keyword because we are trying to convert the number into an integer first. So after passing in the int keyword, we're going to type in the input method right here. Sorry. We're going to put in the input method right here. And we're going to say guess the number. So what we are doing here is that we are essentially creating a variable called user guess, and then we're asking the user to guess the number. Now, once the user enters that specific number, it immediately gets converted into an integer because we have wrapped it inside this int keyword, which you can see here. Now, after the user has inputted their guess, what do we want to do? We want to now actually check to see if what they have entered is either greater than the actual number, or if it is less than the actual number, or if it is equals to the actual number. So that is exactly what we are going to do next. And so the first thing that we're going to check is if their guess is greater than the actual number. What I'm going to do is I will write an if condition, and I will say if user underscore guess is greater than the number, then what do we want to do? We want to tell the user that the number they entered is greater than the number they guessed is greater than the actual value which we have set in the program. So I'm just going to write a simple print statement. And in this print statement, I will just write your guess is too high. Now let's look at this again. So the user enters their guess number right here, and then it gets converted into an integer. Now, the next thing that the program does is that it checks if what they have entered is greater than the number that we have set in the program. And if it is, we're just going to print your guess is too high. Now, what do we want to do next? We want to check if the number is if their guess is less than the actual number. So I'm going to say if user guess is less than number. And what do we want to do? We want to print your guess, sorry, your guess is too low. So in this case, if I enter like if I enter like 34, it should tell me that my guess is too low because 34 is less than 47. Now, this needs to be an else if block. So L if, that is, if this condition isn't true, then try this next condition. Now, if this other condition isn't true, we just need to write an else block. Now, what do we want to write inside this else block? We want to write else. We're going to print out you have guessed the number. So let's look at this. Now, if the user guess is greater than the number, then obviously it means that we're going to print your guess is too high. But if the number that they guessed is less than the number, then it means their guess is too low. Else, if these two conditions aren't true, it means that the number that they guess is definitely equals to the number that we have set. Because if the number isn't greater and if the number isn't less than, it means that the number is definitely equals to what we have set in the program. So once you do that, I just want you to save this program. Now, after saving it, all we have to do next is just simply run the program. Now, before we run it, let me just give you an overview again of this simple program. So we defined a variable at the top called number, and we equated this to 47. Now we wrote a while loop right here, and we said while true, that is, this loop will continue to run forever until we specifically break it somewhere in the until we break out of the loop somewhere in the loop body. Now it runs forever because we're saying while true. And since true is true, it is going to continue to run this loop forever. Now, what we're now simply doing is we're telling the user to input what they think what they think the number is. So we're telling them to guess. And then after they input it, we convert it into an integer. And then we move to the next line and we check if what they entered is greater than this number which we had specified. If it is, we print your guess is too high. Now we move to an else block. Now in the else if block, we are checking if the user guess is less than the actual number. Now if it is less than the number, we just print your guess is too low. Now else, once the else block runs, we know that what the user has entered is exactly equals to the number that we have specified. Else we're just printing you have guessed the number. And the last thing we just have to do is we have to break out of this loop because we no longer want the loop to run again. So what we're just going to do is we are going to run this program right now. So let's run it. Now, once we run it, you can see it's asking us to guess the number. So let's say I enter 2. You can see that it says your guess is too low, and then it asks us to enter a number again. If I say 60, you can see it says your guess is too high. If I say 45, it says your guess is too low. I can enter, like, let's say 50. It says your guess is too high. But the moment I enter 47, you can see it prints out you have guessed the number, and then the program just ends because we told it to break out of the loop. Now, the reason why it keeps asking us to input the number is because when it checked this condition, it saw that, like, for example, when we enter the number greater like 50, it came here and said if the user guess, which is 50, if 50 is greater than number, then we want to print your guess is too high. Then after it's printed your guess is too high, it automatically came back again to this while loop. It came back because at no point at that iteration had we broken out of the loop. So because it's printed your guess is too high, it now came back to the while loop to run the entire block of code again. But the moment we entered 47, these two conditions did not hold any true value. So the else block ran and it's printed you have guessed the number, and it's broke out of the loop and the program ended. We are going to be moving on to the next chapter here. So I want you to create a new folder and call it chapter 5. Now in this chapter, we are going to be discussing strings and special manipulations that we can perform on strings. So what I want you to do first of all is create a new file and call it string underscore indexing. Just py. So in this specific subtopic in this chapter, we are going to be discussing string indexing. So you might be wondering what string indexing is. So Python allows us to access specific characters from strings using indexing. So let's say we have a random string or text called, or a variable called text, and we equate this to a string called programming. Now imagine you wanted to print out a single character from this string. That is, you wanted to print out a single letter. So let's say you wanted to print out O, for example, from this entire string. Now, usually when we want to print out the string, what we're just going to do is we're going to print text. Now, if we wanted to print out only a specific section from this string, what you can do is you can use something called string indexing. Now, string indexing basically helps us to grab specific characters from an entire string. Now, there's something I want to explain to you. In a string, every single character has a position. Now, this position is called an index. Now, its index is how you access each position in a string. Now, and also in Python, every single item always starts with an index of 1. That is going from left to right. It always starts with an index of 0, going from left to right. So I want you to just keep in mind that when you look at this string right now, P has an index of 0, R has an index of 1. So let me just put a comment here so you can easily see it and understand it. So P has an index of 0, R has an index of 1, O has an index of 2, and then 3, 4, 5, 6, 7, 8, 9, and the last one is 10. Now, once you look at it, every single character in this string has an index. Now, the index tells us exactly what position that character is at in the string. So if we wanted to print out, for example, any elements in this string, all you're going to do first of all is you're going to pass in text, and then after passing in text, we'll pass in square brackets. Now, inside these square brackets, we need to pass in the index of the character we are trying to retrieve. So if, for example, I wanted to print out G, it means I have to first of all know the index of G. Now, since G has an index of 3 because it's 0, 1, 2, 3, it means I can access G using the index score of 3. Now, once I save that and run this program, you see that we have G getting printed out in the terminal. So using this method, we are able to access specific elements or specific characters in a string. Now, what we can also do is I can just remove this and create a new variable and call it character index value. Now, I'm just trying to create a new variable here, and I'm just going to assign it to text, which is the variable storing the string. And then we're trying to pass in the square brackets and pass 3 into it because we're trying to grab the specific character that exists at that index that we've passed in. So what I can do is I can then print out character index value. And this is still going to give us the same result, which is G. So I could also print out, let's say I wanted to print out M, the second M. You can see that it has an index of 7. So we're just going to pass in 7 right there. And once I run this program, you see that we have M being printed out right here in the terminal. So essentially, anytime you want to print out or grab a specific character from a string, all you need to do is just count up until that character. And you have to count from 0, and you are going from left to right. So P has an index of 0, R has an index of 1, and like that up until the character that you want to print out. So if you want to print it out, you have to pass in the variable name first, and then you put square brackets, and inside the square brackets, you pass in the index of the character you are trying to get. Now, there's also a different method that we can use in order to get characters. Now, the second method is going from right to left. So in the first method, we are going from left to right, but the second method is going from right to left. Now, the index of going from right to left, I am going to show you right now. So when you're going from right to left, the first item from the right has an index of -1. So at this point, G has an index of -1, N has an index of -2, I has an index of -3, and so on. So if we wanted to do this now, this would be -1, G would be -1, N would be -2. So let me just shift that in so you can properly see it. So N would be -2, I would be -3, and so on. So using this method, if I wanted to print out N right here, what I'm going to do is I'm just going to print out text. It's the same method. We pass in the variable name, and then we put square brackets, and inside the square brackets, we pass in the index. I'm just going to pass in -1. Now notice what gets printed out in the terminal. Once I run it, you see that we have G being printed out in the terminal because we passed in -1, and G has an index of -1. If I wanted to print out N right here, let's change it to -2. Now, once I clear my screen and run this program, you see that N gets printed out because right here, N has an index of -2. Now, if I wanted to print out this A, that is -1, 2, 3, 4, 5, 6. So once I pass in -6 right here and I print and I run it, you'll notice that we have A being printed out. So those are the two methods that we can use when we are trying to print or when we're trying to retrieve specific characters from the string. So I'm just going to write a comment here, and this is going to be from right to left. And then this comment is going to be from left to right. So that is all we're going to talk about in this video. We spoke about accessing specific values from or specific characters from a string using indexing. Now, moving on, we are going to talk about the next topic, which is string slicing. So create a new file and call it string underscore slicing dot py. Now, what exactly is string slicing, you might ask? So basically, string slicing allows us to extract portions of a string. So think of a pizza, for example. When you order a pizza or you make a pizza, it's circular in shape. But what you can do is you can cut it into slices and cut out chunks of it from the main body itself. So you have a pizza that can be cut into like 6 slices. Now, what we had before was a full circular pizza, but then we took like a knife or something and we had chopped it off into 6 pieces. Now, this is exactly what we can do in Python. We can slice out a specific section of a string and print it out or perform some operation on it. So I am going to show you exactly what that means. So imagine we have the same variable called text and it is equals to programming. Now imagine all we wanted to do was just simply print out program from this programming. Now, in the last section, we talked about printing out a single specific character or a single letter from the overall string or the overall sentence. Now, what if we want to print out a slice of that specific sentence or specific text? What we can do is we can use string slicing. So if we want to print program right now from programming, what we are going to do is we are going to use string slicing. I'm just going to say slice of string. I'll create a new variable. I'll say slice of string, and I'm going to equate this to text. But instead of just passing in text and passing in a number like the last time, what we need to do is we need to enter 2 indexes. Now, the first index is the starting index, and the second index is the last index. So what that means is that at what points do we want to grab from in this string? At what position do we want to grab? Do we want to start grabbing text from this string? Now, that is what the first position is for. Now, the second index is where we want to stop. So if we want to print program now, let's type in the index right here. So this is 0, 1, 2, 3, 4, 5, 6, right? So if we want to print out program from this entire string, it means we have to start from index 0 and stop at index 6 because those are the positions of all the characters from P to M. Now, if we want to simply do that, all we're going to do is we'll pass in index 0 and then we'll put a colon and pass in index 6. So what this tells Python is that we want you to go into, we're essentially telling you to go into the string and grab all the characters starting from index 0 and stopping at index 6. So what we can now do is we can now come down and print out slice of string. Now, once I run this, you see that we have program getting printed out. So we have program. So what we actually need to do is that instead of putting in the stopping index, we need to put the stopping index plus 1, which is 7. So what that means is that when we start from index 0 and we tell Python we want to stop at index 6, Python is going to ignore this last item in this index and it is going to stop at index 5. So what we want to do to properly print out all the characters in this string is that you need to put the stopping index plus 1. That is, since we want to stop at this first M right here, which is at index 6, we need to add 1 to it. So we tell Python that we're going to print from P to M, and M is going to be the stopping index. So whatever you pass in here, whatever stopping index you pass in here is going to be ignored by Python, and it is going to stop at the index before 7 or before whatever value you pass in here. So let's clear the screen right now and run it. So you can see we have program printed out in the screen. That is because Python started from P and stopped at M. It ignored this last index of 7. So we're just essentially telling us that we want to stop at the character before this last index. So it stopped at this M and ignored this second M. So that is exactly how we can extract a piece of a string and print it out, or you can even perform some extra processing on this slice which you have gotten from the string. Now, there are other ways that we can slice strings out from a there are other ways that we can slice strings out or perform slices on a string in Python. Now, this is the first way. The second way is that let's say we wanted to print out let's just say programming again, or sorry, let's say we wanted to print out program again, but we wanted to use only one index to do it. All we could simply do is we can print out text, and in here we're just going to pass in :7. Now, what does this mean? What this means is that we are going to start from the default first index, which is 0, and then we're going to print up until index 6. Remember that 7 is going to be ignored because it is the stopping index. So it is going to read from 0 to the stopping index -1, which is 6. So once I save that and run it, you can see that we have program again getting printed out. So what you can just do is, this is like a shorter way of using string slicing. Here we had to pass in 0:7. All we could simply do is just say :7. So by default, Python is just going to print from, or Python is just going to slice out from 0, which is the starting index, up until this stopping index -1, which is what we have seen right here. Now we have another slicing method that we can use. Now imagine we wanted to print out everything after program. That is, wanted to print out MING. Now what we could simply do here is that we could change this slice index in the first place. So this is from 0 to 6. It means we're going to be printing from 7 to, this is 8, 9, and then this G has an index of 10. Now, what we can do is, since we want to start printing from M, we can just change this to 7, and then we're going to tell it to stop at 10. But since we're stopping at 10, I want you to notice what gets printed out. Once I run it, you see that we have MIN getting printed out. The G doesn't get printed out. Now, that is because we have told us that the stopping index is 10. So it's going to do 10 minus 1, which is 9, and it is going to stop at N. Now, all we're just simply going to do is pass in 11. Even though no elements with 11 exist, Python is just going to automatically do 11 minus 1, which is 10, and it's going to print out G. So once I save that and run it, you see that we have MING getting printed out. So we're successfully able to get this slice from this string and print it out. So we're successfully able to do MING, and we printed it out, and it's worked successfully. Now, this is the first way of this is a way of performing string slicing. Now, imagine we wanted to perform the exact same operation, but using only one slice. All we are going to do is remove this colon from front of 7 and put it at the back of 7. So when we do this, we are essentially performing this same operation. What we're just telling Python is that starting from index 7, which is M, print everything that comes after it, or grab everything that comes after it. So when I run this program, you see that we still have MING, MING being printed out. That is because when we say text of 7 colon, we're just trying to tell Python that we want you to go into this string, and starting from index 7, we want you to slice out everything that comes after it. So by default, it just starts grabbing from M and stops at G. That is basically how string indexing works. And if you have any question, please feel free to, string slicing, I mean. And if you have any question, please feel free to ask me in the comment section and I will reply you. And something else that I want you to take note of is that even white space in a string has an index. So let's say, for example, I create a string and I say name is equals to Ayo space Solomon. Now, what we can do is, let us write out the index of this. Let's write out the index of this string. So O has an index of 1, and A has an index of 0, Y has an index of 1, and O has an index of 2. Now you see that there's a white space here. Now this white space, or this empty space, it's called white space in programming. Now this empty space also has an index, so we can pass in 3, and 3 is going to represent that empty space, because in a string, every single item has to be accounted for. That is, every single position in a string has to be accounted for. Now, because there's an empty space here, it still has an index of 3. Now, we're now going to continue and say uh, 4, 5, 6, 7, 8, 9, and then n has an index of 10. So what we can do now is that we can even print out this empty space just to show you. I'm going to print out name of 3. Now, if all of this goes well, we should see an empty space getting printed out. So when I run it, you see that we have this empty space being printed out because what Python did was it went into the string and it grabbed this empty space. Now, what we can do is we can now print out like S, for example, and I can pass in 4. Now, once I save that and run it, you see that S gets printed out and the space is no longer there. So in a string, every single index or every single position has to be accounted for, even if it is an empty space. Python is still going to give it an index by default. The next topic that we are going to talk about is string formatting. So I want you to create a new file inside chapter 5 and call it string_formatting.py. Now, we had talked about this before in a separate video, but it's just worth mentioning again because we are talking about strings in this specific chapter. What exactly does string formatting help us to do? String formatting helps us to format our string or a string to a specific value that we want. So we could even pass in variables and different items into a string using string formatting. So let's say I have a variable called name and I equate this to Solomon. And I have a variable called age and I equate this to 48. And I have another variable called gender and I equate this to male. What I can do is I can create another full string using all of this, and I can pass it into, I can create a new string using all of these variables, and I can format it using the F keyword, which helps us to format strings, which we had talked about. So I can create a new variable and call it sentence, and I can equate sentence to my name is name, and I am I am years old, and I am a man or something like that. So what we want to do is we want to say my name is name. We want to dynamically pass in this name which is here, and then we want to dynamically pass in the age as well as the gender. So what we're just going to do is we're going to make use of the F keyword, which helps us to format the string. So instead of putting my name is name, we're going to put these curly brackets. And inside these curly brackets, remember that I explained we can pass in variables or even expressions into it. So what we're just going to pass in here is name. And inside years, I'm going to say, and I am, here we're just going to pass in the years and say age. And after doing that, the last thing we're going to pass in is the gender. So all we're just simply going to do is run it. And when we run it, you can see that we have nothing being displayed in the terminal. That is because I haven't printed out the sentence yet. So I'm just going to type print sentence. And once I run this program, you see that my name is Solomon and I am 48 years old and I am a male. So you can see that this is what we have getting printed out to the screen. And if we change this value from Solomon to like, let's just say Daniel. Once I run this program, you see that we have Daniel also being displayed here. My name is Daniel and I am 48 years old. So this is basically how string formatting works. It basically helps us format the string to whatever we want. We can pass in variables into it. We can pass in expressions. We can pass in basically different items into the string to format it to the way we want it to look. Now, there's also something else that I would like to explain. That is the new line character. Now, inside this string right here, you can see that everything is on one single line. What you can do is we can make use of the new line character in order to break text into a new line. So I am going to put the new line character here, which is \n. Now what \n is going to do is, right from this and right here, it is going to break out and create a new line in the terminal when it is printed out. So let's run and see what that gives us. So you see that we have my name is Daniel and I am 48 years old and I am male. You can see that this is being printed out on a new line. That is because we had passed in the new line character to signify and tell Python that after this point, we want to break and create a new line. So we can create multiple lines. I can even come here to add another new line character. And once I run this program, you'll see that we have three lines being printed out in the terminal. So you can see it says, my name is Daniel and I'm 48 years old and I am a male. In the next section of this course, we are going to be discussing string methods. So in chapter 5, I had already created a new file called string_methods.py. So I want you to do the same so you can follow along. Now inside this file, you can see that I have created a variable called sentence, and it is simply equal to a string called Python is fun. Now we are going to be performing some manipulation on this string using string methods. So you might ask, what are string methods? So string methods are basically methods or functions that Python has given us by default, which we can use to manipulate strings to give a desired output. Now I'm going to be sharing a few string methods with you, and I'm going to be teaching you how to use them. And I will also share a link to where you can practice more string methods because we have a lot of string methods in Python which help us manipulate strings. Now, the first one that we're going to talk about is upper. So we have this string right here, and then it's just equated to Python is fun. So let me just make this P lowercase. So we have this string and all the characters are lowercase. Now, what if we wanted to convert every single thing, every single character in this string to an uppercase character? What we can do is we can make use of the upper keyword or the upper method, which is going to take the string and convert all the characters in the string into uppercase letters. So let's see how that is going to work. I'm going to say capitalize sentence, capitalize or uppercase sentence. Let's name it uppercase underscore sentence. And what are we going to equate this to? We're going to equate this to sentence, which is the sentence variable right here. We're going to say sentence dot upper. And you can see that Python is already, you can see that we're already being given this by default. So I'm just going to call it. Now, once we do sentence dot upper, what the Python is going to do is it's going to take the string inside the sentence variable and it's going to convert every single character into an uppercase item. So what I can then do is I can just come here to print uppercase sentence. So once I run this program, you can see that we have this string being printed in the terminal. Python is fun and everything is in uppercase. So you can see that using the string method called upper, we were successfully able to convert all the strings, all the characters in the string into an uppercase letter. Now, the next item that we're going to be talking about is the dot lower. Now, the dot lower is just the opposite of upper. It converts all the uppercase letters to lowercase letters. So let's say, for example, this full sentence was fill the uppercase character. So let's just say Python is fun. What I can then do is instead of saying dot upper, I can say dot lower. And once I save that and run this program, you can see that Python is fun in lowercase gets printed out in the terminal. So we have several string methods which just help us to manipulate the string that we are currently working with. So Python gives a lot of these methods to us by default so that we don't have to write it ourselves again. Now, another method that we're going to talk about, let me just undo that. Another method that we're going to talk about is the dot split method. So we have this string right here called Python is fun. What we can do is we can separate this string into their individual parts. So what I mean is we can break it up into their individual words in the string. So let's say I wanted to break up this string into individual parts. So the first part will be Python, second part will be is, and the third part will be fun. And they are all separated by space. What you can do is you can make use of this dot split Python method. I'm going to create a new variable and I'll call it split sentence, and I will equate this to sentence dot split. Now, what exactly does this do? So what the dot split does is that it goes into the string and it splits it and separates the string into their individual parts. So Python is will be the first part, is will be the second part, and fun is going to be the third part. So once what we can now do next is that we can print out this split sentence. And once I print it out, I want you to notice what it gives us. Once I print it out, you can see it gives us this kind of weird data type that we have not seen before. What you have here is a list, and we are going to look at lists in a future video. But what I just want you to notice is that it took each individual word in the sentence and it broke it down and it broke it into and it broke the sentence into each individual part. So Python is one item in the list, is one item in the list, and fun is another item in the list. Now, you don't really need to understand what a list is now, as I'm going to explain it in a future video, but I just want you to know that anytime you use a dot split, anytime you use a dot split string method, it is always going to break the string down into a list, and the list is going to contain each individual part. Now, there's something else that you need to take note of. Anytime you're using the dot split method, it takes in a separator. That is, what do you want to split by? Because we didn't pass anything into the parentheses here, what Python did was it just splitted the string using the empty space. So it's just used the empty space right here as the separator. But if I were to put dash or hyphen in between each word, I want you to notice what we have. You can say that everything is now one word, or everything is now one item inside a list. You can see that it isn't splitted anymore, unlike the first item. So the reason why it's not splitted into their individual parts is because when we said dot split, what Python did was it was splitting using white space. So using this empty space. So it would then use that empty space to split them. But what we can then do is, since each of the words are separated by an hyphen, we can just simply pass in the hyphen here, because we're telling Python that we want to split this string and we want to use this hyphen as the item that separates each word in the string. So I want you to notice what happens when I print this now. So when I print it, you can see that each item is now being separated, and we have three items in the list, unlike here before where we had everything as one item. So what Python did is that it just took this hyphen and it looked at the string and it said that, okay, we're going to split or separate the string using the hyphen. So essentially what it did was that any point where it saw the hyphen, is broke the left and right elements up. So at this point, it saw that it had an hyphen between Python and is. So it broke this element and it broke these entire elements together. Then it's moved to the next string, and then moves to the next element. Then it saw an hyphen here. So it broke this one and broke this one apart. So it just helps to separate all the elements in the split method just helps to separate all the elements using a unique separator. Although if you don't pass in a unique separator and if you leave it empty, it will try to separate using just white space. So that is how the dot split method works in Python. Now, the next one that I am going to be teaching you is the dot replace. So let's say I create a new string and I say, and I call it introduce. And I equate this to my name is Solomon. Now, what if you wanted to replace this string? What if you wanted to replace this name Solomon with something else? What we can do is we can make use of the dot replace string method. Now, what the dot replace string method does is that it basically takes in two values. So it takes in the value that you want to replace, and it takes in the new value that you want to place. It takes in the value that you want to remove, and it takes in the value that you want to, the new value that you want to place in. So if I wanted to replace Solomon with Daniel, for example, what I can simply do is that I can say new text is equals to introduce dot replace. Now, what do I want to pass into replace? The first thing is we need to pass in what value we are trying to replace. So since it's Solomon, I'm just going to pass Solomon in as a string. And then the next thing that we need to pass in is the actual value we're trying to replace it by. So I will just pass in Daniel. So what I can then do is I can come down and print new text. So once I save and run the program, instead of printing out, let me show you this. Instead of printing out my name is Solomon, you can see that my name is Daniel gets printed out. That is because in this new variable, we equated it to this string, which is introduce, dot replace. And we said go into this string, then wherever you find Solomon, replace it with Daniel. So the first item that you always pass into the dot replace is the value you are trying to remove. And then the second value is the new item that you are trying to insert into the string. So these are just the few string methods that we are going to be talking about. Now you have a whole lot more, and I actually have a lot of them open right here. I'm going to be leaving a link in the description of this subtopic. So I would like for you to visit this link, or you can just check it out from the video right here and visit it. So essentially what we have here is a list of Python methods which we can apply in our program. You can see that we have a lot of Python string methods right here, and we talked about a few. For example, if I can find the dot upper, we talked about the dot lower, which is here, and we talked about dot upper, which is here. So the good thing is that if you want to practice, what you can do is you can just select any one of them, and when you select them, it takes you to a page that actually shows you how to implement it, how to use it. So it shows you an example, it gives you an example, and it shows you the results when you click try it yourself. So for example, if I click try it yourself, it shows you the result. So I would highly recommend that in order to practice more string methods, you should come to that you should come to this specific page. So for example, if I wanted to use does capitalize, we can see the description of what it does here. It says it converts the first character to uppercase. So what I would do is in this string, let me just separate it now and just put Python is fun. So what I can do is I can change it from upper to capitalize. Now, once I say a sentence or capitalize, I want you to notice what gets printed out. You can see that it now says Python is fun. So you see that the first item, the first element, which was Python, has its first word, has the first letter being capitalized. So here, Python started with a lowercase p, but when we run the program, we can see Python started with an uppercase P. That is what the capitalize method, string method does. So these string methods are going to be used quite a lot, and I cannot stress and I can't overstress the importance. So I would highly recommend that you practice a bunch of these string methods. So let's just take a few more examples. So we're going to use the index. So the index searches for a string, searches the string for a specified value and returns the position of where it is found. Now, if you remember, in a previous session, I explained that every single item or every single character in a string has an index. For example, now P in this string has an index of 1, Y has an index of 2, then we have 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12, and so on. So every single character, including the white space itself, has an index which represents the position in the string. Now, what we can do using this string method .index is that we can find the specific position of an item in a string. So let's say I wanted to find the position of f in this string. What I can just do is I'll create a new variable and I'll say position of f is equals to, and I'm going to equate this to sentence dot index. Now, what do I want to find? What is the index that I want to find? Since I want to find the index of this specific character, which is f, I am just going to pass in f as a string or as a character right here. Now, what this is going to do is that it's going to go into this string, which is sentence, and it is going to search the entire string. And once it finds the first occurrence of that specific character, which is f, it is going to print out that index immediately. So what does that mean? Notice that I said once it finds the first occurrence. So what that means is that if another f exists here, it's going to completely ignore this and it is only going to print out this f because it only searches for the first occurrence. So let me just print out the position of f right now. I'm going to print out position of f. Now I want you to notice what we get when we run the program. You can see we get 10 getting printed out in the terminal. So that means that it shows us the correct index of where that character is. So if we decide to count it now, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you can see that Python properly was able to find the index of f. So if I were to add f here, for example, just to show you that it only finds the first occurrence. Once I run the program, you can see that it gives us 10 again. So even though we have another f here, it's completely ignored it and it only found the first occurrence. So that is basically how the dot index works. It just basically helps us go through a string and search for where and searches for the first occurrence of a specific character of whatever we pass into it. And once it finds it, it prints out the index, which is the location of that item in the string. So we have a bunch more. We have is digits. This one returns true if all characters in the string are digits. So you have a whole lot more. And I will encourage that you come to this page to practice them, as you are going to be using these string methods a lot in your program as you proceed. In this new chapter, we are going to be talking about lists and tuples or tuples. So what I want you to do is create a new folder and call it chapter 6. And inside chapter 6, I want you to create a new file and call it list.py. So let's begin. I have this little definition right here of what a Python list is, which I got from Google. So it says a list is a data structure in Python that is a mutable or changeable ordered sequence of elements. Each element or value that is inside of a list is called an item. So what does this basically mean? So in Python, a list is a data structure that just helps us store multiple values and assign them to a single variable. So before, when we were working with variables, when we wanted to store a value, we had just said like name is equals to Solomon. Now, this way, we are only storing one single value, or we're creating a single string called Solomon, and we're assigning it to name. Now, what we can do is using a list, we can store multiple values in a single variable. So I'm going to show you how. So if we head back to the definition, it says a list is a data structure in Python that is a mutable or changeable ordered sequence. Now, what mutable means basically, it means changeable. So what the definition just basically tries to say is that the values within the list or the list itself can be changed. So when you hear mutability, it means something can be changed if it is mutable. But when you hear immutability or when you hear that something is immutable, it means that the value cannot be changed. So the values of a Python list can be changed, as it says it's a data structure in Python that is mutable or changeable, and it's an ordered sequence of elements. So what that means is that a list can store multiple elements and you can create a list to store multiple elements and you can assign it to a variable. Now it says each element or value that is inside a list is called an item. So I'm going to show you exactly how to create a list right now in Python. So let's say we want to create a list and we want to store the names of students. So I'll create a variable and I'll call it names of students. And I'm going to equate this to this square bracket. Now, what you have here are square brackets, and this is what you use when you want to create a list in Python. So once you create this square bracket, you now need to pass in what values that you want to store in this list. Now, because I want to store names, the first name is just going to be Daniel, and then the second name is going to be Jackson, and then the last name is going to be Bella. Now, what do we have here? We have three names being stored inside of a list. So we have three strings, Daniel, Jackson, and Bella, and we're successfully able to create a list to store all of these values and assign all of those values to a single variable. So what we can now do here is that we can come down to print names of students. Now, once I save that and run the program, I want you to notice what it gives us. As you can see, it just prints out the list back to us. And the way that we can even know what data type it is or what data structure it is that I'm just going to use the type inbuilt method that Python gives us. And then what I'm just going to do is I will print the type. So once I run this program, you can see it gives us a class of list. So that tells us that the variable names of students, it's storing a list data structure. So that is how we can, create a list and determine exactly what data type the variable is storing. So I would just like to clear this out and just print names of students. Now, if you remember in a previous chapter when we were talking about string methods, we had spoke about using the split method, if you remember. Now, the split method, which we had talked about, splits up a string using a unique separator. And then when it splits it up, it returns a list back to us. And then we then printed out the list here. So what I can do is I can come here and put the hyphen between each of these uh, items in the list or in the string, I mean. And when I print it out, you see that a list is being returned back to us. So the list just basically helps us store many elements and assign this to a single variable. Now, I want you to note that inside a list, you can store more than just strings. In fact, you could store a number of things in a list, and you could store different data types in a list. So, for example, I could also come here and put like an integer, and then I could put a comma and store a floating point number. So, a list is capable of storing different kinds of data types or data structures within it. So, this is what makes the list very, very dynamic, as we can store not just strings, we could store strings, we could even store booleans, and just we could pass in through here, and this is completely valid. So once I run it and print it, you can see that it just prints that value exactly back to us. So we could store different values inside a list. We could even store a list inside a list. So I'll show you how. So I can even come here and create a new list, and in here I can just pass in like two new names and say like Solomon. And then after saying Solomon, I could pass in David here. So this is just to show you that the list data structure is very, very dynamic. So as you can see, I have a string, an integer, a floating point number, a boolean, and even another list stored within the list. Now you could even go crazy and then store a different list inside this list, but you get the point of how we could store multiple values inside a list. Now a list, again, like I said before, is mutable, meaning that the values within this list can be changed and the entire list itself can be changed. So for example, I can come down and redeclare this list. So I can say names of students is equals to just DG, and then I could store like Hannah. And then once I run this program, you can see that even though names of students was first declared to be this long list, we now came down here and redeclared this to this short list. And you can see that this is what gets printed out in the terminal. So that is to show you that lists are mutable, or the variable itself is mutable. We can change the value. The next thing that we are going to talk about is how to actually access elements in a list. So I want you to create a new file and call it access underscore lists underscore elements dot py. Now, once you've done that, please just open the file and navigate to it. So what I'm going to show you in this section is how to access elements of a specific list. Now, if you remember, when I was teaching you about strings, I told you that when you create a string, there are ways that we can access specific values of specific items in a list. So I believe that is in chapter 5. So right here, I had showed you that anytime we want to access a specific character from a string, we can make use of the index of that string, of that specific character in the string. Now that exact concept that concept is the exact same thing when we're working with lists. So let's say I create a list and it just stores names, and it's going to store Solomon, it's going to store David, it's going to store Bella, and it's going to store Aaron. Now we have all of these names right here in this list. A comma needs to be here. Now we have all of these items in this list. Now imagine we wanted to access any single value from this. Say we wanted to print out a single value. What we can do is we can make use of indexing. Now, just like how we were accessing specific characters in a string, we can also use indexing to grab specific items from a list. And then starting from the first item, it always has an index of 0 by tradition. So Solomon is going to have an index of 0 because this entire string represents a single element in this list. And each element have a specific position, and the index represents the position of that element in the list. So if we are going to be following the same traditional method, Solomon is going to have an index of 1. David is going to have an index. Sorry, Solomon has an index of 0. David has an index of 1. Bella has an index of 2. And then Aaron has an index of 3. So what we can then do from here is that we can then access each of these elements or each of these items in this list using their specific index. So if I wanted to print out David, for example, I'm just going to come here and print names, and then I'm going to create this square bracket. If you remember from these square brackets, if you remember using these square brackets when we try to access characters from strings, it's the exact same thing when we're trying to access elements from a list. So you first of all write the variable name that it has been assigned to, and then you put square brackets. Now inside the square bracket is where you pass in the index of whatever element you are trying to access. So since it's David, I'm just going to pass in 1 because David has an index of 1. And once I run this program, you see that David gets printed out in the terminal. Now, there's something interesting that I would like to show you. If you remember from string methods, I told you that you could access specific characters from a string. Now, what if from this David string, after we get David, what if we wanted to print out, let's just say D from this David? What we can do is we can then create a new variable, and I'll call this new variable name instead of names, and I'm going to equate this to names of 1. Now, at this point, when we go into the list and grab David, this is what gets returned to us. So just imagine that this name variable is equated to this list called David. Now, if you remember, I told you that every single item in a string has an index. So if I wanted to use indexes, D is going to have an index of 0. A is going to have an index of 1. Sorry, let me just remove this. A is going to have an index of 1, and then 2, 3, 4. So if we now wanted to use the print statement to print out just D from this string, what we can do is we can write a print statement and print name of 0. So I'm going to explain this, but once I run it, you see that we have D just getting printed out. Now let me explain what happened here. We first of all grabbed the first item in this list using its index, and we said name is equals to names, which is the name of the variable that stores the list, names of 1. So it goes into this list, grabs David, and assigns David as a string to this variable. Now, what we now did next was that we wanted to print out the first character in this string, which is D. Now, because every character in a string has an index position, we could just simply access D using the index position of 1. So we now printed name of 0. So what Python now did was it went into this name call of David, and then it grabbed D, which is the first item, and it has an index of 0, and it printed it out. So that's exactly how list indexing works in Python. Now, there's also something else that we can do using list indexing. So I will just remove all of this. Now, just like string indexing, we can perform slices on strings, on lists, I mean. So what does that mean? Imagine you wanted to only print out Solomon and David. Now, what we can do is we can perform a slice on this list, just like how we had explained slicing in strings. We can perform a slice on this list to only print out 2 items from this list. Now, how exactly do we do that? I'm just going to write a print statement. And I'm going to say print names. Now, we're going to print names starting from what index and ending at what index. We're going to start at the 0th index, and I want you to guess where we are going to stop at. Do we stop at 1? Do we stop at 2? Do we stop at 3? Now, bear in mind that we only want to print out Solomon and David. Now, if you guessed 2, you are correct, because if you remember, I said that the stopping index will not be picked up. That is, if we put 2 at the stopping index, what Python does is that it stops at the stopping index minus 1. So what that means is that if we put in 2, It's going to start at 0 and stop at 1. If we put in 1, it's only going to stop at Solomon. So what we're going to do is we're going to say starting from 0 and stopping at 2, so that Python is going to print out these two items. Now, once I run this program, you see that we have only Solomon and David getting printed out in the terminal, because what we did was we created a slice of this list, and we created a slice of this list using the index. Now there's also something else that we can do. Instead of passing in 0, I can say I just want to print everything starting from 0 and ending at 2. So by default, Python is just going to put a 0 here, so we don't have to specifically pass it in. So what we're telling Python is that starting from the first element, which has an index of 0, we want you to grab all the elements that stop at, we want you to grab all the elements until you reach this index. And once I save that and run it, you see that we still have Solomon and David getting printed out in the terminal. So this is exactly how we can use indexing. Now remember that we had discussed two types of indexing, which was going from left to right when we're talking about strings. Now we could also use negative indexing by going from right to left. So if I wanted to print out Aaron is going to have, let me just put um, the comment here. Aaron is going to have an index of -1. Bella is going to have an index of -2. This is going to have an index of -3. And then this is going to have an index of -4. So, okay, let me just shift that in properly. Okay. So now we can see that each of these items, we can see that using negative indexing, each of these items, starting from the left, have a negative index. Starting from the right, have a negative index. And it always starts from -1, as opposed to starting from the left, which is 0. Now, if I wanted to print out Aaron, all I simply just have to do is print names. And inside the square bracket, I'm going to pass in -1. So let's see what that gives us. Once I run it, we can see we have Aaron getting printed out in the terminal, because negative indexing helps us grab items from right to left. There's also something else that I would like to show you, which is performing a slice on a list using negative indexing. Just like how we were able to successfully perform slices using positive indexing from like 0 and stopping at 2, we can also perform the exact same operation using negative indexing. So what we are going to do is, imagine we want to print from Solomon and stop at Bella. Now we know that Solomon has an index of -4 and Bella has an index of -2. So what that means is that if we want to print from Solomon to Bella, we're going to start from -4, and since we're stopping at Bella, we're going to pass in the ending slice as -1. So once I do that and run this program, you can see that we get Solomon, David, and Bella being printed out, because we told it starts from -4 and stop at -1. So it just printed out Solomon, David, and Bella. So that is exactly how indexing and slicing works in Python lists. We are then going to move to talking about list methods. So Python gives us some inbuilt functions or methods that we can use to manipulate lists and perform some specific actions on lists. Just like how we had string methods, we also have list methods, which are functions, inbuilt functions or methods that we can use to manipulate lists in Python. So what I have here is just a number of the Python list methods that we can carry out. I'm going to leave the link to this page in the description of this subtopic, but you could just, always look at it from the video. But the link is going to be in the description. So we are going to be talking about a few of these list methods and how we can use them to manipulate lists in Python. So what I would first like to do is head back to my Visual Studio Code, and I will create a new file inside chapter 6, and I'll call it list_methods.py. Now inside this list methods, I am just going to create a new variable, and I'll call it names and equate this to Jane and Samson. So I have created a list, and I am storing two strings or two values called Jane and Samson. Now we're going to be performing a few manipulations on these strings to show that we can, we're going to be performing some manipulations on this list using the list methods which Python gives us by default. So what I'm going to do first of all is I'm just going to come down and print out this variable called names. Now, once I run it, obviously you're going to see Jane and Samson printed out to the screen. But what I will now do next is that I am going to make use of this first list method, which is called append. And what append does is that it adds an element to the end of a list. Now, what I would like you to do is, I am not going to talk about all the list methods right here. But what I want you to do is, after this video, I want you to come back and practice some of these string methods, as a lot of them are very, very useful. So I'm going to talk about the append method first. So what the append just basically does is that it just adds a new value to the list. Now, what if we wanted to programmatically add a new value to the list? We could come here and just simply add like Samuel to the list. But here we have to do it manually. Imagine we wanted to do it programmatically. So we can use the append list method, which helps us add a new value to a list. So say I wanted to add Samuel to a list. What I will just simply do is I'll say names.append. Now, what do I pass into append? We can append, what do I pass into append? I pass in the value that I would like to add to this list. So I'm just going to pass in Samuel. And then what I will do next is, after appending Samuel to this list, I will then print out the list again just to show you. So once I run it, you can see that the first list gets printed out, and we have just Jane and Samson being printed. Then here, I came and added a new value. I appended a new value called Samuel, and then I printed the list again. And you can see I now have Jane, Samson, and Samuel. So the append method just basically helps us add a new value to the list. Now, the next method that we're going to talk about is the clear method. So as you can see, the description here says that it removes all the elements from the list. So say you have a list and you want to just automatically remove all the items from this list. What you can then do is come down and say names.clear. Now, once you say .clear, Python is just going to automatically delete all the items in this list. So I will come down again and I'm going to print the names just to show you that it is empty. I'm going to run it. So you can see that the first time we have Jane and Samson because we created the list and Jane and Samson were the default items. Then we came and added Samuel and printed the names list, which is why we have Samuel here. Then we came down here and said names.clear. So .clear now went into the list and removed every single item in the list. And when we printed it out, we then had an empty list being printed to the screen. So that is what the clear method does. Then we can talk about the index method. Now, the index method returns the index of the first element with the specified value. Now, if you remember from the string methods, when we wanted to find the position of a specific element in the string, we had to make use of the index method. We can do the exact same thing in Python, in lists. So let's say, for example, we wanted to find the position of Samson. What we can do is we can use the index method. So I'm just going to come down here and print the index. So I'm going to print names dot index. Now inside index, I have to pass in, sorry, this is a typo. I have to pass in the value of, I have to pass in the value whose index I am trying to find. I'm just going to pass Samson in because let's just say we're trying to find the position of Samson in this list. So once I run this program, you can see it prints out 1. That is because Samson indeed has a position of 1 in this list. You know, we're going to start from 0. So Jane has an index of 0 and Samson has an index of 1. So therefore, we are able to grab whatever, we're able to print out the position of Samson in this list. So that is what the index method does. Now, the pop method removes an element at a specified position. Now, let's say, for example, we wanted to just remove a specific element from this list. Now, we wanted to remove the element using its index. That is what pop does. So I will just remove all of this. And then let's say I want to remove Samson from this list. Now, since we know that the index of something is 1, what I can just simply do is I can say names dot pop. And in here, I'm going to pass in the index, which is 1. Then after passing in 1, I will just come down and print names. So once I do that and save this program, you see that we first of all have uh, Jane and Samson being printed from the list. Then once I said names.pop of 1, we told Python go into this list and remove the element that has an index of 1, and then we printed it out. You can see that we now have only Jane being printed out. So those are the so that is how the pop method, list method works in Python. And those are the only ones that I will teach you about. You can see we still have a number of them. We have count, we have copy, extend, insert. Insert adds an element to a specified position. So instead of append that just adds it to, it adds the item to the end of the list. When you say insert, you can insert a new item to any position. So you could even tell it to insert that item to position 1 or position 0. So what I want you to do is I want you to practice each of these list methods, as I will not be teaching you everything because I want you to practice some of these on your own. And if you have any question, please feel free to ask and I will definitely get back to you. In this next part, I would like to teach you how to update values in a list using indexing. So I want you to create a new file and call it update values.py. So update underscore values.py. Now, once you do this, I am just going to create a new list and I'll call it names is equals to Solomon and then Jane. Now, let's say, for example, I wanted to update Solomon to a different name. Since we know that Solomon has an index of 0 and then Jane has an index of 1, what we can do is we can update these values inside this list, or we can update these elements using their indexes. Now, remember that when we wanted to access elements, all we simply do is, say I wanted to print out an element, all we simply do is say print out the name of the index. And in here, let me just pass 0. And then once I do this, you see that it gives us Solomon. Now, what we can do is we can actually update the value at that 0th index. So what we are going to tell Python is that go into this list, and as the 0th index, we want you to put a new value. So what I will do is, instead of printing out just Solomon, I'm going to print out the entire list. Now, before printing out the entire list, what I will do is I will update the value of Solomon to something else. So I'm going to say name of 0 is equals to James. Now, what do we have here? I have told Python that, okay, the 0th index of this name list, I want you to replace it with James. That is, whatever value is at this current index of 0, I want you to go in there and replace it with this value of James. And once I run it, you can see that even though when we created the list, it was defined, Solomon was defined to be in the 0th index. Now we now came down here and we changed the value that is stored in the 0th index to James, which is why we see James getting printed out finally in terminal. So this is basically how you can update values in a list. So we could also do the same for the second item. So I can say name of 1 is equals to Tessa or something like that. And once I run it, instead of seeing Solomon and Jane, we see James and Tessa. That is because we had replaced the values. Sorry. That is because we had replaced the values of the two items using their indexes. So again, we just say go into this index and assign it a value of this. Go into the index of 1 and assign it a value of this. All right. So the next topic that we're going to talk about are tuples. So I want you to create a new file inside chapter 6 and call it tuple.py. That is Tuple. Now, I would like to explain what a tuple is. So I have this definition which I got from Google, and it says a tuple is an immutable, that is unchangeable collection of various data type elements. Tuples are used to keep a list of immutable Python objects. The tuple is similar to list in that the value of the items placed in the list can be modified. However, the tuple is immutable and its value cannot be changed. So let us briefly discuss this. Now, when we spoke about list, we explained that a list is just a collection of elements which we can store. A list is basically a collection of elements. Now, these elements can be different data types. And I also showed you that you can update the values of elements in a list. Now, a tuple is very similar to a list in the sense that it itself can indeed store it can indeed store a collection of different data types, but what you can't do is that you can't update the values in a tuple. Now, right here, it has been said that a tuple is an immutable collection of various data type elements. What that means is that once you declare a tuple, you can at no point in time change any value that exists within the tuple because it is immutable. So let's see how to create a tuple. So in order to create a tuple, you just type in the variable. I'm going to say names is equals to, and then you open parentheses. And inside this parentheses, you pass in the values which you want to store. So I'm going to say James, Daniel, and then David. Now, you can say that the key difference when creating a tuple is that the key difference between creating a tuple and a list is that when you have a list, we use square brackets. But then when you have a tuple, but when you have a tuple, you use you use the curved brackets, which are parentheses. So this is the basic way of creating a tuple. And then what I can do is I can just print the type of names just to show you that this is indeed a tuple data structure. So once I run it, you can see it gives us a class of tuple or tuple. So that tells us that we are dealing with a tuple data type. Now, this can also store data types of different ranges. For example, you could even store a list in a tuple, right? And I can say this is Daniel. No, okay. So we already have Daniel. Let's just say, okay, instead of storing a list of names, let's just store a list of ages, for example. So let's say we've created these three items in this tuple: James, Daniel, and David. And as the fourth item in this tuple, we want to create a list to store their ages. So I can say 30, 56, and 73. Now, what we can now do is we can print out this tuple called names. And once you print it out, you can see that we have exactly what we had defined, just a list that contains strings and a list. So a tuple is also perfectly capable of storing elements of different data types. Now, I want you to note something that I hadn't mentioned in the list. Now, once you pass in items into this tuple, each of these represents one entity. For example, this string is one entity. This string here is one entity. And this entire list here is one entity. So if you wanted to use indexing to access an entity, you know that we use their indexes obviously to access each element or each entity in a list or a tuple. So for example, James has an index of 0, Daniel has an index of 1, David has an index of 2, and then this entire list has an index of 3. So if you wanted to access any element, if you wanted to access this entire list, we know that this entire list has been assigned an index of 3 because it acts as a single item in this tuple. The same can be said for a list. When you store, like for example, a list inside a list, the list that is present inside the list has its own index. So this is just to show you that every single element is grouped together as one entity. Now, if we wanted to, say for example, print out this list, I'm going to show you exactly how to do that in the next chapter where we talk about accessing elements in a tuple. So what I want you to do is I want you to create a new file and call it access underscore tuple underscore elements dot py. So we have created this file, and what I will just do is I will just copy this names variable right here and I'll paste it in. Now I will also copy the index which I had written there just so you have a visual representation. Now we have this variable names and it is assigned to a tuple. Now if we want to access any specific element using the index, what you can do is you can, sorry, if you want to access any specific element within this tuple, what you can do is you can access that element using the index. So let's say I wanted to access a specific name. I can just say name, that's I'm creating a new variable and I'm calling it name. Name is equals to names. And in here, I have to pass in the index position. So let's say I wanted to access Daniel. I will just pass in 1. And then what I can then do is I can come down and then print name. So let's see what that gives us. Now, once I run it, you see that we have Daniel getting printed out. So you see that this indexing concept cuts across not just strings, it cuts across strings, tuples, and lists. So you are going to be making use of indexing a lot when you're writing your programs. Now, what I will just do next is that I will show you how to access this entire list, which is an item in the tuple. So let's say I wanted to get their ages. I'll create a new variable and I'll call it ages is equals to names of, and what is the index? 0, 1, 2, 3. So I'm just going to pass 3 into this index and I'm going to print ages. Now, once I do that, I'm just going to click run. And then you can see that we have this list getting printed out, 30, 56, and 73. So you can see now that we're able to access this entire list as one entity or as one element using the index. Now, since we have this entire list being stored in this ages variable, we can then decide to grab one specific item or one specific age from this list. So if I wanted to grab 56, for example, I know that the first item has an index of 0 and 56 is going to have an index of 1. So I can come here and I can print ages of 1. So once I run this program, you see that we have 56 being printed out to the screen. So that is exactly how we can access elements in a tuple using indexing. All right, so now I'm going to teach you exactly how we can perform slicing or perform slices on tuples. So it's the exact same process that we use for lists that we use for tuples. So let's say, for example, we only wanted to print out all the names from this tuple and ignore the ages. What I can do is I can just write a print statement, and in here, I'm going to print names, and then I'll pass in the square bracket. So you remember, the first thing we have to pass in is the starting index, which is 0. And then the last thing we have to pass in is the stopping index. Now, because we want to stop, we want to only print James to David, we're going to put 3 as the stopping index because the element at index 3 doesn't get printed because it is a stopping index. I'm going to put 0:3. And then once I do that and run the program, you see that we have James, Daniel, and David being printed out. So we could also just remove this 0 and save it and only leave :3. And you see that we have the exact same value. So essentially, the same indexing and the same slicing concepts apply to both strings, lists, and tuples. So that is exactly how we can perform slices on tuple items. So in this section, I'm going to teach you the 2 basic tuple methods that you can apply to tuples. So it says Python has 2 inbuilt methods that you can use on tuples to basically, perform a bit of not really manipulation because you aren't really changing any values. So we have 2 methods. The first one is count. Now the count basically helps us to return the number of times a specified value occurs in a tuple. So what I will just do is I will create a new file and call it tuple method. So tuple_methods.py. Now what we're just going to do is we're going to create a new tuple that is going to store a list of that is going to store a bunch of names. I'm going to say like Solomon, and then I'm going to say Daniel, and I'm going to say James. Now let's say I wanted to count the number of times that Solomon occurs in this tuple. So what I can just do is let me just add one more Solomon. Now let's say I wanted to count the number of times that this string Solomon occurs in this tuple. What I can do is I will just print out name.count. And in here, I'm just going to pass in the string that I'm trying to count. I'm going to say Solomon. So what Python is going to do is it's going to take this value and count the number of times that it occurs in this tuple. So once I save this and run this program, you see that we get 2 because Solomon occurs 2 times in this list. Now note that if I change this S from an uppercase S to a lowercase s, I want you to see what we get. So once I run it, you see we only get 1. That is because it looks for the exact occurrence of this specific value in your tuple. So because we have only one Solomon that starts with an uppercase, that is why it returned 1. So that is exactly what count does. It just takes in a value and looks for the number of times that value occurs in the tuple. Now we also have this count method for the list, and it functions the exact same way. Now, the next one is the index. So we had talked about this when we were talking about list methods. So the index method just basically searches the tuple for a specified value and returns the position of where it was first found. Now, note that we have, let me just change it from an lowercase to an uppercase s. Now that we have 2 Solomons, or we have 2 occurrences of Solomon in this tuple, what I will just do is I'm going to say name.index. Because let's just say, for example, I'm trying to find the index of where Solomon exists in this tuple. What I will just do is I will save it and run the program. And now you can see we have 0. So even though Solomon exists at this point also, what Python just did was it returned the first occurrence of that specific element. Because it found that Solomon existed here first, it just immediately grabbed the index and ended the program and then printed it out. So that is exactly how the index position and the index tuple method works in Python. Now, in this section, I'm going to show you how we can combine a for loop and a list item. Now, remember that when I was explaining for loops, I told you that a for loop is used to iterate or go over a sequence. Now, that sequence could be a string, it could be a list, it could be a tuple. So if I try to access our for loop class, here I had showed you how to print out all the items from a string one by one. So here we looped through the string called Solomon. Now we can also do the exact same thing using lists. So let's create a list and call it names. And in here we're going to have Jane and then John. We're going to have Sarah and then, and then we're going to have Solomon. Now, using a for loop, we can actually loop through and go through each item in this list. So I'm just going to write a simple for loop that is going to print all of these items one by one. So again, if you remember the structure of a for loop, we first write the for keyword, and then we write the iterator, which is going to be I or any other item. So I can change it from I to name. So I can say for name in names. So what we're simply trying to do is we're trying to loop through this entire list, and then name becomes the iterator. So at each iteration, that is at each cycle, name becomes Jane, the first iteration. Name then becomes John, the first iteration. Name becomes Sarah, and so on. I'm just going to print out name. So for name in names, we're going to print name. So once I run this, you see that we have them being printed one by one. We have Jane, John, Sarah, and Solomon. Now we could also do this for tuples. So I can change this from a list to a tuple. And then once I clear my screen and run this, you see that we have the exact same effect. So whether it is a list or a tuple or even a string, be rest assured that as long as it is a sequence of elements or a collection of elements, we can loop through that entire sequence using a for loop. So that is mainly what a for loop is used for. It is used to perform a specific operation for every single item in an iteratable sequence. So I would just try and perform a bit of manipulation on each string. Now, because each name is a string, let's say for each name, I wanted to print out the name in all caps. What I can now do is say name.upper. Now, you might be wondering why I can do this. Now, because we're looping through an entire list and each item in that list is a string, if you remember from the string methods, dot upper converts all the items in the string to uppercase letters. So that is what we can do using for loops. and string method. So once I run it, you see that every single item has been converted into an uppercase. You can see that every single character in all the names have been converted into uppercase letters. So that is exactly how we could combine like a for loop and string methods. So let's say you wanted to convert all the names into you wanted to convert all the names into uppercase, you could do something exactly like this. So this is exactly how we combine for loops and this is how we combine for loops and lists and how we iterate and go through a list using a for loop. So right now we are going to work on a mini project that brings everything we've learned together into one simple project. So this is what we are going to be working on. The question says create a Python program that lets the user add, remove, and display items in a to-do list. Now it is important to note that I had created this mini project.py file inside chapter 6. So all we're simply doing here is we're creating a to-do list, and the user is capable of adding, removing, and displaying all the items in their to-do list. Now, obviously, in to begin, in order to store all the items in the to-do list, we need a list in order to store all those items. So the first thing we're going to do is create this list, and I'll call it my to-do list items, and I will equate this to an empty list at the start because when we're running the program, the list is going to be empty. Now, the first thing is that, or the next thing we need to do is that we need to ensure the program flow always asks the user to impute to select an operation. Now, our to-do list is going to have 4 operations. The first operation will be to display all the items in the to-do list. The second operation is going to be adding an item. The third operation is going to be deleting an item, and the fourth operation is going to be exiting or ending the program. So what I will do is I will write a print statement, which is just going to display all of these operations to the user. So I'm going to say print one. So the first operation is going to be display all users. Sorry, display all items, right? And then we're going to put a \n because what we want to do is we want to display each operation on a new line. So once I put the \n, the second operation is going to be add new item, and then I'll put a \n here. The third operation is going to be delete an item, and then the last operation is going to be exit. So once I just save this and run this program so far, let's just see what we have. You see that this is what we have. It just tells us display all items, add new item, delete an item, and exit. So right now we know that these are the operations that we can perform, right? So what do we now need to do next? The first operation says that we need to display all items. So what I will do is I will just write a simple program or a simple input statement that will ask the user what operation they want to perform, because we need to know what operation they want to perform before we can actually tell the program to proceed. I'm going to create a new variable and I'll call it operation, and I will equate this to an int, and inside this int I'm going to put an input, because what we want to do is we want to collect the operation as a number from the user. I'm going to say select operation, and I'll put a colon and space there. So what we're just simply doing is we're going to display all the operations that the user can perform, and then we're going to ask the user to select an operation. Now what we're going to do is we're going to write if conditions. Now these if conditions are basically going to help us determine what the program is going to perform based on the user action. So the first if condition that we are going to write is going to help us check if the user wants to display all items. I'm going to say if operation is equals to 1. That is, if the user imputed 1. So this double equality just checks if the two values are equal to each other, if you remember when we talked about operators. So if it is equals to 1, what do we want to do? We simply just want to print out all the items in this list. I'm just going to write a for loop actually, because I'll need to loop through this entire to-do list in order to print out all the operations, all the to-do list, all the items in the to-do list. I'm going to say for to do in, or no, for item in my to-do list items, I will just simply print out item. So I'm just going to put a print statement here so that the user properly understands what you're saying. I'm just going to print below are your to-do list items. So I'm just going to write it like that. And then once I save that, let's just test the program so far. So once I run it, you can see that it displays all the options and asks us to enter an operation. Once I enter one, you see that it says below are your to-do list items and the list is empty. Now that is totally okay because what we have done is that we have created an empty list. So at the point of trying to print out all the items in the list, it was empty. So it's printed nothing because there's nothing in the list. Now we're going to move on, and then we're going to move on to the next operation, which is allowing a user add a new item to the list. So what I will do is I will then write an else if here. And I'm going to say if, which stands for else if operation is equals to 2. That is, if the user wants to add a new item to the to-do list, what do we want to do? We now want to ask the user to input what item it is that they want to add. Because it's obviously a to-do list and they need to input whatever it is. So what I will do is I will just create a new variable and I'll call it to-do item. And this is going to be equals to an input method, which is going to help us collect the item. And then I'll just simply tell the user to enter to-do item. I'll just say enter to do item. Now at this point, once the user enters it, we already have it stored in this variable. So what we now actually need to do is we need to save it to this list. Now, if you remember when we were talking about list methods, we talked about a special method called .append. Now, .append just basically helps us add a new item to the end of a list, right? So we're going to be making use of that method. I'm just going to come down and say my to-do list items .append, and in here I'm going to pass in to do item. So once I do that, we can be rest assured that whatever gets entered is going to be displayed. Whatever gets entered here is going to be appended to the list. Now let's test that. Now you are going to notice an issue, but let's just test the code to see. So it says select an item. I can select one, and then you see it prints nothing because at that point there's nothing in the list. Now you also notice that the program ended immediately. Now if I run it again and I enter 2 to add a new item, it asks me to enter a new to do item. I can say upload video courses. And once I do that, you can see the program ends. Now the program ends because immediately that value is appended to the list. There is no other operation there's no other code right here that the program executes, so it automatically ends. But what we want to do is we want to constantly ask the user to enter or select an operation which they wish to perform. But we don't just want the user to enter a new to-do item and then the program ends. The moment the program ends, this list is going to be, whatever data was stored in this list is going to be freed from memory because, when we create variables like this, they actually get stored on the memory. So when the program ends, whatever was stored in that list gets deleted and we have to start again. So what do we need to do? We need to write a while loop, which is going to constantly run all of the code inside it unless the user selects that they want to exit the program. So what I will do is I'm going to just write a while loop here, and I'll say while true. Now, while true means that we want to run this loop forever until some operation within the loop breaks it. So what I will now do here is I will save it, and I want you to see what happens. So let me just clear my screen first and then run this. So now it's going to ask us to select an operation, and I'm just going to say display all items. So it says below are your to do items, and you can notice that nothing gets printed out because it's empty. Now notice that it is then asking us to select an operation again. So the reason why that is happening is because when we entered an operation, right, we checked if the operation was equals to 1. The operation was equals to 1, then we printed out all of the values in the list. Then we came down, this else if block wasn't executed because this condition wasn't checked. Then it came down and saw that no other code existed. So it came back to the loop and executed the loop again. and then going down into the loop body, it asks for the operation. So it's just going to continually perform the same operation until a certain condition is met, which breaks the loop. So what I will do next is I will just add a new item. Now it says enter to do item. I will just say upload video course. And once I press enter, it says select operation. Now, since that's what I had just entered has been saved to the list right here because you told it to append it, what I can then do is press 1 to display all items. And when I press 1, you can see it says below are your to-do list items, and then it's prints out upload course video. So that shows us that our program is actually running successfully and we're able to add the feature to display and add a new to-do list item. Now, I would just like to proceed. But before I proceed, I would like to end the program. And in order to terminate a running program, all you just have to press is Control C, which is the show, which helps to interrupt whatever operation is happening. It's called keyboard interrupt, so it automatically breaks the program that's running. All right. So moving on to the next step, we want to delete an item from the list. Now, deleting an item is going to be like a bit of a tricky part that we're going to write, because if you remember from our list methods, when we wanted to remove a specific item from a list, we made use of the dot pop operation. If I can check lists, okay, list methods, let me just check for you right here. So when we wanted to delete a specific item, you remember that we had to use the dot pop method, which takes in the index of the item that we're trying to delete from the. So what I can then do is I can use this specific method to delete an item. But the issue is we need to figure out the index of that specific item, because I could say I want to delete, the third item, but if I don't know the index, there is no way for me to remove it from the list. So what we're going to do is we're going to change this for loop a bit, and I am going to show you exactly how we can, tweak it to make it work exactly how we want. Now, in order to properly display the index, Python gives us a very special method which is called enumerate. So what enumerate does is that it returns to us the item in a list or in an iterable sequence, and its index also. Now I'll show you exactly what I mean. So in order to proceed, we are going to change this for loop a bit. So what I will write is for index, comma, item in, instead of passing in the list, I'm just going to say enumerate of the list. Now, what exactly does this enumerate do? Or what does it, what function does it perform? It takes in an iterable sequence, so like a list, for example, right? So it takes in a list, and then what it does is that it returns the index of every item, the index and the item itself. So unlike the traditional for loop that we just used to, loop through a list, what this enumerate does is that it goes through the list and it also returns, as it returns a specific item, it also returns the index of that item. So what we can do now is that we can use an F string to format it. So what I will pass in here is index, and I'll put dots, and then I'll put in the item. So when we are going to be printing out all the to-do items that exist, we are going to see the index as well as the item itself. So once I run it, I'm going to go over this again, but let me just run it. So what I'll do is I'll first of all add a new item. I'll say upload course videos, and let's just add a new item also. I would say do the dishes. Now, once I select one to display everything, you can see that we have the index being printed out. The index of that item dot upload course video. That is because I had added two items, upload course video, and once I added that item to the list, it had an index of 1, or an index of 0 because it was the first item in the list. Now, the moment I added do the dishes, this became the second item in the list with an index of 1. So that is why we see the index of do the dishes to be 1. So what the enumerate method basically just does is that as you are looping through the list, it not only grabs that specific item or that current iteration, it also grabs the index of that. It also grabs the index of that specific item. So it returns the index of the item and the item itself. So that is how we're able to grab the index. Now that we're able to display both index and item, what we need to do is write the feature to delete an item. Now you remember from the delete method, we're going to be making use of the pop method to delete an item using its specific index. So I'm going to write an else if block. I'll say L if operation is equals to 3. That is if the user selected 3. What I'm going to do is I'm going to ask the user to enter the ID of the item that they would like to delete. So I'll just create a new variable and I'll call it item ID is equals to int because we want to collect it as an integer. And then I'm going to say input and I'll say enter item ID to be enter ID of item to be deleted. Let me just say enter ID of item to be deleted. So this is just going to help us collect the ID of whatever the user wants to do. Now, once I collect it, what we're just simply going to do is we're going to we'll remove that value from list. So I will just do my list, my to-do list items dot pop. Now in here, I'm just going to simply pass in the item ID. So once I save that and run this program, let me clear my screen. Once I save that and run this program, it's going to ask us to, I'm just going to add a new item. I'll say do the dishes, and then I'm going to add a new item and say upload course video. Now I'm going to display all the items. And once I do that, you can see that we have all the items being displayed with their IDs. Now let's say I want to delete an item. I am going to select 3 to delete an item. So I'll enter 3, and then it asks us to enter the ID of the item to be deleted. So let's say I want to delete do the dishes. I'm just going to enter 0. And once I enter 0, it tells us to select operation. So I'm just going to select 1 to display all the items. And as you can see, do the dishes has been deleted. And then upload course video is now the only item in the list. And you can see that upload course videos index changed from 1 to 0. Because the moment the first item, which was do the dishes, was removed, it means that the index position of 0 had to be filled. So it means that the only item in the list became upload course video. And then it had an ID. And the ID changed from the index, changed from 0 to 1. So that is exactly how we can make use of the .pop in order to remove an item from the list. Now the last operation to be performed is the exit. So I will just write an else if block here also, and I'll say if else if operation is equals to 4. Then what do we want to do? We just want to break out of the loop. So what break is going to do is it will just terminate this while loop and the program is going to end. So once I run this program right now, sorry, let's run the program again. It's going to ask for an operation. Once I type in 4, you can see that the while loop just breaks and the program ends. So this is basically how to combine all the concepts that we've talked about so far in order to create, like a full project. So right now you've created a to-do list. You can add as many items as you want and delete as many items as you want. Now I know that the printout wasn't really pretty per se because I could enter 1 and then the text is kind of jam-packed together. What you could do is you could just even add like a print statement. For example, you could add a \n here to create a new line and so forth. So let's just run that again. Sorry. Let's just run that again. And if I enter 1, for example, you can see it says below are your to-do list items. It gave a space. So you could add, like line breaks to make everything look, spaced and neat. So we've basically combined all the concepts that we've talked about to make this one simple project. If you have any question, please definitely reach out to me. So thank you, and I will see you in the next one. In the next chapter of this course, we are going to be discussing dictionaries. So I want you to create a new folder and call it chapter 7. And inside chapter 7, I want you to create a new file and call it dictionaries. Dictionary. Now, once you do that, just please open the file. Now, I am going to paste this simple definition, which I had copied from Google, and I would like to share it with you. So as I will just be using the definition to explain basically what a dictionary is. So it might be confusing at first, but trust me, it's very easy. So it says dictionaries in Python are unordered mutable collections. Mutable meaning that the values can be changed. So dictionaries in Python are unordered mutable collections that store data in key value pairs. They are used when you need to associate unique keys with specific values, similar to a real world dictionary, where keys map to definitions, values. So it's just like you have a dictionary, like a dictionary, the book itself, and then you open it looking for the meaning of a word. Now, every word is mapped to a definition. That is when you want to search up the word, like, let's say you want to look for the meaning of complicated. You open a dictionary, go to the C section, and you search for the word named complicated. Now, complicated itself is the key, and the definition of complicated is the value. So that is why it's like called dictionary. They got the name of this data structure from the dictionary itself. So the dictionary just helps us to map keys to values. So these keys are like unique because in a dictionary, you can never have two definitions or two occurrences of the same word, or although you can have like different explanations in the value of the explanation. So that is basically what a dictionary is in Python. They are just a collections that store data in key value pairs, and they are useful to associate unique keys with specific values. So you might still not understand how to. You probably don't understand how to, write it. So I'll give you the basic structure now in order to create a dictionary. So in order to create a dictionary, first of all, you need to create a variable name. Let's just create a variable called student, right? And then we are going to assign this variable to a dictionary. Now, in order to create a dictionary, first of all, you have to open this curly bracket, opening and closing curly bracket, and then you can press enter. Now, inside this dictionary, we are going to be storing the name of the student, the age, and the grade, for example, in a course. So we're going to be storing the name of the student, the age, the course name, and then the grade. So in order to do that, we are just going to put in a quote. It can be single quotes or double quotes, and it can be name, and this is going to be equals to John Doe, as we can see here. Now, once you do that, make sure that you put a colon after the first item, and then uh, you put in a string also the name of the person. Now, it is also good to note that a dictionary can store data, multiple data types. So just like a list that can store, a list, it can store a string, it can store a list itself. A dictionary can also store multiple data types as values. So they can store even other dictionaries as values. You can store lists as values, you can store integers, booleans as values, and you are going to see exactly. Now, the second item is age. So what we want to do is we want to store the person's age, and we create a new key, which is called age, and we assign it to the value of 20. Now, the next item that we are going to create is the course, COURSE, is the course name. So in here, we are going to be storing, let's just say algebra, for example. So let's just say this user took algebra. We're going to store the course name as algebra. And then let's just say the course code, oh no, not course code, sorry. Let's just say the grade is going to be like let's just say 70.89. Now, what we have basically done here is that we have created a dictionary, and this dictionary is broken down into key value pairs. So what does that mean? This is a key, and this is a value. So that is why it is called a key. That is why they are called key value pairs. Now, it is important to note that you must put a comma immediately after a line. If not, Python is going to give you an error. But you don't have to put a comma after the last line. Now, so these are key value pairs. We can associate specific keys to specific values, and dictionaries basically help us store data in key value pairs. So you might be wondering, how exactly can we work with a dictionary in Python? Because we've looked at how to work with a list, how to work with a tuple, a string. How exactly can we work with a dictionary in Python? So the first thing that I would do is I would just like to print, sorry, I would just like to print students, and I want you to see what it gives us. So once I run this, sorry, let's run that. So once I run this, you can see it just gives us the dictionary right back. And then what we can also do is print the type. because we want to see what kind of data type or data structure that this structure or that this figure is. So once I do that, we see a class of dict. So it tells us that this variable student is assigned to a data structure of dict, which is short for dictionary. So it is also one of the data structures that we can use in Python to store or represent data. So I am just going to Control C or Control Z up onto printing the student. Now, in order to work with dictionaries, I'm going to show you the first thing that we can do with dictionaries, how you can access specific items in a dictionary, right? Because we have created this dictionary and we might need to access specific elements from this dictionary. In order to do that, we are going to make use of something that is very, very similar to indexing. In order to print a specific item, we need to grab, or in order to print a specific value, we need to grab that value using the key that it has been assigned to. So if I wanted to print name, I would first of all put the square brackets right beside the variable name. And in here, I need to pass in the key which I am trying to print. And the moment I put quotes, you can see Visual Studio Code already um, recommends or is already suggesting items. So I'm just going to pass in name. So once I do that and run it, you see that we have John Doe printed out in the terminal. That is because we were able to grab the value John Doe using its key of name. Now, I could also do the same for like first name, for example. And once I run this, you see it gives us algebra right back in the terminal. So this is exactly how to access a new element. Or sorry, this is exactly how to access values from a dictionary using their keys. This is me from the future after realizing that I forgot to add something in. So I had showed you how to access values from a dictionary using their keys in one way. Now, this is the first way to do it. Now, there is also another way which is also actually safer. Now, let's say, for example, I comment out this line that is cost name. Now notice what happens when I try to print it. Right here on line 16, we are trying to access a value using a key cost name that does not exist because it has been commented. Now notice what happens when I run this program. You see that when I run it, it immediately crashes saying key error because we are trying to access a key which does not exist within the dictionary. Now, usually in Python, when you are working with dictionaries, you run into a lot of cases where you don't know if a key is actually in a dictionary. Now, there's a safer way to actually go about this. There's a safer way to access elements within a dictionary, even if they are not, even if that key does not exist in the dictionary, we can still try to access it and it wouldn't crash. So what we can do is instead of just directly calling the square brackets, we can make use of something called .get. Now, the .get is a method, is a dictionary method that helps us to retrieve values from a dictionary using a key, which is, for example, in this case, cost name. Now, another important thing about the .get is that even if that key does not exist within a dictionary, instead of crashing the entire program, it will just return none by default. So if I save this file right now, if I clear my screen and run this program again, I want you to notice what we get. You see, we just have none printed out rather than the way it's crashed before. So something else that we can actually do is we can pass in a default value. So if, for example, we try to access this value, this key called cost name, if for any reason that key does not exist within a dictionary, we can pass in a default value like, for example, I can say default cost. And what Python will actually do is that when it checks the dictionary, if it doesn't find any key that is called course underscore name, it will just immediately return whatever text is here by default. So if you put a comma and in quotes, put whatever value you want, it's going to return a value by default. So if I run this program again, I want you to notice what we get. You see we have default course being printed out to the terminal. So that is what .get does. It checks for a key within a string, within a dictionary rather. But if that key does not exist within a dictionary, whatever item you have specified as the default value will get returned. So this doesn't also have to be a string. It can be like a value, an integer, for example. So I just want to show you that the false value doesn't always have to be a string. So for example, here you can see that 23 was returned. So that is how the does get works. A lot of times when you're working with dictionaries in Python, you might not readily know if a key is within a dictionary or not. So that is where the does get method comes into play, and that is where it actually helps a lot to prevent these crash, to prevent the crash that occurred at the beginning of the video. Now, you might be wondering why you are learning about dictionaries. Now, this is very, very important because as you progress in, in your Python career, you're going to work in a lot with APIs and requests. So you might not understand what that is right now, but a lot of times in your code that you're going to be writing, data is going to be structured as a dictionary. And if you don't know how to work with a dictionary, manipulate the data, create a dictionary, edit it, and so on and so forth, you might not have a very, very good experience with Python. So it is very important that you understand this concept right now. So this is exactly how we can grab specific items or specific values from a dictionary using their keys. Next, we are going to be talking about dictionary operations. That is the different operations that we can perform on dictionaries. So I want you to create a new file inside chapter 7 and call it dictionary underscore operation. Okay, dictionary operations.py. Now, what I will just do is I will head back to the previous class or chapter, subtopic, I mean. I will copy the dictionary that we had created. I'll paste it here. Now, the first operation that we are going to talk about is adding a new key value pair. So what we have done here is we have defined this dictionary, right? And we can just come down and then print, we can just come down and print students, right? Now, once I do that and save it, I will run the file and you can see that we have the dictionary printed out in the terminal. Now, what we can also do is we can add a new key value pair. Now, the first way of doing this is obviously to come into the dictionary and like just add a new value. But another way to do it is that I'm going to show you another way to do it. In order to add in a new key value pair without having to do it manually inside the dictionary itself, we're just going to take an example. Let's say, for example, we want to add the email of the user to the students, to the student's dictionary. What we can do is we can type the dictionary first of all, the variable assigned to the dictionary, and we're going to put square brackets. Now, inside the square brackets, we can type in the new key that we are trying to add to this dictionary. So since we want to add email, I'm just going to type student of email, and we're going to assign it a new value. So let's just say test at gmail.com. So what I will then do is I will come down, and after creating this new key value pair, I will print dictionary. And once I do that, I want you to notice that the first item or the first dictionary that was printed out here has only name, age, course name, and grade. But the second item has name, age, course name, grade, and email. So in order to add a new key value pair to the dictionary, we didn't have to, manually come into the dictionary and say email. We could have done this and said email is equals to, test at gmail.com. And this is also totally fine. But the other way to add a value to a dictionary is you just come down and define it again, or you just come down and assign it. Now, this specific form of declaration is used when at the point of creating a dictionary, you don't want to add that value yet. So perhaps you want to perform some processing before adding a new value to the dictionary. This is when this comes in handy, and you're going to be using it a lot. So this is how we can add a new value to a dictionary without defining it inside the dictionary itself when we create it. Now, the second operation that we are going to talk about is updating an item in the dictionary. So let's say, for example, we want to change this student's name, right, from John Doe to like Solomon. What I can do is I can come down here and inside student, I can say student of name is going to be equals to, let's just create a new uh, line here, I'm going to say student of name is going to be equals to a new name like Solomon. So what we're telling Python is that we want you to go into this dictionary which has been assigned to students, and at the very position or at the key that has a value of, or the key that has a name of name, we want you to replace the value of Jane Doe with Solomon. So once I save that and I run it, I want you to notice what happens. So the first time the name is John Doe, because we printed it out. Then we came down to these two lines where we inserted a new key value pair, and then we are changing the value of the name to Solomon. So you can see the first name here is John Doe, and then here the name has been turned to Solomon. So that is basically how to um, update a specific key value pair, or that is exactly how to update a value using its key. So the next operation that we are going to talk about is how to remove a key value pair. So what if we would just wanted to remove this line of grade? I mean, we could technically come into the dictionary and just delete it and everything still works perfectly. But what we can do is that we can delete this programmatically. So in order to delete a key value pair from a dictionary program programmatically, we have two ways of doing it. Now, the first way is to use the del or del keyword. So in order to do that, all we first of all type is the del, and then what do we want to do? Let's say we want to delete grade. We're just going to say delete student of grade. So what this is going to do is that it's just going to go into this student dictionary, and it's going to automatically delete this entire line, that is that key value pair. So once I save that, I want you to notice what happens when I run the program. So let me just clear my screen before I run it. Once I run it, you can see that in the first item, we had name, age, course name, and grade. But in the second item, or the second dictionary, which was printed out, we only have name, age, course name, and email. Notice that grade is not present in the second item. That means that we were successfully able to delete grade from the dictionary. Now, this is the first way of deleting a key value pair from a dictionary. Now, the second way of deleting it is using the pop keyword, and I'm going to show you exactly how to do that. So let's say we wanted to delete grade from this dictionary. The second way of doing it is saying student, right, dot pop. Now, inside this pop, what are we going to pass in? We're going to pass in the key that we are trying to delete. That is the key of the key value pair that we want to delete. I'm just going to pass in grade right here, and I'll save it. So once I run this program, you will notice that it gives us the exact same result. So we have grade present here, and we see that in the second dictionary, which is printed out, grade isn't present. So that is exactly how we could delete an item from a dictionary. We could either use, sorry, let me just copy this line. We could either use the pop keyword or the del keyword, I mean. So I'll just comment this out. Or we could use the pop keyword. Either one works perfectly, and we could always delete the key value pair using either of them. So those are the operations that we are going to be talking about for dictionaries. We talked about adding a new item. We talked about updating an item and us deleting an item. We are going to be talking about dictionary methods in Python. So I'm sure you've noticed that by now, every single data type or data structure seems to have a kind of some kind of inbuilt functions for them. For example, lists and tuples and strings, that we spoke about, they all have inbuilt methods that we can use to manipulate them or grab data from them. Now, what we are going to talk about, we're going to talk about dictionary methods. So I want you to create a new file and call it dictionary underscore methods dot py. Now, once you do that, I want you to just open the file. So I will copy the dictionary that we had created from the last tutorial or video, I mean, and I'll paste it here. So we are going to be making use of these dictionary methods in order to, manipulate the data. Now, if I head to W3 Schools, again, I will leave this link in the description of the subtopic so that you can visits this website, or you can always get the link from this video and just type it in. So these are a bunch of big dictionary methods that we can use to manipulate data or grab data from a dictionary. So the first one that we are going to talk about is we're going to talk about the, let's just say, keys. Now, what the dot keys does is that it returns a list containing the dictionary's key. Now, remember that the dictionary is broken out into key value pairs. So what keys does is that it basically returns to us a list of all the keys. So we should only see name, age, first name, and grade being returned back to us. And it is just dot keys that we're going to use. So what I will do is I will come down and I am going to print students dot, sorry, I'm going to print students dot keys. Now, once I save that and run it, let's just see what we have. So you can see that it gives us dict keys. It gives us a list of name, age, first name, and grade. So that's returned back to us a list of all the keys which are present in this dictionary. And we also have a different one called dot values, and this returns to us all the values that are stored in a dictionary. So instead of printing out all the names, imagine you wanted to get all of the values. Instead of saying dot keys, you could just say dot values. And once I clear my screen and run that, you see that we only get the values, which are John Doe 20 algebra and 70.89. So those are, like the first two that we are going to talk about. Another one that we're going to talk about is dot get, and this returns the value of a specified key. Now, remember that in the last uh, section, I told you that in order to get an item from a dictionary, or in order to get a value from a dictionary, you need to make use of the key itself. So I said, if you wanted to get like the name, if you wanted to print the name, for example, you can say students of name, and then this is perfectly fine. You could just run this, and it would still give you the name, which is John Doe. But we have an inbuilt method to actually also perform this operation. So instead of saying student of square brackets name, we can say student.get. And in here, inside the dot get, we just simply pass in the key of the value that we're trying to get. So if we're trying to get name, I'm just going to say student.get name. And then once I run this program, you notice that we still have John Doe printed out in the terminal. So in order to get values from a dictionary, you could either use this way or you could use the other way, which is just this. Now, it is important to note that using this method is usually better for when you are not sure if a value is inside the dictionary. For example, if I were to go back and remove name from this dictionary entirely, once I run this program, you'll notice that it is going to crash and we have an error. It says key error name. Now, what that means is that there is no key in this dictionary that has a name of name. Now, I want you to notice what happens when I now use dot get. I want you to see the difference. I'm just going to save that and I will run the program. So once I run this program, I want you to notice what happens. You see that we don't get an error. It's just print out none. So if you are sure that a value is inside a dictionary, you could use that first method of using the square brackets. But if you aren't specifically sure if that value is present, you can just use the dot get. And if that if that key is not present in the dictionary, it's just going to return none. So it's usually better to use students. It's better to use dot get. It either returns none or it returns the value of the key. So the next method that we are going to just look at right now, let's just scroll through. We can look at the items. Now, items returns a list containing a tuple for each key value pair. Now, we're going to see exactly what that does. Now, what items does is that it returns the key and the value itself. So we're going to need two variables in order to get all the items. So what we can just do for a start is that we can just print students.items, right? Now, once I do that and save it, I will just print this and let's see what it gives us. You can see it gives us a tuple, a list of tuples actually. And each tuple contains the key itself and then the value. So the key itself and then the value. Here we have grade, the value. Here we have course name and then the value, which is algebra. Now, what that tells us is that we can actually loop through a dictionary because it is also an iterable sequence, just like a string or a list or even a tuple. So what that means is that since dot items gives us a list containing age and containing the key and the value itself as an element. That is, if you look at this list, let me just copy the list so we can visualize this better. If I copy that list and paste it inside my program, my code editor right now, we can see that we have a list and each item is a tuple, right? So this is one item, this is another item, and then this is another item. It means that we can definitely look through this um, because it is indeed a list which gets returned back to us. So what we are going to do is we're just going to write a simple for loop that is going to help us loop through these items. So I will just remove this student.print of items and I'll close that. I'm going to write a for loop and I'll say for item, comma, right? Not even item. I'm going to say for key, comma, value in students.items. Now let's look at the structure of this for loop. We're saying for key, comma, value. Now we're saying for key, comma, value because each item in this list is a tuple that has two values stored in it. Now there is something that is called deconstructing a tuple in Python. Now what that helps us to do is we can separate out the values of a tuple by assigning them to specific variables. By saying for key, comma, value, we are saying that for every item in this element, in this list, since all the items in this list are tuples, and then we know that we can deconstruct a tuple by assigning each value in that tuple to a specific variable. That is exactly what we are doing. So we're saying for key, comma, value in students.items. So student.items is going to return this list back to us. Fine. Then we're saying for key, comma, value because we're going to get the key and then the value inside a tuple. So in order to deconstruct this tuple, we need to grab the key itself, which is age, and then we need to grab the value, which is 20. So we're going to do that same operation for every single item in this list. So we're going to say for key, comma, value in student.items, we can just print out something here. We can just print out using the F string. So in order to format this properly, we're just going to print the key, right? And then we'll put a colon here, and then we're going to print the value. So you are going to see how this looks. Let me just clear my screen and run this program. So you see that it gives us age colon 20, course name colon algebra, and grade colon 70.89. So this basically just helps us grab each key value pair individually from the dictionary. That is what the dot items does. It returns to us a list. Now that list contains different elements. Each element is a tuple, and each tuple contains the key and the value. And we can deconstruct a tuple by assigning every single value inside the tuple to a specific variable. So in order to make it more understandable, let me just head back to, I believe it's chapter 6, and we're going to go back to tuples. I should have actually talked about this in tuples. So I will create a new, let me just comment this. So I will create a new tuple and I'll call it student, and I will equate this to, let's just say Solomon, and then I will put Solomon and let's just pass in the age of like 70. Now what we can do is we can deconstruct this tuple by saying, instead of saying student is just equal to this, we can say student name, comma, age is equals to Solomon, comma, 70. Now what I can then do is I can come down to print, sorry, I can print student name, and I can also come down and I can print age. So look what happens when I run this program. Sorry, TLS. So once I run this program, I want you to notice what happens. You see we get Solomon printed out first and we get 70 printed out first. Now let's look at what happened. We know we are storing two values in this tuple called Solomon and 70. Solomon, comma, 70. Now, what we can do is instead of just assigning one variable of student equals to this, we can deconstruct the tuple and separate it into its individual parts. So when we say student name comma age is equals to a tuple of Solomon comma 70, what we're essentially saying is that let Solomon be equal to student name and let age be equals to, and let 70 be equals to age. So this is exactly what deconstructing a tuple means. It just means separating the tuple out into it just means breaking the tuple down and assigning them to their own individual variables. So that is exactly what we did here. We did for key comma value in students.items, and then we printed the key and value. In this chapter, we are going to be discussing functions. So I want you to first of all create a new folder called chapter 8 and then create a new file called functions.py. So what exactly is a function? A function is a block of reusable code which performs a specific task. So you might not fully understand that right now, but as we take an example, you are going to properly understand what a function is. Now, before I proceed, remember that all through all what we've talked about, we always mentioned, inbuilt functions, inbuilt methods. For example, if I go to list methods, I always talked about list methods being inbuilt functions in Python. Now you are going to learn what a function is and exactly how to write your own function. So I'll give you an example. Let's say, for example, I wanted to print out, like introduce myself programmatically. So I'll have three print statements. So the first thing I'll print is my name is Ayo. And then the second thing I'll print is, like my age, for example. I am, let me say 60 years old. And then the last thing I'm going to print is my occupation, for example. I'm going to print I am a programmer. Now, let's say, for example, I wanted to display this, like 5 times, or no, like let's just say 3 times, right? What I can do is I will copy all of that and paste it 3 times. So if I even wanted to display it 4 times, I'll have to paste it again. Now, once I run this program, you are going to see that, it prints it 4 times. But there is an issue here. The code is very, like it's voluminous, it's bulky. Now, what if we wanted to create a way to write this code once, but to run it as many times as we wanted? So we can use a function to perform that specific task. So in order to create a function, what I will first do is I will delete all of this and I will come to the top here. Now, in order to create a function, we first of all need to type the def keyword, which stands for define. So what it essentially does is that you are telling Python that you want to define or create a new function. Now, after typing def, you need to type in the function name. That is, what do you want to name this function? And I will just call the function introduce self, CRODUCE, introduce self. And then after typing in the function name, what you need to do is type opening and closing parentheses and put a colon in front of it. So this is just a simple way, or this is the exact way of creating a function. Now, what you then do is you inside the function body, you then need to place all the code that you would like to execute. Now, since I want to execute these three print statements, I will just push them into the function body using the tab key. Now, what we have here is that we have created a function called introduce self, and all it basically does is that it has a block of code that just prints details about a user, the name, the age, and the occupation. So when I saved it, I want you to note what happens when I run the program. So when I run the program, you see that nothing gets printed out. So you might be confused. Why exactly does nothing get printed out? Now that is because we haven't invoked or called the function. Now in Python and in programming generally, anytime you create a function, the block of code within that function doesn't get executed until you invoke the function or call the function. Now, how exactly do you invoke or call a function? All you simply do is type the function name and then you type parentheses right there. So what you are telling Python is that, okay, I want you to run all the block of code or execute all the block of code that exists within this specific function at this specific point. So what I will do then is that I will come and run this file. When I run it, what do you see? It says, my name is Ayo, I am 60 years old, and I am a programmer. Now remember that we wanted to run this block of code 4 times. In order to run this 4 times, all we just simply have to do is paste this 4 times and it will definitely run. So once I run this, you can see that we have it running 4 times because we had called the function 4 times. So that is the idea of a function being reusable and being callable. It basically just means that you can define a function in your program and you can use it multiple times at different points in your program and it will still execute whatever block of code exists in it. And it is just a much cleaner and a much better way of structuring code because you can definitely agree with me that having this written once in one function and calling it, like as many times as you want is way better than having this block of code like multiple times. It looks neater, it looks better, and it's just a better structure to writing programs. So that is basically what a function is. Now, we had been talking about inbuilt functions earlier, and like string methods, string for inbuilt functions, list methods, which are also inbuilt functions. Now, one of the inbuilt methods that we had talked about was the .pop for lists. Now, if we can actually go into this code to see what it is. So if you want to see it, if you're on VS Code, I want you to press your Control key and hover over it, and you can see that it's now um, underlined. So just click it, and it's going to open the file where that function actually existed. So you can see that the pop method is actually a function underneath, and all of this comes by default. So when you install Python, most of these or all of these inbuilt methods come by default with it. You can see the append right here. You can see extend, pop, index, count, and so on. So all of these are actually functions which were written by default in Python, which is why it is called inbuilt. But right now, we are learning how to write our own functions, which we can make use of in our programs. In the next section, we are going to move on to talking about function arguments. So I want you to create a new file and call it function underscore arguments.py. So the first thing that I will do is I will just come over to the functions.py file, copy it, and paste the block of code that we've written in there. So function arguments are basically a way of passing parameters to a function or passing values that a function can work with. So I'll give you a very simple example. For people who remember, like basic algebra in math, let's say, for example, we have x is equals to, let's just say 5y plus 50 or plus 60. And then they say, let y equals 10, and they tell you to find x. Now, obviously, what you know that you're going to do is you are going to say x is equals to 5, then you substitute the value of y, which is 10. So it becomes 5 open brackets 10 plus 50 plus 60, which becomes 50 plus 60, which is 110. Now, in this case, the function is x, and this is a block of code. Let's just like look at this programmatically. In this case, the function name is x, and the block of code that exists within x is 5y plus 60. Now, this function x receives one parameter, which is y, and the function makes use of y to perform this computation or this simple calculation. So we pass y into the function, and then y gets substituted at this point. So we have 5 open brackets 10 plus 60, which is 110. So that is like a very simple analogy that we can use. Functions basically can take in parameters. Now those parameters can be used to perform some computation or some processing within the code, within the body of the function itself. So we're going to see how to apply this. Now here we have, my name is Ayo, I am 60 years old, and I am a programmer. We are going to tweak this function a bit to actually collect these values, and we're going to print them out. So we're going to be collecting a user's name, their age, and their occupation, and we're going to be passing that dynamically into this print function so that our function can dynamically print out different values based on what values were passed as arguments to it. So the first parameter is going to be name, right? The second one is going to be age, and the last one is going to be occupation, or let's just call it job, for example. Now, if you look at this function, it takes in 3 parameters: named, name, age, and job. So what we can now do using these parameters is that we can perform some specific computation or some specific operation with it. So I will add the f keyword to all of these strings so that we can format them to pass in these as variables. So instead of saying my name is Ayo, I will just dynamically pass in the name, which comes as a parameter. And instead of passing in the age here, I will just dynamically, instead of writing the age there, I will dynamically pass this in, and I'll do the same for job. Now you might be wondering, okay, now that we have added parameters, how exactly do we call this function? Now we can call this function in two ways. Now the first way is we are going to just type introduce self, and we are going to call it as we had seen in the previous chapter or the previous subtopic. Now if I try running this program like this, we are going to get an error. As you can see, we get an error saying that the function introduce self is missing three required positional arguments, which are name, age, and job. So the reason why we get this error is because we have passed these parameters into the function, which are name, age, and job. And they are by default they are by default required. So when you are calling this function, you have to pass in these values. Now later on in this video, I am going to teach you how to make some of these arguments not required. But if you try calling this function right now, as you have seen, we get an error because we have to pass in all the values for these parameters into the function. So let's move on. I will just close this right now. So in order to properly call this function, what we need to do is we need to pass in the value for name, age, and job. So I will just first of all say name is equals to Solomon. Then I'm going to say age is equals to 65. And then I'm going to say job is equals to, let's just say programmer. Now, once I save this and I run this program, I want you to note what we get. So you can see that it prints out, my name is Solomon, I am 65 years old, and I am a programmer. So what we were able to do was, we were able to dynamically call this function, and we passed in the values for this specific user. And we were able to get these values printed out because we had passed them dynamically into the string, into the printing string using the F keyword to format it. Now, what we can then do is that we can do this for multiple users. So I can say Solomon, I can say Jane here with an age of, let's just say 45 and a job of teacher. And then I can change this name here of the third person to Simon. And the age can be like 12 and the job can be like student because, a 12-year-old would be a student. Now, once I clear the screen, I would just like to print, like a new line so that there's space in between each and every one of these printouts. Let me just do that, \n. Now, what I will do then is run it. I want you to notice what we get. You see that we have this code or this function being called 3 times. And for each time that the function is called, we get different values. So here we have my name is Solomon, here we have my name is Jane, and here we have my name is Simon. And we can see that the ages as well as the occupation printed out are different. That is because once we write a function and we are passing in values dynamically into this function, it means that we have created a reusable block of code which is going to take in, which is going to take in parameters and perform some processing using those specific parameters. So whatever output it gives back or whatever output is printed out might be different for every single user or for every single data that we pass into this function. So this makes the function very, very reusable. So instead of having to write this block of code manually for each of these users, all we can just do is create a function and dynamically pass in those values as function arguments. And we can call those functions. We can call the function and pass in the values that we want, and the function performs the operation. Now, it is very crucial that you understand how functions work because as you progress, you are going to be working with functions a lot. And you might even ask yourself, but why do I need to know how to use functions? If the first reason is that it is just very, it just makes your code very structured. So like I said earlier, if I wanted to do it manually, I would have had to write print statements for 3 of these users and had to change their name, age, and all that. But what I can then do is write a function and just call that function once. I'm sorry, and just call that function three times and pass in their values dynamically. And we have written this once, but it runs three times. So we're able to perform the same action for three different users. So it makes the code, number one, lesser. So it's less bulky. And number two, it makes it more structured. And it makes it more readable and clearer. So it's way better than doing everything, writing everything manually, which makes it become bulky. So that is basically how parameters work. Now, if you want to make parameters optional, I will show you exactly how we can do that. So I will just comment this right now. And in order to make parameters optional, all you are just going to do is type in equals none, and then equals none. So what we have done here is that we have defined a function and we have told it that, okay, it is okay for these parameters to be none. That is, if no parameter for name is passed in, then it is okay. If no parameter for job is passed in, it is okay. And if no parameter for, age and job are passed in, then it is okay. If I run this program right now, you can see that, okay, nothing happens because we haven't called it. So let me come down here to call the function. And I'm going to say introduce self. And I will not pass anything into that function. Let me clear my screen right now and run it. So as you can see, it just says my name is none, I am none years old, and I am none. So I am a none. So what that means basically is that we're able to, first of all, define that, okay, this function takes in parameters. But in the case that no parameters are passed in, by default, we're just going to set those values to none, and that will definitely be okay. Now, this is also something that I would like to teach you, which is setting default parameters for functions. So what you can do as a function, or what you can do for a function is that you can set default values for these parameters. So in a case where a user doesn't specifically pass in a value for that parameter, you can just use the default parameter which exists in the function definition. So I can say the default name is going to be Samuel, right? The default age is going to be, let's just say 12, and the default job is going to be student. So once I save this program and I run it, you're going to see that it says, my name is Samuel, I am 12 years old, and I am a student. So even though I had called introduce self without passing any parameters into it, it was still able to make use of these default functions, or these default parameters rather. Now, the moment you try and call this function and actually pass values into them, what Python is going to do is it is going to override the default values that you have passed in. So once I save this and run the program, instead of printing Samuel 12 and student, we are going to see Solomon 65 and programmer. So let me show you. Once I run it, you can see it says, my name is Solomon, I am 65 years old, and I am a programmer. So that is basically how we can set default values for default and non-values for the parameters of a function. So if you set default values, then Python is going to make use of those default values. But if you don't set any values at all, if you don't set any, but if you set values, then Python is going to use those values that you have set, and it will override the default parameters or values which you had passed into the function argument. Now we are going to move to talking about return value for functions. So I am just going to create a new file. So let me close these out and head to chapter 8 and create a new file and call it return values.py. Now, what exactly is a return value? In the previous class where we had talked about function parameters and functions, we mentioned that functions can perform specific tasks. Now, what functions can also do is that after performing some specific task or operation, a function can also return a value when it is done processing the task. I am going to show you an example. So let's say we want to create a function. So let's just say calculate the addition of two numbers. So we're going to say def add numbers, and we're going to open parentheses. Now this function is going to take in two parameters, which are namely num1 and num2. Now what are we going to do? I'm just going to print out the addition of num1 plus num2, right? So I'm just going to save that. Now, what I can then do is come down to call add numbers. And I'm just going to pass in like 5, comma 7. So what this function is just going to do is it's going to take these values in, first number, the second number, and it's going to print their sum. So once I run this program, you see that we have 12 being printed out. Now, this function that we have created here doesn't actually return anything back to us. All it's simply doing is it's just simply printing out the addition of two numbers. What functions can do is that they can like perform some processing and we can return whatever output or whatever value we desire. So instead of printing num1 plus num2, we are going to make use of a special keyword which is called return. I'm just going to say return num1 plus num2. Now, what the return keyword does is that it just basically returns a value back to where it just basically returns the value back to where that function was called from. And if I run this, you are going to see that nothing happens because all this function is doing is returning the addition of these two numbers. Now, it's also important that we could always say addition is equals to num1 plus num2, and then we return addition. So that was just like the shorter way of doing it. So we could return like this variable, and this variable is just basically going to store the summation of these two numbers. So we could either say return addition, or we could just directly return the expression that adds the two numbers together, and this is valid. Now, in order to show you, or in order to prove to you that this value actually gets returned to the point where it was called, we are going to create a variable right here, and I'll say result is equals to that. So we are creating a new variable and we are equating it to add numbers of 5, 7. Since we know that this function is going to return a value, we are going to be storing the value that that function has returned to this variable called result. What we can then do is come down to print the value of result. And I want you to see what we are going to have. So once I clear my screen and run this, you are going to say that we have 12. Now that is because anytime you create a function, you can choose to return a value and you can store whatever value has been returned to a variable, but just make sure that you create a variable and you equate it to the point where that function was called from. So as at this point where the function is called, whatever value gets returned from the function is going to appear here, and then we are going to assign it to the result variable. And then after assigning it to the results variable, we are essentially printing it out. So this is how the return keyword works in Python for functions. Now, there's also something that I would like to teach you. Functions can return more than just one value. That is, a function can return just more than two numbers. So let's say we wanted to return both addition and subtraction of the two numbers. I can tweak this function, and instead of calling it add numbers, I'm going to say add and subtract numbers. Now, what exactly do we want to do? We want to return two things. We're going to return the addition of these two numbers, and we're going to return the subtraction of these two numbers. Now, what Python is going to do here is that it is going to return these values as a tuple. So instead of actually passing in the parentheses here, we don't necessarily have to do it, and I will just remove it. But what Python does is that it returns the addition and subtraction. Now, in order to make it not confusing, let's just create two variables for this. So this is going to be addition, and it is going to be num1 plus num2, and then we're going to say subtraction is going to be equals to num1 minus num2. So what we're just simply going to do is we're going to come down here and say return addition, and then at this point I'm going to say return subtraction. So this is supposed to be minus num2, right? So what we're just doing here is we've created two variables, addition and subtraction, and these variables just help us, store the results of the arithmetic operation of adding the two numbers together and subtracting them together. So what we're now simply doing is we're going to return addition and subtraction. So Python is going to return this back to us as a tuple. Now, what we can then do is I'm going to change this from add and subtract numbers. Yeah, I'm going to change this to add and subtract numbers. And I'm going to pass in, let's pass in a bigger number as the first number. So let's just say 9 and then 7. So what is going to happen is that Python will return this value as a tuple. And in order to prove to you, I will just print out results so we see what we are given. So you see that we have 16, comma 2. That is because Python returned these arguments or these results as a tuple. And we can actually return as many items as we want from a function. Now, the way that we can properly get these items is we can use something called deconstructing, which we had talked about earlier. So we can deconstruct this tuple in order to receive the two values. Since we know that we are going to be receiving the addition and subtraction, I will just copy that and place it here. So we're going to say addition, comma subtraction is equals to the function call and then the variables, that is the parameters. So we're saying addition, comma subtraction because we know that this function returns two values, which are the addition value and the subtraction value. Now, these values don't have to match actually. So I could change this from addition to add, and I can change this from subtraction to sub. So we're just trying to create two variables which are going to be able to grab the returned values. And then I can come here to print add. I can also come down, to print sub. And once I save that, let me just clear the screen and run this program. So you see that we get 16 being printed out, and then we have 2 being printed out next. So that is exactly how we can make a function return more than one value. So we can return as many values as we want. Now, there's also something that is very important that I need to explain, which is functions can actually accept parameters of different data types. So what I mean is that we can create a function, and that function can accept data types of multiple. We can create a function, and that function can accept multiple values of different data types. So a function could accept, like an integer, which we have done here. A function could also accept a list. It could also accept, like a tuple also. So it can accept a list, it can accept a tuple, it can even accept a dictionary. So the data types or data structures that a function accepts is basically everything that exists within Python itself. So we can pass in an integer, as we've seen, to a function. We can pass a list as a parameter to a function. We can pass a tuple. We can pass a dictionary. We can pass basically even a floating point number or a Boolean value to a function as a parameter. And then the function itself can also return any data type it wants. So it can return a list, it can return a tuple, which is what gets returned by default here when we return multiple values. It can return a dictionary right back to us. So it's basically limitless based on, it's not limitless. I mean, it's basically can accept and return the different values and different data types and data structures which exist within Python. Now, before I forget, it is also important to add that anything that gets typed or any block of code that exists after the return value isn't going to be executed because by default, anytime a return is written, it is the exit point of a function. So once you type return, that is the exit point of a function. That is, you are returning the final value that was gotten from whatever processing you did within the function. So I'm going to show you an example right now. I can come down here and I can try to print out a string. Let's just try to print out hello world. So I can say print, okay, I can say print this will not be printed. So it's just like an example. So instead of hello world, I'm going to print this will not be printed. And if I run it, you can see that it indeed wasn't printed. So any block of code that comes after the return function does not get executed. And you can see that VS Code automatically just, like blurred it out or grayed it out because it isn't going to be executed. Instead, what you would like to do is every single block of code or every single line of code that you would like to execute before the function finishes execution, you need to write this before the return statement. So what I will then do is once I run this program, you can see that this will not be printed, gets printed out, and then function returns the value. So right now we are going to work on a mini project, which is going to just bring all of what we've talked about so far into one project so that we can see how we can combine it. So it says, the question says, create a program where users can add, view, and delete contacts using a dictionary. So what we're going to do is we're going to be making use of functions, lists, dictionary, a while loop, and an input method to put all of this together. And you're going to see how everything comes together perfectly well. So again, the question says create a program where users can add, view, delete, and delete contacts using a dictionary. So what we're going to do first of all is that we are going to create a variable that is going to store a list of the user's contacts. I'm going to say contact is going to be equals to a list. Now let me explain how exactly we are going to be storing the contact. So since we are storing it in a dictionary, this is going to be the format. So the first thing is going to be the name of the of the contact. So like John Doe or something. Let's just say John Doe. And then the next item is going to be number. So I'm just going to say number is going to be like 1, 2, 3, 4, 5, 6 or something like that. So inside this contact list, we are going to be storing a list of dictionaries. Now remember that I had told you that a list is a dynamic data structure that is capable of storing, different kind of data types or data structures. So in a list, you can store lists. You can even store other lists. You can store strings, integers, dictionaries also. So we're going to be storing a list of these dictionaries inside. We're going to be storing all of these dictionaries inside a list, and each dictionary just represents a single contact. So I will just comment this out for now. Now, what do we want to do first? We want to. It says create a program where users can add, view, and delete contacts using a dictionary. So what I will do is I will first of all create the main function. Now, the main function is going to handle the entire operation of this program. So first of all, just write with me. I'll create a main function and I'll call it def main. Now, this function will not accept any parameter. And the only thing that this function is going to do is that it will just display the options, that is the operations that we can perform in this program. The first operation is to add a contact. Second operation is to view a contact, and the last operation is to delete a contact. So I will just print all of these out. I'll write a print statement here, and I'll say below are the operations. And I'll just put a colon here, and I'll put a backslash n so that I can create a new line. The first operation is going to be add contact, and I'll put a backslash n. The second operation is going to be view contact, I'll put a backslash n again, and then the third operation is going to be delete contact. So delete, delete contact. So let me just put a space here. Now I'm just going to always call the main function because the main function is what is going to control the entire flow of this program. So once I run this program, you'll see that it just tells us below are the operations, then it says add contact, view contact, and delete contact. Okay, fine. Now, what do we want to do? We want to write a while loop inside this main function, which is always going to constantly ask us for what operation we want to perform. Now, this is very similar to what we had done in a previous mini project, if you remember. So I will just type it out. So I'll say operation is equals to int, and then I'm going to pass in input right here. And then inside the input tag, I will just say enter an operation number. And I'll put a colon there. So what we're doing is we're telling the user to input an operation that they wish to perform, and then we're converting it into an integer. So now that we have done this, we need to now actually start writing separate functions which are going to perform each of these tasks, like add a contact, view contact, and delete contact. So the first function that we're going to add is a function that was going to help us add contact to our contact list. So I'll create that function and I'll call it def add contact. Now this function is not going to take in any parameter, so I'll just put a colon there. Now what exactly do we want to do? We want to, in this function, all we want to do is ask the user to enter the name of the contact, the phone number, and then all we want to do is just save that contact as a dictionary in the contacts list. So just follow with me. So the first thing is going to be the name, and then we're going to write an input field. In here, I'm just going to say enter contact name, and I'll put a colon right here. And then the next thing is going to be the number. And this is going to be an input field also. And in here, I'm going to say enter contact number. So once I do that, what we can then do is we can create a new, okay, this is supposed to be equals to. We can then create a new dictionary using these values which have been entered. Now remember that the dictionary has to be in this specific format. We are going to be creating this dictionary, and then we are going to be saving that dictionary into this contact list using the .append list method. If you remember, the .append list method just helps us save, it just helps us save a value or add a new value to the end of a list. So in order to do that, let us first construct the dictionary. So I'll create a new variable and I'll call it contact, C-O-N-A-C-T, and I'm going to equate it to a dictionary. Now in here, the first thing that we're going to be saving is the name of the user, and I am going to just put name here, and then the next thing is going to be the number, right? And I'm going to put number right in front of it. So what we have just basically done is that we created a dictionary, and inside this dictionary, we're saving the name of the user as well as the number of that user. Now, after doing this, all we're just simply going to do is save this contact that we have just created to the contacts dictionary. So I'm going to say contacts, right, which is the list dot append. Now, what are we trying to append? We're trying to append this contact that we had just created here. So what we have successfully now been able to do is that we have been able to make sure that whatever gets entered here, first of all, gets saved as a dictionary. And then after we created the dictionary with those details, we're appending it to the contacts list. Now, what we can do next is we'll come down to our main function, and then we are going to ask the user what operation do they want to perform, which we have done here. Now, if the user wants to perform, like add contact, we are then going to call this add contact function within the main function. And yes, it is very possible we can call a function from a function. So let's write our if statement. We're going to say if operation is equals to 1. That is, if the user has selected that they want to add a new contact, what are we simply going to do? We're just going to call the add contact function right here. And that is all we are going to do. So I will just save it and let us test out our program so far. So let me just run this. And then you can see that it says below are the operations. It prints out all the operations and it says enter contact, enter an operation number. So I'll enter 1. The moment I enter 1, you can see it's asking us to enter a contact name. So I will just say Solomon and then enter a number. I'll just say 1, 2, 3, 4, 5. And once I do that, the program ends. So we do not want the program to end, as we always want the program to ask the user to enter an operation. So I will create a while loop here, and I'll say while true. And we are saying while true because we want this loop to run forever until we break out of the loop from the loop body. So I'm just going to add a last option here, which is going to be exit. So it will be for.exit. So if the user enters exit, we would just like to break out of this loop and end the program. So we're going to say while true, operation is equals to enter an operation. And if the operation is 1, we are just calling this add contact function, which is going to help us collect the name and number from the user and then save that contact, to the contacts list. Now, the next function that we need to create is the view contact function, right? So we just want to view all our contacts. So what we're simply going to do is that we are going to be making use of a for loop right here. And you'll see how we're going to do that. I'm just going to create a new function and I'll call it def view underscore contact. And this function is not going to take in any parameters because we don't need to collect any parameters. So the next thing that we are going to do is that we are going to then loop through this entire list. Now remember that this list contains dictionaries. So it's a list of dictionaries. And each of these dictionaries contain a name and a number. So what I will do is I am going to write for contact in contact. What exactly are we trying to do? We're just trying to look through all the items inside this contacts dictionary. Now, because each of them are, sorry, inside this contact list. So because each of them are, because each item or each element in this list is a dictionary, we are going to be working with it differently. So we're going to say for contact in contact. So we are sure that for every single iteration, contact grabs a dictionary from the list. Now, because we are grabbing a dictionary from the list, we're going to be accessing the elements using the keys of that dictionary. So the keys that we have created are name and number. So using the keys of that dictionary, we're going to be printing out the values. So I'm going to print out a formatted string. So this is going to be name. I'm just going to pass in a contact dot get, or instead of using the dot get method, I'm just going to use this indexing method, and I'm going to say contact of name, and then I'm going to say number colon contact of number. So this is supposed to be single quotes. Now change this to single quotes also. If not, we're going to have an error. Now let us examine what this program is doing. So we are saying for contact in contacts, because contact is a list and it contains a list of dictionaries, we are going to loop through it by saying for contact in contacts. Now, all we simply want to do is that for each contact, which is a dictionary, because if you remember, let's head back to the dictionary chapter, if I can find it. So in the dictionary chapter, remember that in order to access a single item from a dictionary, what we had to do was we had to use this key method. We had to access the value using the key. Now, because we have given our contact keys of name and number, what we are now able to do is that when we look through the contact, since every single contact is a dictionary, we can now print contact of name, which is a key, and then we can print contact of number, which is also a key, right? And we're just passing that in as a formatted text into this for loop. So we're saying for contact in contact, then print out this value. So what I will then do is I will come down right here and I'll say L if, which stands for else if. So else if operation, right, is equals to 2, that is you want to view all contacts, we're just going to call view contact function. Now let's see exactly how that will work. So I will just run this program. You know what, let me just first of all clear my terminal screen just to make sure there's space. So I'll just call this program, run this program again, and then it says enter an operation number. So I'm just going to add a new contact. The name is going to be Solomon, let's just say Grundy. And then the number is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it now says enter an operation number. So let me add a different contact. And then I'll enter the contact name to be, let's just say Jane Doe. Then the number is going to be 9876543 1. Now, the next operation that I will then enter is to, which is to view contact. And when I click to view contact, you see here that we have name Solomon Grundy, number, the number being printed out, and the name of Jane Doe, and number of that being printed out to the terminal. So I probably need to format this well in order to, let me just format it well in order to make sure that we can view it legibly. So I'm going to write a print statement here, and I'll say below are your saved contacts. And I'll put a \n here. And I also need to put a \n here so that everything is saved properly. So I'll also put a \n. Oh no, there's no need to put that there. I will instead put it here. So print \n. So I am just trying to print out new line characters so that everything can be seen very, very legibly. So I will then save that, open my terminal. So in order to open your terminal, you can just hover towards the end and you see that, and then you can drag it up. So allow me to run this program again. And once I run it, it asks to select an operation. So I will add a contact. So entering the contact name will be Solomon Ronde, and then contact is a random number. And I'll say I want to enter a number again, or enter a contact, and this is going to be Jane Doe, and then a random number again. Now I will select 2 just to display all my contacts. And when I do that, you can see it says below are your contacts. And then we have the name Solomon Grundy, the number. Then we have name of Jane Doe and the number being printed out to the terminal. So we have successfully created 2 functions which help us add and view contacts. Right? Now the next item is that we need to now actually write a function which is going to help us delete a contact. So I will create a function for that, and I'll call it def delete contact. And this by default is not going to take any single parameter. So what I will do next is that we need to first of all print out all the contacts which this user has. And we're going to tell the user that we're going to print out all the contacts that this user has. And we're also going to print out the index. Now, after printing that out, we're going to tell the user that they need to select a specific user who they want to delete. And once they enter the ID of that user, we're going to remove or delete that dictionary from the list. Now, if you remember, we are storing all of these dictionaries in a list. And in order to get rid of an item, which is a dictionary, we're just going to try and guess the index of that dictionary, and we are going to delete it. So what we're going to do next is we then need to print out all the contacts as we have described. We need to print out the contact along with their IDs to show the user, okay, this is the ID and then this is the contact. To select the ID of the contact you would like to delete. So in order to do that, I will just edit this view contact function a bit, and we're going to make use of enumerate, and you are going to see why. We're going to make use of enumerate because when we want to display all the contacts, we also want to display the ID of that contact. Because we are looping through a list, we can make use of enumerate, which is going to return to us the ID of the current item which we are iterating over, and it's going to return the item itself. For index, contact in enumerate of contacts. So we're just going to say enumerate here, and we're going to pass in contact. So this is going to always return back to us the index as well as the contact, that is the dictionary element or the dictionary item from that list. So we're going to then come here and print out the ID. So the ID is going to be the index, right? So we're going to print out the index, the name, as well as the number. So from here, we can then proceed. So the next thing that we're going to do is that we are then going to call the view contact function from our delete contacts function. That's true. We can call functions from a function. Now, the reason why we are going to call this function is that when a user wants to delete a contact, we first of all want to show all the contacts that they have. And then that includes and when we're showing them, we're going to show them the ID of the contact, the name, as well as the number. Now, the way we're going to delete it is we're going to make use of the ID of that specific contact to delete it. So when we're able to get the ID from here, we're just going to use the .pop method in order to remove that specific contact from the contact list. So once we've displayed all the contacts here, so the next thing that we need to do is now ask the user to enter the ID of the contact that they wish to delete from the list. So I'm going to create a new variable and call it contact underscore ID, and I will equate this to the int, which is going to help us collect which is going to help us convert it to an integer. And then I am also going to use the input keyword, tell the user to enter the contact ID you want to delete. So once the user enters our contact ID, what we just want to do is we want to remove that contact from the contacts list. What I will just simply do next is I will say contacts dot pop, and in here I'll pass in contact ID. So what this is then going to help us to do is that the does pop list method or list function is going to help us delete that specific contact that has that specific ID from the contacts list. So if you have any questions so far, please just feel free to go back a few minutes to watch what I have done, or you can always reach out to me down below or click the Ask AI button. So if you have any question, please don't hesitate to ask. So once we do that, we know that we can be rest assured that the user has been deleted from that specific contact, has been deleted from our contact list. So all we have to do to utilize this function is we just need to write an else if block. So I'll say else if operation is equals to 3, and we just want to delete contact, right? And then the last operation, which is 4, is when we want to exit or end this program. So I'm just going to write that else here. I'll write else if operation is equals to 4. That is else if the user enters 4. And what do we want to do? We just want to break out of the loop. Now, once we break this loop, we know that the program is just going to exit out of this entire loop. And then since there is nothing that comes after the loop, the program is going to get terminated. So that is all we are going to write for this project. So I will then come and run this program to test our code so far. So I'm going to be adding 3 contacts. So it says add contact. I'm going to enter a name of Solomon Grundy, and then enter a contact number. It's going to be a random number. And I'll enter a different contact again, Jane Doe, and then a random number. And then I am going to enter the last contact of Joshua and a random number. Now that I have entered 3 contacts, I'm just going to click view contact. So let me enter 2. And once I click 2, it says below are your contacts. You can see we have the ID, which is 0, 1, and 2. And we have the name Solomon Grundy, number of that. And we also have the same for the second entry and the same for the third entry. Now I am going to test out the delete feature, right? The delete method. So I'm just going to select 3 in order to delete a contact. And when I select 3, notice what it does. It prints out all the contacts that we have, and then it asks us enter the contact ID you want to delete. So let's say I want to delete Joshua, which is the last one. I'll just enter 2. And once I do that, I'm just going to click 1, or what's the operation? I'm just going to click 2 again to view all my contacts. And once I do that, you can see that there are only 2 contacts left. And let's say I also want to delete another contact. I'm just going to enter 3, and I'll delete the first one. So once I enter 2 to view all contacts, you can see that we only have 1 contact saved in our list. So this is essentially how we are going to combine, or this is essentially how we've combined all of the features which we have talked about. So let me just enter 4 to end the program. So this is how we can combine for loops, dictionary, lists, if conditions, input statements, loops, into and also functions to form or to write a simple program in Python. In the next chapter of this course, I'm going to teach you about file handling in Python. And we're going to specifically talk about text files, and we're going to be working with text files in Python. So file handling basically helps us as Python programmers to store and retrieve data from text files. So let's say you're working on a program and you need to actually store data that the program outputs. You could use something like a text file to store that data in the text file. And then when next you want to make use of that data, you could just read it from the text file. So we're going to learn how to work with files and file handling basically in this entire chapter. So anytime you are working with files, you have different modes that you can use to manipulate or retrieve data from those text files. So we have some of those modes here which are outlined on this web page. I'm going to leave a link to this page in the description of this subtopic so you can go ahead and check it out. Now we have 4 basic modes which we are going to talk about, which is the X. X helps to create a new file. W helps to write to a file. A is to append, which is to add more data to the file, and R is for reading. Now you're going to exactly see how all of this works. So the first thing that I want you to do is head to your, to your code editor and create a new folder and call it chapter 9. Chapter 9. And then once you do that, inside chapter 9, I want you to create a new file and call it creating a file.py. So the first thing that we're going to talk about is actually to, create a file. So in order to move on to the more complex topics like writing to a file and reading to a file, reading from a file, we need to first understand how to create the file in the first place. Now, when working with files in Python, Python has already given us a bunch of inbuilt methods or inbuilt functions that we can make use of in order to perform various operations on these files. So in order to create a new file, the first thing that we need to do is that we first of all need to create a new variable. So I'll create a new variable and I'll call it file, and I will equate this to this open function, inbuilt function right here. Now, what exactly does open do? Open is a function that takes in a few parameters. So to prove that it's a function, I can just press my control and hover over it. And once I do that, you can see that Python gives us this. So it comes in Python by default, or comes with Python by default. Now, once we type open, the first thing that we need to pass in is the name of the file that we want to create. So let's just say we want to create a text file called example .txt. Now, the next thing that we need to pass in is the file mode, which is the mode in which we are trying to work with this file. Now, since we want to create a new file, we're going to make use of the X mode. Now, if you look at this, it says create the specified file and returns an error if the file exists. So anytime you want to create a new file in Python, what you need to first of all do is type in the name of the file, right, which is example.txt in this case. And then the next thing is you put a comma, and inside quotes, you need to pass in the mode that you are trying to, the mode in which you are trying to work with this file in. And since we're trying to create this file, we're just going to type X. Now, once you do that, we're just going to come down, save it, and run this program. So once I run it, let me just run that. I want you to notice what happens. Now, you can notice that a new text file called example.txt was automatically created for us. I want you to take note of something. Now that this file was generated, you can notice that it was generated in the base directory, that is the parent directory of where everything is present in, of where all the chapters are present in. That is because if you don't specifically pass in the file path to where you want that file to be created in, it will by default create that file inside the base directory of your project. Now, let's say I rename this from chapter 9 to, let's just say, chapter-9, so we don't have any issues. What I can now do is, in order to create a new file inside chapter-9, what I will do is I'll type in chapter-9 / the file name. So let's say I want to create a new file called example2.txt. Now, I want you to notice what happens. I'm specifying that I want to go into the chapter9.txt folder and create a new file called example2.txt. Now, once I run this program, I want you to notice what happens. You can see that an example2.txt was created inside chapter 9. And once I close chapter 9, you can see that that file was indeed created in chapter-9. So what you can do is that when you want to create a new file, you can dictate exactly what location or exactly what folder you want that file to be created in. So that is basically how to create a new file in a new text file in Python. As we move on, I'm going to teach you how to write contents to a file, how to read from a file, and how to add data to the file. The next mode that we are going to talk about is the writing mode. That is, how exactly can we write content or write data to a file? So the first thing that I would do is I would just first of all create these two files, or delete those two files, I mean. I'm just going to delete the example.txt files. And once I do that, I will come into chapter 9 and create a new file and call it writing _2 _a _file.py. So writing to a file.py. So let me just close this out. Now let's say, for example, we want to create a new file and write any random text to it. Now we can do that using the open function again, but we're going to use a different mode. So in order to do that, I'll create a variable and call it file, and I'll equate this to the open inbuilt function. Now after typing the open inbuilt function, what I need to do is pass in the path to where I want to create this file. So let's just say I want to create it inside chapter 9. I'm going to put chapter-9 forward slash tests.txt. Now, once I do that, I am just going to pass in the mode. Now, if I head back to the web browser where I have this tutorial or this guide, it says the W is the mode that we use, and it opens a file for writing, and it creates the file if it does not exist. Now, this is actually very, very important, because imagine you are trying to write contents to a file and the file does not exist. What the W mode does is that it will automatically create that file if it does not exist, and it will write that data to the file, compared to the X mode, which only creates a file. The W mode is capable of creating a file if it does not exist, and also writing that data to the file. So you're going to see exactly how that works. So we're just going to pass W here into this mode. Now the next thing that we need to do is now actually write the contents that we want to write to the file. So I'm going to say file.write, and in here I'm just going to say hello world. Now let's look at this code. We have created a variable and we equated this to this open method, which takes in the file path which we want to write to and the mode, which is W. If you notice, this file doesn't exist, test.txt. It doesn't exist for now inside this chapter 9 directory. But the moment I run this program, it will first of all create that file, because what the W mode or the write mode does is that it first checks if that file exists in the specified location. And if it does not exist, it will create that file first. Then it now moves on to line 2. It says file.write. Now the .write is another method. As you can see, it says method or function. The .write basically takes in a string and it writes that string into the specified file which has been opened in write mode. So we basically opened the file in write mode here, and then we're basically using .write to write a string to it. Now, once I run this program, I want you to notice what happens here. You can see that the test.txt file was created for us, and if I open that file, you can see hello world has been written inside the file. So what this basically means is that Python was able to create that file, and it was able to detect that that file didn't exist. And the moment it's created it, it's now came to line 2 and wrote hello world to the file. Now, something special about the write mode is that the moment you open a file in write mode, it will automatically overwrite everything that is currently present in the file. So what that means is that since this file is already created and it has hello world in it, if I decide to come here now and change this text to I am human, what Python will do is that it will go into this file, erase all the current content of the file, and replace it with this text here, which is I am human. So when you are working with a file and you put write mode, when you open a file in write mode, if there is already content within the file, what Python will do is that the moment you call .write, it is going to take whatever content you pass into .write and to overwrite everything that is currently present in the file. So it basically deletes hello world and puts the new value there. So that is exactly what it does. So for example, now if I run this program to say I am human, the moment I open test.txt again, you can then see that all the content has changed from hello world to I am human. And I can change this, I am human and not an alien. So once I run this program, once I open the file, you can see that the content has changed to I am human and I am not a program. So, and I am not an alien. So it is very important to know that the moment you open a file in write mode, if that file already exists, the moment you call the .write method, it is going to immediately overwrite everything that currently exists in the text file which was just opened. Now, there is something that is very important that I need to tell you. Anytime you are working with files, The moment you open the file and you do whatever you want to do, so let's say you want to write to a file or create a file, what you need to call is file.close. So you need to close the file, right, to let Python know that you are done working on this file. And this is just a very standard and important procedure because you need to basically let Python know that, okay, I am done working with this file. Because you have opened the file, and if you end the program without closing the file, you might start having complications, like memory leak and things like that. So the moment you open the file and finish working with the file, that is, at this point, I have just written to the file and I am done working with the file. What you just need to do is call the .close method. And I am saying file.close because file is a variable name that was assigned to the open method. So if this was a different variable name, like let's just say my file, the other items here would have to be my file. So you get the point. So you always have to close a file the moment you are done working with it so that you avoid complications. So that is basically how you can write contents to a file in Python. In the last subtopic, I explained to you how to write content to a file. Now, the problem with this is that anytime you pass any string you pass into the .write method automatically overwrites all the content which is present in the text file. But what if you don't want to replace all the content? What if you just want to add to it? Now, this is a different write mode, or this is a different file mode, which is called the append. And it basically opens a file for appending. It also creates the file if it does not exist. So you can see that write and append have something in common. What they have in common is that they basically create a file if the file does not exist. So the only difference is that what the write mode does is that it automatically, overwrites everything that exists in the file. But the append mode is basically going to add contents to the file. So it doesn't overwrite it, it just adds content. Let's just see how that is going to work. So I will create a new file and call it append to file.py. So append underscore to underscore file.py. So let me just copy this right now. And I am going to call this my file is equals to open chapter 9, and then we're still opening that test.txt from the last subtopic. Now notice that this is the content which is there. I am human and not an alien. So what we want to do is we want to add content to this, right? So instead of opening it in write mode, we're going to open it in append mode. So you're basically telling Python that, okay, I want to open this file or create this file if it does not exist. And what I basically want to do is I just want to append or add more data to the file. So in order to basically add more data to the file, I'm going to call the variable. I'm going to say my file.write. And in here, I'll just say, and I live on Earth, right? So I just want to add and I live on Earth to this text file, basically. Now, I want you to note something. You might be confused by saying, but why are we writing .write? Isn't there a .append mode? Now, that is a perfectly good question because I was also confused when I had first seen it. But as long as you have specified that you want to work with this file in append mode, we are going to still call the .write, and it won't overwrite everything that exists. It will only add this content to it. Now, again, the last thing that we just need to do is call my file.close. Remember, you always need to close the file after working with it. So let's run this program and see what happens. So when that's finished running, just open the text file. So you can see exactly what happened. It said the content is I am human and not an alien. And then we have the second text which we had added to it, and I live on Earth. So we can see exactly how we can actually add text to a text file. But you're going to notice that there is no space between the last sentence and the new sentence. That is because Python just automatically mashed them together. But what we can do is that we can just come here, put the full stop and put space. And once I run that and open the file, you can then see that Python appended that exact value to it. So it puts the full stop as well as the other text which was added to it. So there's also something interesting that we can do. So I will just undo the change that was made. Now, something else that is interesting that we can do is we can create a new line in a text file. So let's say I wanted to add this and I live on earth to the next line instead of writing everything on one line. We can make use of the new line character, which is \n. If you remember when we had talked about this new line character. What it's basically going to do is that it will write this \n, which stands for new line, to the text file, and it's going to write it's basically going to write all of this to a new line because we have put the \n, indicating that we want to go to a new line. So once I run this file and open it, you see that "and I live on earth" has been written to its own new line. So that is basically how the append mode works. It basically adds more content to a text file instead of overwriting everything that exists like the write mode. I have showed you how to create a file and write data to the file. Now, the last thing that I need to show you is how do we read data from a file? That is, how do we get all the content of a file? So I'm just going to show you that. What I want you to do is create a new file inside chapter 9 and call it read underscore from underscore file .py. So again, I will copy this and I will paste it inside read from file.py. Now, the only difference is that we're going to be changing the mode. Now, if I head back to the tutorial guide, it says the read mode is the default value. It opens a file for reading and gives an error if the file does not exist. So this mode does not create a new file, unlike append and write mode or the X mode. What it only does is that it opens a file to read its content. So what we're just going to do is we're going to change this from A to R, signifying to Python that we want to read data from the file. And in order to read data from the file, all we just have to do is I'm going to create a new variable and I'll call it my file data. And it is going to be equals to my file dot read. Now, this dot read is an inbuilt method that Python gives to us by default. As you can see, it's a method or a function, and Python gives this to us by default. Now, once you call dot read, it will just get all the contents of the file and assign it to this variable called my file data. And all we simply just have to do is print my file data just to see the content. Now, before I print it, let me head to the text file. You can see this is the content of the file. I am human and not an alien. And the next line is, and I live on earth. So what I will just simply do is I will run this program. And you can see that it gives us exactly what is inside the file, which is, I am human and not an alien. And I am human, not an alien, and it gives us, and I live on earth. So that is to tell you that we are successfully able to read contents from a file. And we forgot to do one more thing, which is to close the file. So always forget to close the file. So I'm going to say my file does close. So that is basically how you read data from a file. You just open it in read mode. You call the .read method, and then you can then print out the data or perform some other processes that you wish to perform on the data from the file. Now, I am going to show you a better way of actually handling files in Python. So it's pretty much the same process, but it's just a better way. So what I will do is what I want you to do is create a new file inside chapter 9 and type the underscore with underscore keyword .py. So that's the underscore with, like WITH, and underscore keyword. Now, what I want to show you is that there is actually a better way of working with text files. So let me just copy this line right here and paste it in. Now, if you remember from the last few subtopics, when we're working with files, the moment we opened it, we always had to close the file at the end of working with it. Now, using this method, you can pretty much forget to close the file a lot of times. Now, using this with keyword, it actually closes the file automatically for us when we're done working with it. So in order to use this method, what we're going to do is we're first of all going to type with space open, and then it's still going to be the file path or the path to where that file is, Then we're going to put a comma and put the mode that we're trying to work with the file in. So we're just going to put R because we want to read the content of the file. So just put a colon right after that. So with open the file, comma, the mode, and then colon. So what you now need to do is that we need to actually put something else here. So with open this file as file. So what exactly does this mean? We want to open this file and assign it to a variable called file. So this file basically gets equated to this entire open statement here. That is what Python does underneath or in the background actually. When you say with open this as file, now this file can be like any name. So it could be as file or as my file, right? Something like this as my underscore file. But you just have to pass in a variable name. What Python is going to do is that in order to actually now work with this file object, you can access it using this my file variable. So we open the file as whatever variable name you want. Since we want to read contents from this file, we're just going to say create a new variable and say file content, right, is equals to my file dot read. And then all we can just simply do is print file content. So notice here that I am not going to put a like my file dot close. That is because using this method, Python automatically closes the file for us. So we don't have to worry about, oh, did we close the file? Did I not close the file? Well, rest assured that Python is going to automatically open this file, read the content, and print it. And it's going to now close the file in the background for us. So we don't have to worry about it. And as you can see, this method works perfectly well also. We open the file by saying with open the file, the mode, and then as my file. So it has to be a sensible variable name. So as variable name. So you can now access the content or you can access that file object itself by calling variable name. So we can do that by saying my file.read and we assign the contents to this variable and printed it out. So this also works with the different modes actually. So this can also work with the write mode. So I could change this to the write mode and write some content to it. For example, I could put this in write mode and I can just remove this line and say my file dot write. And in here, I'm just going to say I am a human who loves movies, right? And I will get rid of this print statement. So what I can then do is run this program. And once I run it, I will open that text file and you can see it says I am a human who loves movies. So you can see it's even shorter than, let me just open it right here. It's shorter than this method because here you have to write 3 lines. But using this method, it's literally just 2 lines. So it's better because it helps us open the file and it closes it automatically once we are done with the process that we needed to perform. In this section of this course or in this new chapter, we are going to be talking about object-oriented programming. Now, if you notice, I had already created a new folder called chapter 10. So this is where we are going to be writing all the code which is required for this chapter. So you can see I created 2 files. The first one is car.py and the second one is classes.py. I want you to ignore this car file for now as we're going to use it in the future, but I want you to create a chapter 10 folder and then create a new file called classes.py and then save it. So let's get right into what object-oriented programming is. So object-oriented programming, or OOP for short, is a different kind of programming paradigm, or it's a different kind of programming style that helps us to structure code using classes and objects. Now, I am going to explain exactly what classes and objects are, but I just want you to, get the overall idea first. So object-oriented programming, I said it's a paradigm that helps us to structure code using classes and objects, and it actually helps us organize our code properly. Now, before I even start writing any code and explaining in detail what classes are, we need to talk about a different paradigm which I had taught you in this course. So if I go to chapter 8, you can see that we had spoken about functions. So functions are actually a different way of writing code, and it's actually a different paradigm of writing code. And this is called the procedural paradigm of writing code. Now, procedural programming basically means that we structure code into different functions or different procedures that perform some specific kind of task. Now, if you look at this project which we worked on in chapter 8 called mini project, we can see that we have several functions created. The first one is called add contact, second one is called view contacts, then we have delete contacts, and we have the main function. So you can see that all the code basically have been divided into different functions, or we can call them procedures also. So different functions or procedures that perform some specific task. So this is the procedural way or the procedural paradigm or procedural style of writing code, where code is divided into different procedures or functions that actually perform some specific task. Now in Python, we can actually make use of different paradigms depending on what your project needs and the scope of what you're working on. The first one, which we talked about, is the procedural, which is the function. Now, I'm going to be teaching you the second procedural method, which we'll talk about in this course, and this is object-oriented programming. Now, like I had said earlier, object-oriented programming is a paradigm that helps us structure code using objects and classes. Now, you might ask yourself, what exactly is a class, or what exactly is an object? Now, a class is a blueprint that helps us to model real world entities or abstract concepts. Now, let me give an example. Let's say, for example, you want to model a car within your program. How exactly do you do that? We make use of we can make use of a class to actually model a car within our Python program. Now, in the definition I gave, I explained that we can that classes are used to model real world entities or abstract concepts. So by real world entities, what I mean is you can actually model physical objects. Let's say, for example, we want to model a car again. We know that a car has a model. We know that it has the year of production. We know it has, for example, the type of engine it has, the number of doors. So those are physical attributes that this car has, which we can actually model within our program. And by abstract concepts, I mean something like bank account, something that you can't hold. So a bank account can be an example of an abstract concept. We know that a bank account has, the balance that is currently present in the account. It has, the user or the customer who actually owns the bank account. We know that it has transaction history, things like that. So we can actually model these abstract concepts, things that you can't physically hold. We can actually model these abstract concepts within our program and within our code. And I'm going to be explaining in more detail as we proceed. So a class, like I said, is just a blueprint for modeling real world entities or abstract concepts. And if you want to create a class in Python, all you have to do is just type keyword class followed by the name of the class. Now, in Python, the naming convention for creating a class is usually using an uppercase first letter. So let's say we want to create a class that models a car. We're going to call it car. Now, note that the first character should always be an uppercase. And if it has multiple words, so let's say we're trying to model a car company, this class will be called car company. Notice that each word starts with an uppercase letter. And this is the Pascal case, which we had spoken about in chapter 2. So if I go to chapter 2 under naming conventions, you can see that under Pascal case, the first letter of every single word is a capital letter. So that is exactly what making use of. Anytime you want to create a class in Python, you should always make use of the Pascal case. But since our class is called car, I am just going to call it car. So we say class car, we put a colon, and in here, let's just say pass for now. Now let's analyze this syntax. So anytime you want to create a new class in Python that models something, we first use the class keyword, space, the name of the class, the name that we want to actually give this class, then we put a colon. So the next thing that we are going to talk about is what we call class attributes. Now, class attributes are basically things that describe what the class is about. So you can look at it as attributes of, for example, like the name of the class is car. So by class attributes, what that basically means is that these are variables that contain some specific kind of data that describes what this class is about, that describes what the class can do. It basically helps to save data concerning that class. Now, remember that I said we can model real world entities using a class. Now, what exactly does a car have? we know that a car has a brand. So what we're going to do is we're going to say brand is equals to, let's just say, for example, a Toyota. So now we've said that our class has a brand of Toyota. Now, what else does a car have? We can say a car also has a model. So let's just say the model is Camry. Now, what else does a car have? It can have a year of production. So let's just call it year. And I'm going to equate that to, let's just say, 2025, which is going to be the latest Camry, because this video is being recorded in 2025. Now we can see that we've created three variables called brand, model, and Camry. So we can see now that we have three attributes. Now these are class attributes. And basically this class or these variables, these class attributes basically describe what this car class is about. So we can see that we've stored the brand equals Toyota, we've stored the model to be Camry, and we've stored the year equals 2025. Now, what we can actually do is we can now make use of this car class. Now, we can actually reference these class attributes by just printing them out. And I'm going to show you exactly how we can do that. So I'm going to call the print method and I'm going to say print car.brand. And I can actually come down and do the same thing for model. So I can say print car.model and I will say print car.year. Now, once I run this program, I want you to see what we get in the terminal. So you see what we get in the terminal. We have Toyota being printed as Camry as well as 2025. So you see that we can actually access these class attributes which we've created called brand, model, and year. So basically, we've been able to store some attributes of this car class, which are brand, model, and year. Now, there's something that I would like to teach you about, which is what we call objects. Now, at the beginning of this chapter, I mentioned that we're going to be talking about object-oriented programming. And object-oriented programming is divided into two main things, which are classes and objects. I explained what classes are. Now, I need to explain what an object is. So, an object is basically an instance of a class. Now, what exactly does that mean? So let's take an example. There are currently 8 billion people on earth right now, and each of us have different names, but we are all human beings. We can look at the term human being as a class, and we can look at every single person as an object. Obviously, human beings are not objects. This is just an example. So we can look at the term human being as a class, and we can look at every single people that lives on earth as an object. Now, every single human being has the same physical attributes but kind of different, right? Every single human being has a name, they have a height, they have a gender, they have skin color, they have different color of hair, things of that nature. So every human being has different attributes that distinguishes each other, but we are all human beings, right? So we can look at the term human being as a class, and we can look at every single human being as an object. So what exactly does that tell us about objects and classes? We can actually say a class is a blueprint for creating objects. So we can also say a class is, a blueprint for representing abstract concepts and physical quantities within our code. That is the first definition I give. Now, the second definition I am giving is classes are actually blueprints for creating objects. So the class is a blueprint. We have a blueprint called human being. Now, that class called human being can produce several objects, which are different human beings that we have on Earth right now. We have 8 billion people. So we can look at those 8 billion people as different objects. We can say we have 8 billion objects. So that is exactly what an object is. It's just an instance of a class. It's like it's a new entity that is created based on the blueprints created by a class. So let's proceed and explain exactly more what an object is. So right here, what I created here are called class attributes. Now remember, we are 8 billion people on the planet. Every single person on the planet does not have the same. So for example, every single person on the planet is not black, is not white colored. Every single person on the planet does not have the same height, the same eye color. So things of that nature. Every single person doesn't have the same DNA. So we have distinguishing features that actually differentiates people from each other. And that is exactly what object-oriented programming helps us do. Because I said it helps us model abstract concepts, we know that because I said it helps us model abstract concepts, that means there needs to be a way to distinguish between two different objects of a class. It's the same way when I use the bank account example. Every single person cannot have the same bank account balance. Every single person cannot have the same bank account name. So there are distinguishing factors that actually differentiate objects of a class from each other. Now, these are what we call object attributes or instance attributes. Now, what we have here are class attributes. No matter how many times I call car.year, it's always going to be 2025 because I set it as a class attribute. And if I run this now, you see that we have 2025 being printed out two times. So these are what we call class attributes. Now there's something that we call that are called instance attributes. Now these are attributes or features that are specific to only, or these are features that are unique to only that specific object. So one object can have a car, can have a brand of Toyota. Another object can have a brand of, let's just say Lexus, for example, or Mercedes Benz. So let's see how we are going to do that. In order to actually enable our class to create multiple objects, we need to make use of a special method called init method. Now, I am going to basically explain what we're doing now, but just type def. We're going to define a new function. Type def double underscore init double underscore open parenthesis and pass in self. Now, I'm going to explain exactly what is happening, but just follow with me. I'll put a colon and type pass right there. Now let's explain what exactly this is. Why are we having a function inside a class? Now that might be confusing, but let's proceed. Now classes can have some things, classes can have things called methods or functions. Now these functions are basically actions that the class can, basically actions that are possible, instances of this class can perform. So let's say, for example, we have a car. What are the actions that a car can perform? A car can move, it can accelerate, it can stop, it can flash its lights, it can spray water on the windscreen, it can use the wipers to clear dirt. So these are different actions that these are different actions that our class car can perform in the real life. Cars can perform these actions. Now, how do we translate that into code? The first thing that we need to know is that, okay, we can actually store attributes for both the car class as well as the instance. Remember, I mentioned that instance or objects have variables that distinguish them. For example, different cars have different brands. So it could be Toyota, Mercedes Benz, BMW, and so on. Now, what that means is that each of these cars must have, different functions or different actions that, each of these cars have functions that they can perform because cars have functions that they can perform, which is move or accelerate. They can stop. They can, they can perform different actions. Now, those actions can be created using functions within the class. So each function is basically going to perform a specific task within the class. Now, I'm going to show you more examples of what these functions can do and how these actions can, work. But let's just proceed. Now we have a special kind of function when creating classes. This function is called the initialization function, or we can just say init, the init method. Now within a class, functions are called methods. So from now on, I'm going to be referring to them as methods. So when I hover over it, you can see we have method in parentheses right here. So what that means is that we can actually create functions and they are called method. Now, the init method is a method within a class that actually helps us create a new object of that class. And the moment you initialize a class or the moment you create a class, what I mean by create a class is I can say, for example, my car, or let me use snake case. I can say my car is equals to car. Now, this is what you call initialization. That is, you initialize a new car class or a new car object at this point. So the moment you initialize a new car object, this method will automatically run regardless of what else has been written. So the moment you type something like this, the moment you initialize a new object, this function will automatically run. So for example, I can actually test that out. I can just print this is my car, and I will just comment this for now. So once I run this, I want you to notice what we get in the terminal. So you can see that we got this printed out being this is my car. I didn't even have to call this method. The moment I just initialized this car class, it automatically just printed out this is my car. So this means that this function, this method, this init method will automatically run anytime we create a new car anytime we create a new car instance. Now, at this point, what we have actually done is we have initialized a new car object. So what that means is that, remember that I had explained when we call the init method, it actually helps us create a new object. So this method is responsible for creating a new object of this class car. So the moment I call this car class right here and assign it to a variable, what we have done is we have created a new instance of that class called car. So this is a new object. If I now come down here and create a new variable and call it my car2, what this means is that we have created another object of this class. So the moment I run this code, it will mean that we would have created two objects of that class. So I can actually clear my terminal screen and run this program again. And you can see that this is my car gets printed out twice because at this point we had created two instances. At this point, we had created two objects or two instances of this class called car, which is why we can see this being printed out. So if you have any questions so far, please feel free to ask me a question using the ask question button below, and I'll be happy to reply you. So let's proceed. So what we're going to do right now is we are going to create a new file inside our chapter 10, and we'll call it classes underscore and underscore objects dot py. So at this point, I just want you to save all what we've done inside this file, and we're going to proceed inside our classes and objects file. So remember that I mentioned we can create classes called, we can create any class and call it anything. And each class can have methods as well as instance attributes. Now I'm going to show you exactly what instance attributes are. Now, at this point, we created a class called car and we gave it class attributes. Now, these class attributes will always be present in every single instance of that car because these variables or attributes were defined at the class level. So the moment I move these variables inside that instance, uh, it would mean that each object will have their own different instance variables. Now, that might not make sense, but let's just proceed to write more code and I'll explain exactly what that means. So I'm going to create a new class and I'll call it car. Now inside this class, I'm going to create the init method. So def underscore underscore or dunder, that's what it's called. Double underscore is called dunder. And I'm going to create this init method. And in here, I'll just type pass, for example. Now there is something that I needed to explain, which I hadn't explained. So I'm just going to type self here. Now I actually didn't explain what this self means. So I am going to proceed to explain what self means. Now when we pass self in, what that actually means is the current object or the current instance that is currently being worked with. So when we pass self into this method, we're currently trying to reference the current object which we are working with. So a lot of the times when we're working with methods or when we're creating methods within a class, we are going to pass in self. So for example, let me create difference method and call it test method. And this will take in self. Let me just put pass for now. What that means is that anytime we make use of this test method and we pass self in, it means we are going to be working with the current object which we are going to be working with the current object which is currently being called. So remember that I said we can create different objects within our class. What that now means is that since we can create different objects within our class, each of these objects can have different methods and we can call any of those methods on the current object. Now we need to be able to know what object we are calling that method on. That's why we pass self into it. So self is like an identifier which helps to identify what object we are currently executing. That is exactly what self is. Now, in the previous class or previous video, I explained that we have class attributes here, but there is a way that we can actually define unique attributes which every object will have. Now, the way we can do that is we can actually take in unique attributes. So I can put a comma here and take in parameters just like how a normal function would. So since our cars have different brands, models, and year, we are going to take that in. So I'm going to say brand, model, and year. So right now, what this means is that when we create a new class, we can pass in the brand, model, and year of this class. And the init method is going to create a new object, and it is going to set these attributes as the attributes of that specific. Now, right now, our init method is just taking in these attributes, but we haven't actually told it to set these attributes as the instance attributes of this car. So what I'm going to do is I'm going to say self.brand is equals to brand. And I'm going to explain exactly what is happening, but just follow with me. I'm going to say self.model is equals to model. And then I'll say self.year is equals to year. So let's look at what is happening here. So this init method takes in 4 parameters. So I explained that self basically references the current objects that it's working with. And then we have brand, model, and year. So these are the attributes that we want to set for these current objects because these objects will have its own special kind of attribute. Now, once we've passed that into this method and we're accepting it as parameters, what we can now do is say self does brand is equals to brand. What that simply means is that we're trying to create a new attribute for this object called brand by saying self does brand because we're saying, okay, this current object does brand. So we're creating a new instance attribute called brand. So we're saying self does brand is equals to brand, which is what has been passed into the method. So we're doing the same thing. We're trying to create a new instance method called model, and we're saying self.model is equals to model, which is exactly what we have created, which we have passed in as a parameter here. And then we're saying self.year. We're trying to create a new year attribute or a new year instance attributes for this object, and we're assigning it to the year parameter, which was passed in. So what that now actually means is that we can now be able to access these attributes from a different method. Now, this is the actual beauty of object-oriented programming. Now, if I go back to chapter 8, where we spoke about functions, if I open the mini projects.py, if we look at it, we can see that the code has been broken down into different functions. And if we actually needed to pass data between these functions, we'll see that we actually needed to if we actually needed to pass data, I mean, within these functions, we would have had to collect a parameter like data, for example. So we could pass data in there, we could pass data in here. And if we ever wanted to call view contact, we would then have to pass data into this method. So you can see that it can get chaotic because if you have multiple functions which are going to be working with the exact same data, it would mean that you would have to pass it into the functions. Now, mind you, a function could accept multiple kinds of methods, so multiple kinds of parameters. So I could accept data one, data two, data three, and so on. And I have to make sure that I must pass all of those parameters into wherever this function is called from. Now you can see that it can eventually get chaotic because you have to make sure that all of these data are passed into the right place. But this is where object-oriented programming actually shines because what it helps us to do is it helps us to bundle data and attributes together. So it helps us to bundle data as well as behavior. Now, behavior basically means methods. It helps us to bundle data and then methods that act on those data. So let's say, for example, now I wanted to create a method to display the details of this car. Let's say I wanted to create a method that actually displays details about this car, which I have just created. Let me just delete this method and I'll create a new one and I'm going to call it def. display, or let me just call it car, or let me just call it details. Now, what exactly is this method going to take in? It's going to take in self because we are trying to reference the current object that we are working with. So when I take in self, what do I want to do? I just want to print out some certain items. I'm going to print out self dot brand, and let me just do that 3 times. I'm going to print out self dot brand, self dot model, and then self dot year. So you might ask yourself, well, how exactly are we able to access self dot brand, self dot model, and self dot year, even when they haven't been specifically defined inside this method? Now, the beauty of object-oriented programming is that the init method takes in some certain parameters, and we can actually set these, like I had explained earlier, we can actually set these attributes as the instance attributes or as the object attributes or attributes of that object by saying self the brand is equals to brand, self the model is equals to model, and self the year is equals to year. So because we have actually set these attributes for that specific object, if we now create any other method within this class and that method takes in self as a parameter, it means that we can access those parameters. Sorry, it means we can access those attributes which we defined in the init method. So it means we can actually access those attributes in any other method within the class. So let's see how we can actually utilize this. So I'm just going to go down and I'll create a new car object. So let's just say I'll create a new variable and I'll call it first car. And I'm going to equate this to car. And we need to actually pass in some certain parameters into this initialization of this new class. Notice that inside the class car in our init method, it takes in 3 items aside self. It takes in the brand, model, and year. So what we need to do is we need to pass these parameters in. So let's say our brand is Toyota, our model is Camry, and the year is going to be 2025. So this is exactly how we pass attributes in. So when we pass these attributes in, they will automatically be sent to the init method, and the init method will create a new object for this class. And as it is creating that object, it will assign some certain attributes for the instance, or it will assign some certain attributes for that specific object, like the brand, model, and year. Now we don't need to pass in self because it will automatically just take that in. It will automatically just create that by itself. So we don't have to pass any parameter for self into the init method. Now what I can then do is I can say first car dot details. So what exactly are we doing here? We created a new car called first car, and we equated this to a new object, and we passed in the values of Toyota, Camry, and 2025. So that will be assigned to the brand, model, and year. So what we can now do is, in order to call methods of a class to perform some certain action, all we have to do is just call the variable that we had equated this to, and we can call dot details, or the method name of dot details. So this will actually immediately just run that specific method for the object which has been assigned to first car. So let me just save that and bring up my terminal so I can run it and we'll see the output. So let me just clear my screen and run this. So when I run it, you can see what gets printed out: Toyota, Camry, and 2025. That is because the moment I called first car.details, it's just, okay, so let me explain again. In line 13, I first of all created a new car object, or a new car object, yes, using the class car, and I passed in the values of Toyota, Camry, and 2025. So Python came to this init method, accepted those values, and set them here. Self the brand is equals to the brand, which was Toyota. Self the model is equals to Camry, and the year is equals to 2025. Then I now went to line 14 and said first car dot details. So what it did was it just performed a certain action, which was display the details of that car to me. And it's printed them out line by line. So I can actually get rid of this to print it out in one single line by using the F string. So I can say name, or let me start by saying brand Brand will be equals to the self dot brand. Now remember we had talked about string formatting in, I believe it was chapter 3, or was it 4? Okay, yeah, in chapter 5 we talked about string formatting. So if you have any questions, you can just go back to that file or go back to that chapter in this course to review it. So brand is self dot brand. Then we are going to put a comma and we're going to say model is going to be self dot model, and then the year is going to be equals to self dot year. So once I save this, it's still going to print out the details, but it's now going to be on a single line. I'm just going to clear my screen and run this code. Okay, so the reason why nothing is getting printed out is because I didn't actually write print. Let me just write print. Let me wrap this in a print method, in the print method. Once I save that, I'll clear my screen again and run it. So once I run it, you see exactly what we see: brand, Toyota, model, Camry, and year of 2025. So what we can actually do is I can now come down to create a new car object. So I will just copy this, paste it, and I will rename this to second car. Let's call the brand of this car Ford, and let's change this from a Camry to Explorer. And let's change the year to, let's say, for example, 2015. So we're trying to create a new object, and the brand of this car is Ford. The um, the model is Explorer, and the year is 2015. So the moment I now call second car.details, what is now going to happen is Python is going to run this method for this second car. So let me just save that, clear my screen, and see exactly what we get in the terminal. I'm going to run this file. So you see exactly what gets printed out. We have brand. The first one is Toyota, model is Camry, year is 2025. And then we have the brand for the second car. It is Ford, model is Explorer, and the year is 2015. So you can see now that we are capable of creating a class, and that class is capable of creating multiple objects. Now, if we didn't actually make use of a class, what that would mean is we would create this details method in a different, we would create it as its own method, as its own function. Then we'll then have to figure out how to dynamically always pass in this data. So let's actually look at the car file which I had created earlier. Now, if we look at this file, it's just basically details, and it's just an example of making use of the procedural way of doing things. So it's an example of how it would look if we're only working with functions. So here I have this function called car underscore info, and it takes in the brand and model. And you see that we are just returning the brand and model. We're returning brand and model. Then we have a different method called start car. And all it takes in is the brand model, and it returns a formatted string saying the, the brand as well as the model is starting. Then we have a different method also, a different function rather, and it's returning the same formatted string. Now notice that anytime we want to make use of these functions, we are saying print, and then we're just calling that function inside the print statements because the function returns a string. And it means that that string will just get substituted in place of this function call. So notice that every time we always have to pass in the car name and the car brand as well as the name. So if, for example, we wanted to get the car info, start the car, and stop the car, notice that we always have to pass in the same value. So we always have to pass in Toyota and Corolla every single time we want to call different functions for the same car. We'll always have to pass in the name Toyota, Corolla. Anytime we want to call start car, we also have to pass in the car brand as well as the name. So we have to do this multiple times. Now, if you look at this is a second car. Now, we also have to do the exact same thing for the Honda Civic. Want to get the car info, we pass in the brand as well as the model. We pass in the brand here, model. So we're doing the exact same thing. We always have to pass those values in. But in our object-oriented programming implementation, we know that we never actually have to always call those, we never have to pass these values into the method again because we've already passed it in once. And all we have to do is just reference it by saying self dot, by saying self dot the instance variable name, which is brand. So I can perform the exact same example by saying start car and stop car. So I will just copy these methods, come to the class, and right under details, I will paste it here. So let me just indent this properly. So what I'm now going to do is instead of taking in brand and model, I am going to remove this and just simply type self. I'm going to remove this here also and just simply type self. Now what I can do is instead of passing in brand, I will just say self does brand, self, self does brand, and here we're also going to pass in self dot model. So I'll do the exact same thing here. Self does brand and self dot model. So in order to now actually make use of these methods which we have created, because these functions were pasted inside our car class, so they are now methods. All I can just do simply do is, let's say I want to start the first car. All I'll just do is, let me comment details out. All I'll just say is first car dot start car. And I can also stop the car. So I'm just going to say first car dot stop car. Now you see the beauty of this. I can exactly do the same thing for the second car. So I can just change this from first car to second car. So you can see that I can just automatically call the start car and stop car for each of these objects, and I don't have to manually pass in the name, the brand, as well as the model, as well as the year every single time I want to perform an action. Unlike here, where we had to always pass in the brand as well as the model every single time we wanted to perform an action. And these two files actually perform the exact same action. So for example, I can just print this. I can just run this. So this won't actually do anything because I have to actually change this to print if I want to see the printout. I'm just going to put print there, and I'll do the exact same thing here. I'll call the print method or function here. So once I save that, let me just clear my screen and I will run it. So once I run it, you see what it says. Toyota Camry is stopping. Ford, okay, it says Toyota Camry is starting, Toyota Camry is stopping, Ford Explorer is starting, Ford Explorer is stopping. And I can even uncomment these um I can even uncomment these details to show you that it will actually make use of these details that we passed in once multiple times within this class, because all we've passed in is self. And by passing in self, it means that we can access the instance attributes of that specific object, or the attributes or the object attributes of that specific object. So what this means now is that we've been able to create two different cars that have two different models, two different um, two different years, as well as two different brands. So let me just put a print statement here to actually print out a new line character, just so we have space in the terminal. So I'm going to clear my screen and run this again to show you how it looks like. So when I run this, you see that this is the first car. It says the brand is Toyota, model is Camry, and the year is 2025. And then if you look at this, it says Toyota is starting, Toyota Camry is starting, Toyota Camry is stopping. Then we have some space which we printed out. Then we have the second car, which is the brand is Ford, model is Explorer, the year is 2015. And we can see that it says Ford is starting, Ford is stopping. So what that now tells us is that our class is capable of modeling any single car objects that you can think of. So I want you to just, as an example, create like two more car objects, and you can pass whatever you want in there. So it can be Mercedes, it can be BMW, whatever you want. You can pass in the brand, the model, the year, and you can create these functions. You can call these methods, I mean. And what I want you to practice is actually practice creating your own special method. So think of an action that a car can perform and you can just write it there. Write it as a method. So you can say, yes, my method, and to take in self. And inside this method, it will perform like a certain kind of action which you want your car to perform. So I want you to just do that and test it. As usual, if you have any question, kindly leave a question in the comment section or ask a question and I will reply you. And so something else that I would like for you to note is that these attributes can actually be redefined somewhere else. So they can actually be reassigned somewhere else. And attributes do not always have to be defined inside the init method. So we're going to take the first case of how attributes can be redefined or reassigned within another method. So I could actually come down here to my details method and say self does brand is equals to BMW. And I can say self dot model is equals to M4. And I can also say self dot year is equals to 2024 or so, for example. So what that now means is that I can actually reassign these variables, these instance attributes or object attributes, just like how we can do the same for normal variables. So what I will do is I will copy this line, come down here and also print. So we're going to see what it was before and then we're going to see what it is after. So let me just comment these out so that we can only see the print out when we call details for the first object. So when I come here and enlarge my terminal, once I run this file, I want you to see what we get. You see that we have Toyota printed out first. So if I go back here, we see that we have Toyota being printed out first, Toyota Camry at 2025. But the moment we reassigned these values and printed them out again by saying self to brand, self to model, you see that they have changed to BMW, M4, and 2024. So this is the first case where instance variables can be reassigned, even though they've been defined in the init method. They can actually be changed or reassigned in a different method. Now, something else that we can do is we can actually even create new instance variables outside of the init method. So for example, I can say self.color is equals to black. And in here, after printing the year, I can say color is self.color. Now, once I save that and actually clear my screen, once I run it again, let's see what we get printed out. Okay, so we are having an error because I spelled this wrong. This is meant to be self, S-E-L-F. So I'm going to clear my screen and run this again. So once I run it, you can now see for the first time it prints, it says Toyota Camry and 2025. But the moment I reassign the first ones and create a new instance attribute or a new instance variable, we can now see we have brand, model, year, as well as color. And it is black because that is what we assigned here, self does black. So I just wanted to explain that we don't always have to specifically I wanted to explain that it is not only in the init method that we can only create class attributes. We can create, sorry, instance attributes. We can create instance attributes in other methods, and we can also reassign or change the values of instance attributes in other methods. So it's not only restricted to the init method. So that is what I wanted to explain in this for this specific section. Now, in this section, we are going to be moving on to the next topic, and I'm going to be explaining the differences between class attributes and instance attributes. For example, in my classes and objects file, I explained what instance attributes were, and in my classes file, I explained what class attributes were. So you might be confused about what the differences are. So in this section, I am going to explain what the differences actually are. But before I do that, I just want you to also know that from each of these methods, instead of printing, we can actually just make them, we can actually just convert this to be returned. So What that means is that I can just say return this. I can just say the return keyword and it will return this string just like any other normal method. This will be returned. So this string would be returned. So what that now means is that wherever we call stop car, we can actually just come down to print out that value since the function or the method is returning a string. So I just wanted to explain to you that each of these methods can actually just return a value instead of printing it out. So you can perform some action that whatever action that you want to perform using the value that has been returned from that method. So for example, now I am printing it. I just wanted to explain that we can either, let me also print this. I just wanted to explain that we can perform both printing and returning of data from methods. So each method acts just like every other normal function, except that it can return data, it can print. The only difference is that it is within a class. So the next thing that we're going to talk about, like I said, was differences between class and instance attribute. So I want you to create a new file inside chapter 10, and I'm going to say instance and class attribute .py. So I want you to create a new file, call it instance and class attribute.py. So in this file or in this section, we're going to be exploring the differences between class and instance attribute. So I'll just go to my classes and objects file and I will copy the class which we had created earlier. And I'm going to paste it here. So we just simply have a class called car and it has an init method. Now, something else that I would like to tell you is that in other programming languages, this init method is usually called the constructor because it helps to construct and create a new class. So that is why it's called init in Python because we're like initializing a new object of a new class. So it helps us to create a new object of the class. I mean, so in other programming languages, it's usually called the constructor. So now to proceed, we're trying to find out what differences exist between instance attributes as and class attributes. So let's say, for example, we want to create a class called car, and all the cars that will ever be created from this car will have 4 doors. So I can create a new class attribute called number of doors, and I can equate this to 4. Now, what this basically means is that every single object that gets created using this car class will have an attribute of number of doors and it will never change because this is a class attribute. Now, the reason why you might want to define a class attribute within your class is, for example, creating variables that will never change within your class, or it is also you might also want to create a single variable that can be accessed by every single object that will be created by that class. And that variable and every single object created by that class, every single object will share the same data which has been stored inside that class attribute. Now, because we've stored created a variable, a class attribute called number of doors equals 4. What that means is that every single object that gets created inside this car class will also have an attribute of number of doors equals 4. So let's actually see how that will work. So I'm just going to go back to my classes and objects file and I will copy this instead of writing it again. So let me just come down and paste it. So I will actually get rid of these other methods right here. So what I will just simply do is I'm going to print out first car dot number of doors, and I will copy this and come down and I'm going to say second car dot number of doors. So before I actually call this number of doors, let me just add this details method to our car. I'm just going to copy it, come down here and add this method so we can actually also see details of our car. And I am going to copy this line for the first car, paste it, and I'll also copy this line for the second car and paste it right here. So what we've just done is we've created a method called details, and what it just basically helps us to do is display the details of the first and second cars which we had created. But I want to explain something to you. I want to show you that anytime we create a new class attribute, every single object that gets created inside that every single object that gets created by that class all share the same value of the same all share the same value of the class attribute. So I want you to notice what happens when I run this code. So let me open my terminal right now and clear my screen. So once I clear my screen and run this file, I want you to notice what we see. So right now, let's examine what we see. So we created a new object called we created a new object of the car class, and we passed in Toyota Camry and 2025, and we said first car details. So it came to this method and printed out the details, which was Toyota Camry and 2025 as the brand, model, and year. Now notice what happens when we said print car first car dot number of doors. It's printed 4. Now, when we came down here to the second object, we did the same thing. It's printed the details of the car, and it's also printed 4 as the second car dot number of doors. So what exactly class attributes does is that it creates a variable, or it creates a variable or a field that can be accessed by every single object that is created by that class, and all the classes will share the same value of that specific class attribute. So basically, the class attribute remains the same across all instances unless it gets updated within the class. So for example, if I change this to 67 now and I clear my screen, once I run this program again, we see that we have 67 being printed out for each we see we have 67 being printed out for each object. So class attributes will basically remain the same across every single instance or across every single object unless it is modified from the class. So we see now that these are instance attributes. So let me just add a comment here. Instance attributes, and this is going to be called a class attribute. So for example, when you're creating a class, you might want to define a class attribute which every single object will share. So something else that I could do was I could actually just change this to 4, and I can actually move this. I could actually have come down to declare this here and say self dot number of doors is equals to number of doors. So just follow with me. I'm coming. So I could just take this and move it into my init method as a parameter. But if I know that every single car object I'm going to be creating will have exactly 4 doors, then there is no need to put it as a parameter right here, because every single car attribute that I create is going to have 4 doors. So it's going to look like I am repeating myself. So instead of always having to specifically pass that into the method, what I will just into the class call, what I will just do is create it as a class attribute, like I have done here. So that would just prevent us from always repeating ourselves, from always having to pass 4 or whatever number of doors that your car has the into the car call. Now I want you to also notice that all of these have been passed in as parameters. So I could actually also just say brand is equals to brand here, brand. Brand is equals to brand. I can come here and say model is equals to Camry, and I can say year is equals to that. So you could actually choose to manually specify what each value is. So I can say Toyota is a brand, Camry is a model, and 2025 is the year. But if I don't pass those, if I don't specifically define what each value is, it will just automatically assign the first parameter I pass in as brand, the second parameter I pass in as Camry, and as the model, and so on. So that's basically is the difference between class attributes and instance attributes. So if you have any question, please do not hesitate to ask a question, and I will definitely reply you. So we are going to talk about the last two concepts for this beginner section in object-oriented programming. So I want you to create a new file and call it inheritance underscore and polymorphism, POLYMORPHISM dot py. So just call it inheritance underscore and underscore polymorphism dot py. So I'm going to explain exactly what inheritance means as well as polymorphism. So inheritance basically allows a class to derive properties and behavior from another class. So that helps us to promote code reuse. So what exactly does that mean? Inheritance, as the name says, basically helps one class inherit the attributes and the methods of a different class. So let's take an example. We have multiple animals, right? We have dogs, we have cats, we have, spiders. But each of those creatures are actually classified as animals. So we can have one master class called animal, and then we can have several other classes which inherits several other classes that represent each animal. For example, I can have a class called dog, and dog can inherit from a parent class called animal because dog is an animal. So let's actually see how that works. So I'm going to create a class and I'll call it animal. And this is going to just have, let's just say our animal class is going to have a simple method called make sound. And it's going to take in self. And in here, we are just going to print something. I'm just going to print some generic sound. Now let's look at this class that we have created. We have a class called animal, and it has a method called make sound. So what I can actually now do is I can come down and say animal is equals to, sorry, this is meant to be animal is equals to a new, we're going to initialize this animal class. So I'm going to say animal is equals to animal. And what are we going to do? We're going to say animal dot make sound. So let's just call that and save it. Now, once I save that and run it, you can guess what we're going to see is some generic sound because we have created a class of animal and we've called it make sound. Now, again, you might be wondering why I didn't actually create the init method by saying dot underscore underscore init and doing this. So the reason why I didn't actually create it is because by default, Python will actually create a new, it will actually run this initialization method without us having to specifically pass it in. The only reason why we might want to, create this method is if we want to perform some kind of operation the moment that class is being created. So for example, if I go back to the first file, which was called, or if I go back to the other file, which is called classes and objects, if we look at our init file, at the point of creation of that object, we wanted to assign some attributes of that object. For example, we wanted to assign the brand, the model, and the year. And we assigned them by passing those values the into the place where we called the class. So what that means is that we don't have to always create this init method. All we have to do is just, so if we're working on a class and we don't want to specifically define class attributes the moment we're creating it, we don't have to pass it in. But if you want to define class attributes like, let's just say name, then we need to create the init method the moment we need to create the init method so that the moment we are creating that class, we are going to automatically set that class attribute. So that is exactly why I didn't, we're going to automatically set the instance attribute, I mean. That is exactly why I didn't create the init method. So to proceed, we can see that we have this class called animal, and then it has a method called make sound. And when I call animal.make sound, it's just, it just automatically prints out some generic sound. Now, something else that we can do is inheritance. Now, I explained that a dog is a kind of animal, a cat is also a kind of animal. So, what that means is that we can create a new class which inherits from animal class. And by inheriting, we are basically trying to take, when we inherit from a class, we are basically taking all the attributes and all the methods of that specific class. So, let's see what happens now. I'm going to create a new class. Let me just actually do that here. I'll create a new class and I'll call it dog. Now, dog is going to inherit dog. Now, dog is going to inherit from the animal class. So we're going to say create a new class, call it dog, and pass animal into it. Now, what we're just going to simply do is say pass. So what we have done here is we have created a new class called dog, and we've told Python, okay, Python, I want you to inherit from animal. So what that basically means is that every single attribute or every single method that this class has, we are going to inherit it, and those attributes are going to be present inside the dog class. So what exactly does that mean? I can change these variables to, I can change this variable to dog, and I'm going to create a new dog class. Initiate a new dog object here, I mean. And in here, I'm going to say dog dot make sound. Now, the moment I run this code, I want you to notice what we have. You see that we also have some generic sound getting printed out. But you might be wondering, how are we able to call make sound even though that function isn't present inside the dog class? We're able to call make sound because that method called make sound is present inside the animal class, and we have inherited from the animal class inside the dog class. So what that essentially means is that we're able to access every single attribute and every single method inside the dog, inside the animal class. So I can even have a class attribute here, and I can call it species, for example. And I am not sure exactly what species dogs belong to, but I'm just going to put in, test, for example. So what that now means here is that I can come down to print dog dot species. So I'm just going to copy that. I can come down to print dog dot species, and once I save it and clear my screen, and actually come back here to run it. So once I run it, you can see that we have text being printed out as well as some generic sound. So what that means is that anytime a class inherits from a parent class, we can basically have access to all the class attributes as well as all the methods that the parent class has. So the nomenclature, or how we can actually name this, is the class which is being inherited from is called the parent class, and then the class which is doing the inheriting is called the derived class. So here dog is our derived class, and here animal is our parent class. So we're basically inheriting. That's why it's called inheritance. We're basically inheriting all the class attributes as well as all the methods of that parent class. Now, there's something else that we need to talk about, which is called polymorphism. Now, polymorphism basically allows the same method to behave differently based on the object that is calling it. So let's see exactly what that means. So here in this class, animal, we have a method called make sound. But what we can actually do is we can override this method inside our dog class. So what that now means is that the moment we call dog dot make sound, let's just change this to bark. So let's just simulate like our dog is barking. So because it's a dog, we know that dogs bark. So let's just simulate this as our dog barking. So what this basically means is that anytime we create a new class and we inherit from, anytime we create a new derived class and we inherit from a different class, if we want to override the default method which the parent class gives, we can actually do that, and that is perfectly fine. So all we need to do is just create a new method inside the derived class, create a new method with the exact same name, and we can execute a difference block of code. So this is what we call polymorphism. Polymorphism basically allows us to, it allows the same method to behave differently based on the object that is calling it. So because we have created a make sound method here, the moment I save this and I run this code, I want you to see what it gives us. You can see here it gives us back, back, back. That is because we had overridden the default method which we inherited from animal called make sound. We had overridden it inside our dog class by creating a new method with the same name, and we called it back, back, back. But if, for example, I now change this method to something else by saying, let me just say uh, dog make sound, for example. If I call make sound, instead of calling, it would first of all check. So now that I have changed this method to dog make sound and I call dog.make sound, what Python actually does first is that it comes to the derived class and checks if there is any method called make sound. If there is no method called make sound, it is then going to go to the parent class, which is animal, then it will check, does this parent class have any method called make sound? If it does, it is going to run that method. Let me just clear my screen right now and run this. So you can see it says some generic sound. But the moment I change this from dog make sound to make sound, what that now means is that if I run this again, we should see back, back, back as is being displayed here. So that essentially tells us that we are able to inherit from a class. We are then able to also override the content. We are able to override some methods of that class, and that is called polymorphism. So polymorphism basically ensures flexibility and helps us to reduce code duplication. So let's say, for example, we want to create 5 different animals and 3 of those animals are going to make the same sound, right? So let's just say we want to create like a cat, and a cat, let's just say we want to create 5 animals, right? And 3 of those animals are going to make the same sound. Instead of having to duplicate this method, instead of having to write this method 3 times in those 3 different classes, what we can do is you can create a parent class called animal and write this method once. And we can have those other 3 classes inherit from our animal class so that we don't always have to write this make sound method. Since all of them are going to be making the same sound, which is some generic sound, then there is absolutely no need for us to copy this method and paste it 3 times in those 3 different classes. All we can do is create a parent class, define it once, and those other 3 classes can inherit from our animal class, and then they will be able to call the same method. So this is basically one of the great um, ways object-oriented programming helps us. It prevents code duplication, and it prevents us having to always repeat ourselves. And it's also flexible because you can choose to inherit from a class based on some certain variables that you want to get. You can choose to inherit from it, make use of some certain variables, and like we have done here, and you can choose to override some certain methods, like we have done right here in our dog class. So we could actually even create a new class called cat, and cat can inherit from animal. And in here, we can just say pass. So I can come down here and say cat is equals to cat. And here I can say cat dot make sound. So when I say cat.make sound, it's just basically going to call this make sound method, which is present in my animal class. So once I clear my screen, I run this. You see, it says some generic sound for the cat. But if I now create a method called make sound inside this cat class, and I change this to meow, and I save it. Once I clear my screen and run it, you see that we have back, 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 meow, 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 because we said cat dot make sound. So that's exactly what inheritance and polymorphism means. Now it can become a whole lot complex. Now what that means is that
you can actually inherit from a class which has inherited from a different class. Now, we know that dogs are animals, but we also know that dogs have different breeds, right? So I can also even come down here. So this is where it can get complex. So I can come down here and create a new class and call it German Shepherd, because a German Shepherd is also a different kind of dog. It's a dog breed. And this can inherit from dog. And I can just say pass. Now, what exactly does this mean? So we have a class called German Shepherd and it's inherited from dog. Now, the dog class actually inherited from the animal class. So what that tells us is that we can have multiple layers of inheritance being created in our file. But although it's typically usually not advised, because then your code becomes very complex and difficult to manage. But this is something that is actually possible. We could even have, another class inherits from German Shepherd. Now, it's also one of the beauties and one of the things that make object-oriented programming complex and kind of difficult to manage. It is when you have multiple levels of inheritance. So that is why it is generally not advised to do that. But what we can do is we can actually create a new method here inside our animal class, and we can say eat, for example. Now, because every single animal has to eat something, then we can create a method called eat. And we can print out something saying some eating some generic food. Now, once I save that, I can actually then create a new initialization of my German Shepherd class. So I can come down and say German Shepherd dog is equals to German Shepherd. Let me just copy it here. I'm going to come here, copy it, come down, and I'm going to say call German Shepherd. And I'm just going to come down and say German Shepherd dog dot eat. Now you might be wondering, how am I able to call dot eat? Now I am able to call dot eat because if you remember, German Shepherd inherits from dog and dog inherits from animal. So what that means is that dog is going to inherit every single attribute of the animal class. So it's going to inherit test, this species is going to inherit make sound, it's going to inherit eat. So what that means is that in the dog class, it has access to all the methods and attributes that the animal class provides. Now, because German Shepherd is inheriting from dog, it also means that by extension, it is inheriting not only the attributes and methods of the dog class, but it is also inheriting all the attributes and methods of the animal class. So because I created a method called it inside my animal class, that now means that I can definitely access it inside my German Shepherd class. So what I can actually do now is run this file. And you can see it says eating some generic food. So we're able to access this method called eat, which is present in the animal class from the German Shepherd class. And as usual, you can actually override this method. So I can say it, I can call it inside the German Shepherd class. Now I want you to notice what happens when I run it. So when I run it, it says eating some generic food. So let me just change this to German Shepherd eating eating meat, for example, because dogs like meat. So once I save that and run this code now, let's see what we have. You see, it says German Shepherd eating meat. So that basically means that we can have multiple levels of inheritance, and each level basically inherits all the attributes and all the methods of the parent class. So dog is a derived class of animal, and German Shepherd is a derived class of dog. So you can have multiple levels of inheritance, and you can have what you call polymorphism also. So at each level of inheritance, you can decide to make use of polymorphism to override a specific method or to override a specific method which has been present inside the parent class. So right here, we had make sound, and I used polymorphism to override the make sound, which was present inside animal. I can also do the exact same thing right here for make sound. So for example, if I call German Shepherd dot make sound, we know that we're going to get back, back, back. So for example, I can come down and I can say, let me just copy this. I can come down and say German Shepherd dot make sound. So I'm just going to do that and save it and clear my screen. So once I save that and run this file, see what we get. We get back German Shepherd eating meat and then back, back, back. We get back, back, back because the German Shepherd class inherits from the dog class, which has a method of make sound. So we can, by extension, call this make sound method because the dog class, which is it is inheriting from, has a method called make sound. So I know that this can be complex in a way, but if you have any question, please feel free to ask a question in the comment section, or you can create a new, question or comment, and I will definitely reply you. Please feel free to ask. I know this might be confusing in some kind of way, but I will definitely explain if you leave a question in the comment section.
So before we move on to the next chapter, I realized that there was something that I actually left out. Now, in the last section of this course, I had explained, how inheritance worked and how we could inherit from the parent class and how the new class is called the derived class. Now, there's something that I hadn't mentioned. In the parent class here, it had a class attribute of species and it had a method right here of make sound. But what I didn't explain is how to inherit from a class that has a constructor or that has an init method defined. Now, what Python actually does is when you inherit from a class, if that class has an init method, what Python expects you to do is it expects you to channel the parameters which are required for the parent class in its method. It expects you to channel those parameters from the derived class or from the child class back to the parent class, which is person. So in this example, I have the parent class called person, and it has an init method, and it just takes in the name of the person as well as the age, and it sets those values. It sets the instance attributes of the name and age. Now, we have a different class called employee, and employee is inheriting from the person class. Now, earlier, when we ran the code, it didn't give us any issue. Now, in this case, when I come down to say my employee and I initialize a new employee, if I run this code, I want you to notice what it gives us in the terminal. You can see it gives us an error saying missing two required positional arguments, name and age. So what that means is that when Python ran this program, it's tried to initialize this, it's tried to create a new object of the person class because we are inheriting from the person class in the employee class. Now, when it's tried to run this initialization code, it realized that name and age were not passed into were not passed, so it failed and it said two required positional arguments, name and age. Because if employee is inheriting from a person, then that person definitely has to have a name and age. And at this point, that person object has not been created or that person instance has not been created. So what we need to do is we need to let our employee class, we need to create an init method in our employee class that will collect the name, age, as well as an employee ID. And then it will channel that name and age back to this person class, which is the parent class. So let's actually see how to do that. So we're going to come here and create an init method inside inside the employee class. So it's going to take in self. It's also going to take in name, age, as well as employee underscore ID. Now we're going to see exactly what is going to happen. So I'm just going to put a colon here and press enter. So this our employee method, or sorry, employee class is going to take in the name of the person, the age of the person, as well as the employee ID. Now what we need to do is we need to channel this name and ID, or we need to pass this name and ID into the constructor method of our parent class, which is called person. So the way we can do this in Python is just simply saying super. Now this is an inbuilt method that we can make use of in object-oriented programming. So what we can simply just do here is say super dot underscore underscore init. And I'm going to explain exactly what this is. Now pass in name and age. What exactly does this mean? When we say super, we're basically just referencing the class which we inherited from within the employee class. So super is just basically trying to reference the parent class, which is person, right? So what that means is that we can just substitute it, for example, by saying person.init. That's what Python is doing in the background. So we're just calling super.init. When we say .init, we're trying to call the init method inside this person class. And then we're passing in the name and the age because those are the required fields. So what I can now do next is with employee ID, I can create an instance attribute using this employee ID. So I can say self.employee ID is equals to employee ID. Now, when I now come down to initialize this new employee object, what I'm just going to pass in is name is equals to John Doe. Then the age is going to be, let's just say, age is going to be 67 or 68. And the employee ID, I'm going to set employee ID equals 1 because this is the first employee that we're creating. Now, the moment I clear my screen and run this again, we shouldn't see any error being printed to the terminal. So you can see that there is no single error right now being printed to the terminal. That is because we have successfully been able to take these details, which are name and age, as well as employee ID. We've passed it to our constructor inside. We've passed it to the init method in the employee class. And what the employee class is now going to do is it is then going to pass that name and age into our person class, which is right here, by calling super. When we say super, we're trying to reference the parent class, which we inherited from. And then we're going to say super.init because we're trying to reference the init method inside parent class. And then we're going to pass in name and age. Then we're going to set the instance variable of the employee class called employee ID to what has been entered in the init method. So that is why we no longer get an error. So this is exactly what I wanted to explain, how to inherit from a class which actually has an init method and it is expecting some certain parameters to be passed into the method. This is exactly how we are going to do it. Now, in this section in chapter 10, we are actually going to be working on a mini project. So what this project is going to do is, in order to solidify all that we have talked about, in order to solidify the knowledge of object-oriented programming, we're going to be working on a very simple project that combines topics like object-oriented programming with topics like arrays together so that we can fully understand how how these techniques work together. So we're going to be working on this simple project. It says create a program that allows adding, viewing, and deleting employee details using OOP principles. Now, if you remember where we talked about inheritance, I explained exactly how we can create, how we can inherit from a class that has an init method. So we're just going to come here and copy exactly what we have here, and I'm going to explain why we are doing this. So in order to actually start working on this project, we need to look at the structure. So it says create a program that allows adding, viewing, and deleting employee details using OOP principles. Now, we know that an employee is definitely a person, right? So using these OOP principles, we're going to talk about um, inheritance also so that that knowledge can be solidified. So we have a person, and that person has a name and an age. Now, because employee is inheriting from person, it means that an employee is also a person. So the employee, by extension or by means of inheritance, is also going to have a name and an age. Then right here, the employee is also going to have the employee ID. So when we create a new object, it would mean that a single instance of the employee class is going to have both name, age, as well as the employee ID. So all we have to do then is to create a way that we can is to write the code that will enable us to create multiple employees, store them somewhere, retrieve all these employees, and delete them. Now, before we actually start working on that method or that functionality, what we're going to do is we're just going to create a method inside our employee class that will help us display information about this specific employee. That is, we want a method inside our employee class that will help us display the employee's name, age, and employee ID. We're just going to call it details, def details, or detail. Okay, we can leave it as details. So I'm going to say def details, and this will take in self. Now, all we're just going to do is we're just going to print out a very, very simple formatted string. I'm going to print f, and in here, I'm going to put the formatted string. So the formatted string is going to be name, and we're going to say self.name. Again, we can say self.name because we have inherited person, and person contains this instance attribute of name and age. So because we have inherited person, it means we have access to these variables or this class attribute, instance attribute, I mean. So self.name, I'm going to say age is going to be colon self.age, and then employee ID. Employee ID is going to be self.employee underscore ID. So all this is just going to help us do is print out the details of this supposed to be name. All this is going to do is help us print out the details of a specific employee. Now, what we're going to do is we're going to create a different class which will help us manage all of the operations. The operations that we wish to perform are adding a new employee to our list, deleting an employee, as well as viewing all the employees within our list. So let's just use a list as our database. So we're also going to be making use of a list. So we're going to create a class that will actually handle all of these actions. So let's call this class, let's create this class, and we're going to call it employee manager. As you can see, we're using the Pascal case. Now, this class is not going to inherit from, this class isn't going to inherit from any other class as employee inherited from person. What we're just simply going to do next is we're going to create an init method. And I'm going to explain exactly why we're doing this, but just follow with me. We're going to create an init method. And in here, let's just put pass for now. Now, since our employee manager is meant to be able to store all employees in a list, that is, when we add an employee, we want all the employees to be stored in a single place. What we're going to do is we're going to create a class attribute, and we're going to call it employees. And we're going to equate this to an empty list for now. So this is going to be a class attribute, meaning that it's going to be available to every single instance that gets created, every single instance of employee manager that gets created. And every single instance is going to have the exact same copy of employees because it is a class attribute. And a class attribute can't be changed they can't be changed the from each instance. Every single instance is going to have its own copy of the employee's class attribute. Now, we have this list right here, and it is going to help us store something. It's going to help us store a list of employee objects. Now, remember that when we were talking about lists, I told you that lists are very dynamic. They can hold data types of different forms. Now, what we're actually doing here is when you create a class, you're actually creating your own kind of data type. I had explained that when we create a string, for example, so if I go to data types where we talked about it, when you do something like this, what we're doing is we're actually equating a value of 70.6, which has a data type of float, to grade. So what that essentially tells us is that float has a class. It is an object of a class, and we can actually come down to print the type of grade just to see what we get in our terminal. I'm just going to come up here and run this code. So once we run it, you can see it is a class of float. What that means is that, like I explained before, every single value that we specify has a data type, and that data type is actually a class. That is why we say class of float. So what that tells us is that we can actually create our own data type. So for example, I can come down here and I can say my employee, or let me just create a person class actually. I can say person one is equals to person. And in here, I'm just going to pass in the name and age. So let's just say John, and I'm going to pass in 67. So I can then come down and say print type of person one. And I want you to note what we get when I run this code. So once I run this, what do you see? We see a class and we see underscore underscore main of dot person. Now, what this is essentially telling us is that this variable person one is representing the value here is representing a class, right? And that class is of data type person. So what that tells us is that person itself is our own, it's a class, but it's also a data type. It is a user defined data type which we have just created. So classes actually in Python are a way of creating our own kind of special, data types, which we have seen when we printed out the type of this. It gave us a class of floats. So when we in turn printed out the type of person, it gave us a class of person because the name of our data type is person. Your data type name is basically the class name. So that is what I wanted to teach you about. So let me just clear this out for now. So after creating a list of employees, we said that this list is going to store, it's just going to store all the employees which we are going to be adding. So when we add a new employee, that employee instance or employee object is going to be stored inside this employee list. We know lists are dynamic, so they can store data types of different kinds. So inside this init method, all we're just simply going to do is we're going to put pass for now. And the next thing is that we are going to create a different method. Now, this new method that we're going to create is just going to display to the user the possible operations that they can perform. And it's going to request the user to enter the operation that they wish to, that is going to tell the user to enter the operation that they wish to execute. So I'm just going to create a new method and I'll call it operation. And this is going to take in self. We'll put a colon here and press enter. So I'm just going to print out a string. Now, this string is just going to basically display all the options that our program is capable of, all the actions that our program is capable of performing. I'm going to put one. So one is going to be for adding a new employee. So I'm going to say add employee. And I'll put a line break and I'll say two is going to be view all employees, right? So view all employees. And then we'll put another line break. And then three is going to be delete an employee. And after printing these values out, let me just put a \n. We are then going to make use of the inbuilt method or function to actually collect a value from the user requesting what option they wish to perform. So I'm going to say user operation, that is what the user wants to select, is going to be equals to the input method. And in here, we're just going to say enter or select operation. Now we're going to, okay, ERATION. We're going to wrap all of this inside the int keyword because after collecting it, what we're going to do is we're going to convert it into an integer so that we can check whether the user entered one or two or three in integer format. That's why we're wrapping it in int. So after collecting this operation, we are then going to create other methods. We're going to create a method for adding an employee, another method for viewing an employee or viewing all employees, and a third method for deleting an employee. So this operation method is basically going to help us always print out the operations that the user can perform, as well as request the operation that the user wants to perform. It's going to always do that. So we're going to leave this operation method for now. Let's just come back to our init method. So what we're just going to do is we're going to call this method and say self dot operation. So self dot operation. Now, what exactly does this mean? Now, all what this basically means is that the moment this class is initialized, that is employee manager, the moment we run this program and the moment we create a new employee manager instance, it is going to immediately call this self the operation. It's going to immediately call this method. Now, what this method is going to do, as we see it, it's just going to print out these values and ask you to enter some data. Let's actually test that. So I'm going to say manager is equals to employee manager, and I'm just going to call it. Now, once I save this code, go back up and press play. Let's see what we get. You see that we have these options being printed out: add an employee, delete an employee, and view all employees and delete an employee. You can see it's now asking us to select an operation. The moment I press 1, for example, the program ends because we haven't actually done anything with the inputs that we are collecting. So that tells us that our program immediately it gets in uh, our program basically helps us call this self the operation the moment a new object or a new instance of employee manager gets initiated. Now let's write the code, the first code or the first method which is required, which is add employee. Now what we simply need to do is create a different method which is going to help us add an employee. Let me remove this empty space here. I'll come down here and say def add employee. I need to take in self. Now, what exactly do we want to do inside this method? Now, inside this method, we want to create a new employee. Now, remember that in order to create a new employee, we need the name, age, as well as the employee ID. Now, we are going to actually have to collect these details from the user. That is, we'll collect these details from the terminal, that is the console, when we run the program. And then we are going to use those details to create a new employee, and then we're going to add that employee to this list. We're going to append that employee to the list. So let's see how we're going to do that. So the first thing that we're actually going to collect from the user is name, followed by age, followed by employee ID. So let's do that. I'm just going to say name is equals to input, and I'm going to say enter name, or let me just say enter employee name. Let me just copy this so I don't always have to write it again. So enter employee name, and then the age is just going to be int of inputs, and inside inputs we're going to say enter employee age, and the last thing is the employee ID. So actually we don't really need to wrap this in an int because we're not trying to do anything special using the age character, or using the age I mean. So the last thing is employee ID, and this is going to be equals to, now we're going to convert this into an integer actually, because it's an ID, so IDs are typically integers. So I'm going to put an input, I'm going to call the input method here, or input function I mean, and in here I'm just going to say enter employee ID, and I'll put a colon there. So at this point, this method is going to help us request name, age, and employee ID. Now, after collecting all of these details, what do we want to do? We want to create a new employee. And after creating that new employee, we're going to add that employee to this our list of employees right here. So let's just create a new variable, and I'll say new employee is going to be equals to. Then we're going to create or initialize a new object of our employee class inside this method. So we're going to say employee. And what things do we need to pass into this employee class? Remember, we need to pass in the name, the age, and employee ID. And then the name and age will automatically get passed the to the parent class, which is person. So that name and age will automatically get set here. So what do we need to do? We just need to pass name, age, and employee ID. So all we need to do is just pass these values in, or you could specifically also say name is equals to name. You could say age is equals to age, and employee ID equals employee ID. But I'm just going to go with the short route and just pass in name, age, and employee ID. So after doing this, we're just going to append this new employee to our employees list. I'm going to come down and say employees dot append, because okay, let me just make sure I am. So, okay, so this is employees. So what we're just simply going to say is self dot employees dot append, and in here I'm just going to pass in new employee. So the reason why we can say self.employees is because employees is a class attribute. So it is a class attribute that just stores the list of employees. This is why we can say self.employees. That is, we're trying to access the employees list within this object. And remember, the object is always going to have access to these employees. Every object is always going to have access to these employees um, list because it is a class object. And then we can call dot append because it is actually a list. I remember when we spoke about list methods, which was right here, we spoke about dot append, which basically helps us add a new item to a list. So we're basically going to be adding that new employee to the list. So let me just write a comment to describe all of this. So I am just going to say create a new employee instance slash object. And here, what we're just doing is save the employee to lists. We're basically just saving that created employee to this list. So that is what this first method is going to do. Now, what we need to do next is the second operation that our project should be able to perform is viewing all the employees within this list. Now, if you remember, we had created a method here called details, and it basically just displays the details about a specific employee. So what we're going to do is we're going to write a method which will loop through all the employees within this list and call this method. Now, I am going to explain exactly what that means, but let's just proceed. Let's create a new method and call it def view employees. And this is going to take in self. And what we're going to do is we're going to write a for loop that loops through all these employees. Now remember that this employees list stores a list of employee objects or employee instances. And because each of these employee instances already has this method, which is called details, attached to it, what we can do is we can loop through every single employee in this list and call this method for it. So it will display the details for each employee. So I'm going to write a for loop here. I'm going to say for employee in self dot employees. That is, I'm saying self dot employees because I'm trying to reference this object. I'm going to put a colon there. Now, all we're just going to simply do is we're just going to say employee dot details. So we can actually rename this to view employee. So I think this is a better description. This is a better name. I'm just going to copy it. I'm going to say for employee in self.employees, I will just say employee dot view employee, and I'm going to call it. So what we are simply doing here is since this our method, since this our list is going to store a list, since it's going to store a list of employees, and each of these employees are objects, and each of these values are objects of the employee class. It simply means that we can call this method for each of those objects that are stored here. That is why we are saying for employee in self.employees, employee.view employee. So it's going to call this method and display the detail. So what we can actually do then is put a \n so that it will always create a new line after printing out one of them. Now, the next or the last option is we need to actually then write code, which is going to help us delete an item or delete an employee from our list. Now, what we're going to do is we are going to also write another method for this. So I'm going to say def view delete employee, and this is going to take in self. Now, what exactly do we want to do inside this method? What we want to do is In order to delete an employee, we're going to delete that employee using the employee ID. So this method, when it is run, it is going to ask the person, okay, enter the ID of the user which you wish to delete. Now, after it has entered the ID of the user that it wishes to delete, we're now going to search through this employee list. We're going to search through this list and check for the employee object whose employee ID matches what was entered. We're going to see exactly how that works, but let's just proceed. So we are going to create an input. We're going to create an input field right here. So I'm just going to copy this since I already have it up. Now, once I have copied it, it's just going to say enter employee ID to be deleted. Now, once we have been able to grab that employee ID and store it in this variable, what we're going to do is we're going to write a for loop that will go through every employee in this list, and it is going to check, is the current employee's ID equal to this employee ID that was imputed? If it is, then we're just going to remove this item from the list using the .pop method. If we go back to list methods.py, you see that we can pop items from this list. But we're actually going to be we're actually going to be removing that item from this list using different method. So back to our method, we're then going to write that for loop that will loop through all the employees. So let me just copy this for loop right here. So I'm going to say let me close this out, sorry. So I'm going to say for employee in self.employees. So we're trying to reference this employees list. So we're saying for employee in self.employees, what do we then want to do from here? What we're just simply going to do is check if that current employee, that is, if this current employee has an ID, that is, has an instance ID that matches the employee ID that was entered by the user, then we're going to remove it from this list. So we're going to then write a for loop here. I'm going to say if employee dot ID is equals employee ID, which is what has been entered here, then we're just going to simply say self dot employees dot remove. And what are we going to remove? Okay, sorry, employees dot remove. And what are we going to remove? We're simply going to remove the current employee, which is this current employee. So let me explain exactly what is happening here. Now we've said for employee in self.employees, that is loop through this entire list of employees, which by the way is storing objects. Now, because it's the storing object, we can just say, okay, actually, instead of ID, it's meant to be employee ID. So this is not meant to be ID, this is meant to be employee underscore ID. So we are basically looping through this thing. We're saying for employee in employee self.employees, if employee.employee ID equals this one that was entered here, that is, if this current object, which is inside this array, if the employee ID of that object matches what was entered, we're just going to say self.employees.remove. Now, lists have another method called .remove, and it basically helps to remove an item from a list. So we have two ways of removing an item from a list. We have .pop, we also have .remove. So they both do the same thing. The only difference is that .pop takes in the, let me just go through it again. The only difference is that .pop takes the ID, that is the location of the item that you wish to remove, while .remove takes in the value itself. So if I wanted to make use of .remove, I would just say names remove, and in this case I'll say Jane. So this is meant to be names remove Jane. So pop just takes in the ID of the sorry, it takes in the index, it takes in the index of the index position of the value that you wish to remove, while remove takes in the actual value itself, not the index. So that is basically the difference between pop and remove. So what I'm just simply saying is, okay, we're telling Python to remove this employee object from our list. Now that is all we need to write for the delete employee method. So what we're just simply going to do is, since we already have all of these methods created within our class, we're just going to start calling them from the operation method. So what I'm going to say is, I'm going to say if user operation is equals to 1, then if it is equals to 1, we just want to add an employee. I'm going to call self.add employee. So what this basically tells us is that we can call other methods within a specific method in a class. So if I'm in a method called operation, what that simply means is that I can call another method within the same class and it will properly run. This is exactly what we did here in the initialization, in the init method. I just simply called self.operation from this method. So we can call other methods from a single method. Then I'm going to say else if the user operation is equals to 2, then what does that mean? The user wants to view all employees. So I'm going to say self dot view employees. Then I'm going to put if that is else if user underscore operation is equals to 3, then what I want to do is delete an employee, right? Is delete employee. Okay. Self actually dot delete employee. And I'm going to call that method. So once I do that, our program basically is able to perform different operations based on whatever the user has selected, right? So if it is 1, the user adds an employee. If it is 2, the user views an employee. If it is 3, the user deletes an employee. Now, at the end of all of this, it is then able to perform all of these different operations based on what the user has entered. Now, there's something else that we need to add. So after each operation has been performed, let's just display the list of operations again so that the user can see all the operations that can be performed. I'm just going to come down here and call self the operation. So it's then going to print out everything, print out all the operations and ask the user for the operation they want to perform. So it always asks the user for the operation they want to perform after it has finished performing any of the operations entered. I'm going to call self the operation. And right here, I'm also going to call self the operation. Make sure you don't call self the operation inside any of these indented blocks. Make sure it's at the end of the processing. So all I'm just going to do is I'm just going to save it. Now, once I save that, all we have to do is just basically run this program. So if you have any question, please do not hesitate to ask me a question and I will definitely be happy to reply you. So let's just open the terminal and see what we have. So I'm just going to open it wide and I'm going to run this program. So once I run the program, you can see it first of all asks us what operation we want to perform. Let's enter 1 to add an employee. So you see, the moment we enter 1, it is asking us to enter an employee name. And that happened because right here, the moment we entered 1, it's called self.employee. So it's called this method on itself. So let's just enter the employee name as John, employee age as 56, and the ID as 1 because this is the first employee. So when I press enter, you can now see that it immediately asks us to enter to select the operation again. That is because after performing all of these operations, we just simply told it to say to call self the operation. So it came back to this method and ran all of this again. But let us actually put a line break so that everything looks better. So I'm going to break out of the terminal by typing Control C. That is why all of this broke out. And I'm going to run this program again. So I'm going to add an employee. Let's just say John. Let's just say age is 56. ID is 1. Now I'm going to add a second employee. And the name is going to be, let's just say Solomon. The age is going to be 78 and the ID is going to be 2. Then let us add a third employee. So this person is going to be named David. Age is going to be 23 and ID is going to be 3. Now let's just view all employees by pressing 2. So when I press 2, let's look at what we were given. So the moment I press 2, you can see that we have three different items being printed to the terminal. We have the name is John, age 56, employee ID 1, name Solomon, age 78, employee ID 2, as well as for the last person which we had entered. So you see that the moment we enter 2, Python immediately called this view employees method, and it loops through all the employees inside the employee list, and it's called this method, which is employee.view employee. And that method is right here when we said view employee. So it just basically calls that method and displays all of these details to the screen. Now, let's say, for example, we wanted to delete like the second employee, which has an ID of 2. I'm just going to enter 3 to delete an employee. Now, we're going to enter 2 because we want to delete the second employee. When I press enter, we are now seeing that it asks us to select the option we wish to perform. Let's just say 2 because we want to view all employees. Now, the moment I press enter and go up, you can now see that we can only see 2 employees being printed, because if we come to this delete employee method, what Python did was it looked through our list, it checks to see if the employee ID that was entered here matches the employee ID of any of the objects which has been saved to this employees list. Now, the moment it saw that, okay, we have the second item has the ID which was entered to be 2, it then deleted all the employees. And I can do the exact same thing. I can delete the first item, and the moment I press 2, you see that we have only one employee printed out to the screen. So that is exactly how our program works. So you see that our program is capable of performing multiple operations. So I can just end this and clear the screen. So you see that our program is capable of performing multiple operations, and everything is working beautifully. So I've been able to make use of classes, inheritance. We've made use of lists. We've made use of for loops, conditionals, as well as calling objects, calling methods from within the class. We've made use of the input method. So you can see how all of these concepts which we have talked about from the beginning are actually coming together to build a more complex project. I believe we built something similar when we were talking about functions. Was that in chapter 8, mini project, where we built this mini project where it said create a program where users can add, view, and delete contacts using dictionary. So we were able to do all of this using functions. Now, what I'm going to tell you to do is just to test your knowledge. I am going to ask you to try and recreate this entire program, but using classes only, classes and methods, as well as obviously objects. Try to convert all of this code, which has been written in a procedural manner, where everything has been divided into methods. Try to convert this code into an object-oriented paradigm type code. So we write everything using classes and objects. And if you have any issues, kindly leave a comment or leave me a message, and I am going to definitely reply you. So that is all we're going to talk about in this section. Now, I want you to also note that this can be written in different ways. Even though I have broken it down into different classes, and I have decided to call this operation method inside the constructor, you could also write it in totally different ways. For example, I could decide to change this init method to a method called run, and all I could do here is I can come down to say manager.run, and it would still do the exact same thing. It would just call this run method, which would call this operation method. So it's the exact same thing. So you could just tinker with it and write it in any way or form that you think might work, as well as also try and attempt converting all of this into an object-oriented code. In the next chapter of this course, we are going to talk about exceptions and exception handling in Python. So what I want you to do is create a new folder, call it chapter 11. And inside this folder, I want you to create a new file and call it exceptions.py. So before we actually start even writing any line of code, we need to understand what exceptions are. So exceptions basically are they're Python's way of signaling us that something went wrong during the execution of a program. Now, this might usually occur when, for example, you run your program and it crashes in the terminal, giving an error. So that's exactly what an exception is. Python raises an exception or throws an exception, which is an error that tells us that something went wrong during the execution of our program, and this exception usually gives us the reason, shows us the reason why we had an error and shows us the reason why our program failed. So what exactly then is exception handling, because we had just spoken about exceptions. So exception handling basically allows us, or it's a way that allows us to deal with these exceptions and these errors when they occur, so that it doesn't completely crash the entire program. So we can actually write some code that will check for when an exception occurs or if an exception occurs. So if that exception occurs, we are then going to handle it gracefully. So that will prevent the entire program from crashing or breaking or giving us an error. So I'm going to show you a typical example that might happen when you have an exception. So let's say, for example, we have two numbers. I'm going to create two variables. I'll say num1 is equals to 5, and I'll say num2 is equals to 0. Now we know that we can't divide any number by 0 because we're going to have an error. And in mathematics, normally, you can't divide any value by 0 because you get undefined. So let's just say, for example, we wanted to say division is equals to num1 divided by num2. So we're essentially trying to say, we're essentially trying to say the 5 divided by 0. And after this, we just want to print out the value by saying division. So I'm just going to bring up my terminal here and show you what happens, show you the error that we get. So let me just pull it up and I'm going to run this program. So notice what we get. It gives us an error saying zero division error. Now, the reason why we get zero division error because it says division by 0. So this is the reason why we are getting this error. And it actually shows us the line where this error occurs. So it says line 4 in this particular file. So it says line 4 in module. What that basically tells us is it's referring to this line 4. So sometimes you might see like long errors that might be thrown when you're running your Python program. But what you need to do is check through all the error logs and check for the line that it is referencing. Here it's referencing line 4. And it shows us the exception or the error that Python threw, which was zero division error. Now note that it didn't even bother to print out division because the program essentially failed at this point. So any other line of code that comes after line 4 will not even get executed because this line has failed and crashed the program. So so this is basically what exceptions are. And in a lot of cases, we might want to write some code that will that might crash, and we want to handle that crashing gracefully so that the entire program doesn't just crash and fail. So what we can do is using exception handling, we can actually check to see if this line is going to crash. Now, if it crashes, we are going to just handle that gracefully so that every other line of code that comes after it can actually get executed. So we're essentially going to try to execute the program. If we're going to try and execute a block of code. If the execution fails, we're going to handle that failure in a different block of code and then continue with the execution of other programs. So let's just say we have, for example, 10 lines after this. We can handle this error gracefully in, it's something called try and catch. So I try and accept, in Python. So we're going to try to execute a block of code. If it fails, we're going to handle it inside the except block, and we're going to continue executing the other lines of code that comes after it. That is basically what exceptions and exception handling are in Python. They basically help us. Exceptions basically tell us that, okay, something went wrong in your code. And exception handling allows us to handle the errors that come up when executing our program. And there's actually a way that we can throw and generate our own custom errors. So we can actually generate and raise our own exceptions in Python. And I'm going to show you how. What we see here was automatically raised by Python itself. when we try to run this, but we can actually create our own way of raising exceptions programmatically. And I'll show you how to do this in the following subtopics in this chapter. In the next section of this course, we are going to be discussing exception handling. So we've talked about exceptions and how they might be generated in the last section of the course. But what we need to then talk about is how do we handle these exceptions that might actually come up. So what we are going to do is we are going to create a new file in chapter 11 and call it exception underscore handling dot py. So we're just going to be explaining exactly how to work with exceptions and how to handle them inside this file. So there are actually three ways of handling exceptions. There are actually three blocks that we can use, rather. There are three blocks of code that we can use to handle exceptions, and these are inbuilt into Python. So they are the try, the except, and then the finally. So these three blocks basically help us to handle exceptions, and I'm going to be explaining each of them one by one. Now, the first one is called try. So the try block basically contains code that might cause an error. So what we're simply telling Python is we want you to try and execute a certain block of code, but if there is an error, then the except method is going to pick up that error. So the try basically is going to execute a block of code that might cause an error. So what the except does is that it is then going to handle the error. It's going to handle the error that gets triggered in the try block. And in the finally block, it just always runs whether an error has occurred or not. So it's useful for cleanup tasks. So I'm going to show you exactly how all of these work. So what we're going to do is we're just going to go into our exceptions.py file, which we had created before. And then I'm going to copy everything that is inside here. And I will go into my exception handling and paste it there. So what we have here is basically what we talked about in the last class, where we had two numbers and we're trying to divide 5 by 0. And the moment we run this, obviously, we are going to get an error because anything divided by 0 in mathematics is undefined. As you can see, it says 0 division error. So what we can actually do is we can wrap all of this inside a try block. So what essentially this does is that we're telling Python, try and execute this block of code. But if an error occurs, what do we then want to do? This is where we write the except block. So the except block is just going to immediately get triggered if any error occurs in the try block, because we're telling Python, okay, try to execute this block of code, but if an error occurs, jump to the except block and handle the error. So I'm just going to type an except and I'm going to print something to the terminal. I'm going to print an error occurred and I'm going to save that. So once I save that, I will just come here to clear my screen again. So once I clear the screen, we are actually going to test this code to see if it works. So I'll come here and run this Python file. It prints out an error occurred. Now, this is exactly how try and except blocks work. You saw that in the last the last time we tried to run it without using the try and except blocks, you can see that the program just crashed and displayed some error in the terminal. But now that we're using try and except blocks, it means that we can handle program crashes gracefully, meaning that the entire program doesn't just have to crash without us knowing exactly what happened. So using try and except blocks, we can then perform some certain operation based on whether it was successful or not. Now we're going to talk about the last exception handling tactic or method in Python, which is finally. So the finally block, like I had explained earlier, it's just always going to run whether an error occurred during the execution of the try block or not. So if it's even successful in executing the block of code inside the try section, the finally is still going to run. But if there's an error and the except block runs, the finally is still going to run. So as the name says, finally. So whether it is successful or not, it is always going to run. So after it finishes running, I'm just going to print something to the terminal, which is execution complete. I'm just going to save that and we can actually test this right now. So let's just run this program to see what we get in the terminal. So you can see that we get execution complete being printed to the screen.
So the finally will always run regardless of whether it was successful or not. So what I can actually do is if I change this to 2 now, I want you to notice what we see in the terminal. So allow me just to run this. You see, we see that we get 2.5 being printed out because 2 can indeed divide 5, and we have 2.5 as the solution. So we have 2.5 being printed out here. And then execution complete still gets printed out because finally block will always run regardless of whether the operation was successful or not. Now, there's something else that I would like to teach you about. There's actually ways of catching specific exceptions. Now, if I go back to my exceptions.py file and I try to run this again, you are going to see the error that we get in the terminal. And I want you to pay attention to something. You see that we have this thing here, zero division error. This is actually an exception that we can directly catch or directly handle. Inside our exception handling.py file, the moment you write except and put a colon, what you are essentially saying here is you just want to handle any kind of error that could occur inside this block of code. That is, any kind of error could occur. For example, the only error that is occurring now is we were trying to divide a number by 0, which is invalid. So that is the only time an error could occur. So the except block will handle the except block will handle any kind of error that comes in. But there is a way to actually handle specific exceptions, unlike how what we have written only handles all kinds of exceptions. There's a way to handle specific exceptions, like the exception that we have seen here. If we look at the terminal, it says zero division error, division by 0. So that tells us that exceptions actually, that tells us that we have different kinds of exceptions. And how exactly can we check for specific exceptions? We just simply copy the exception that's been printed to us in the terminal, come to our block of code, and I can paste it right there. So I can just say except zero division error, then we're going to print an error occurred. Now, I want you to notice what happens when I run this block of code again. So once I run it, you see that we have an error occurred being printed out to the terminal. That is because our program was able to detect and catch that error, which was thrown from the try block. So the try block had tried or had attempted to execute this code, but then Python threw a zero division error. Now, this is actually inbuilt into Python. So Python threw this error to us, and we can actually use the except block to catch this error manually by ourselves. So if we don't pass in the exception, all we're just going to do is, if we don't pass in the exception and just leave except like this, it means that this block of code will catch any kind of error that comes in. But a lot of times when you're programming, you want to be able to detect the exact error that happened or the exact exception that was triggered. So this is why it is important that we are able to catch some specific kind of exceptions or errors that might happen from the try block. Now, there's also something that I want you to take note of. The moment I run this exceptions.py file, there are two things that I want you to look at. We first of all see the zero division error, which is the exception that was thrown. And we see some text being printed here, which is division by 0. Now, we can actually gain access to this text called division by 0. And the way we can gain access to this text is just by heading back to the exception handling, and we can do something like except zero division as E. So when we say as E, we're just trying to access the message that was returned, or the message or the text message that was generated by this specific error. So when we say as E, it means that that message or that text which was here is going to be assigned to this variable E. So it could be anything. For example, we could say as error. It doesn't matter, but usually we will just use E for short, and it just signifies error. So what this simply means is that we are able to grab the text which is here. So instead of printing out an error or code, I will just rather come down and print E so that we can see exact error that was generated. So I'm just going to clear my screen and run this program. So now that I have run the program, you can see what gets printed out, division by 0. So let's actually format it so we know it's coming from this line. So I'm going to put the F string and I'll say error occurred. and I'll put a colon here, and I'm going to pass in E, just like that. I'm going to save it, clear my screen, and run this program again. So once I do that, you can now see that we have the formatted string printed out. It says or error occurred and then colon division by 0. So that shows us exactly how we can catch specific errors as well as catch the text that was generated, or the message basically that was generated by that exception. So we can catch the error, we can catch the exception as well as the message that was generated by that exception, and we can do whatever we want using those details. And you can see that the finally block, as usual, always runs the moment the program has finished, executing either the try or the except block. The finally block will always run as per the name. So that is exactly how we can handle exceptions that might occur. Now there's a whole lot of exceptions that are actually present in Python, and I would encourage you to check them out. So a list of exceptions that you can actually check out is, you could just go to Google right now and Google Python list of exceptions, and make sure you click the W3 schools link. So once you do that, or you could just visit the link right now from what's displayed in the screen. Once you visit it, you see a list of built-in exceptions. So you can see arithmetic error. This is raised when an error occurs in numeric calculation. So you can see there's assertion error, exception. So this is a base class for all exceptions. So what that means is that what we could actually do is, instead of saying zero division error, if we wanted to catch all exceptions, we could actually say except exception as E, right? Now, once I save that, turn my screen and run it, I want you to see what we get. So you see that it says division by error. So when we say except exception as E, exception here serves as the base class for all exceptions. So this would be like, this is kind of generic because we wouldn't exactly know what kind of error it is that we are going to get. We wouldn't know exactly what kind of error it is that we're going to get. So it's like a general way of handling exceptions. So when we say except exception as E, we can then grab every single exception that comes in. And when we say as E, it means that we can grab the message that was generated by that exception. So that is exactly how we can use this, for example. So you can see there is a whole lot more. There is like a long list of inbuilt exceptions that we can make use of. There's keyboard interrupts. This is raised when the user presses Control C. So you can see there's a whole lot of exceptions that can be used. So I would encourage that you check it out and actually practice some of them on your own. So that is all we are going to talk about in this specific section. So I taught you exactly how exceptions work, exactly how we can handle those exceptions using the try, except, and finally block. Now, in the next section, I'm actually going to teach you how to raise your own exceptions. Now, Python actually allows you to raise your own exceptions. So it's not just built-in exceptions that are possible. You can always also generate your own kind of custom exceptions. So in the next section, we are going to move on to exactly how we can raise our own specific exceptions. So I want you to head to chapter 11 and create a new file. And I want you to call it raising underscore exceptions.py. Now inside this file, let's just assume we were building an application and we want to collect the age of users. And we want to make sure that users who are signing up on our platform are at least of the age of 16. Now, if you are not at the age of 16, we want to generate or raise an exception, letting the user know that you cannot use this program because you are below the age of 16. We can actually do that. So we're just going to create a variable called age. I'm going to equate this to the int, and this is going to be wrapped. The input keyword is going to be wrapped inside the int. Sorry, the input function is going to be wrapped inside the int function because we want to collect an integer. I'm just going to say enter your age, and I'll put a colon here. So what do we then want to do? We want to check if the person's age is less than 16, then we're going to raise our own custom error. So how exactly do we do it? We're just going to say if age is less than 16. Now, this is where we actually write the code which will raise
or create a new exception. Now, how do we do that? There is a special keyword in Python called raise, and it is used to raise a new, for example, when you want to create a new custom exception or you want to invoke or trigger an exception, we can use the raise keyword. So we say raise space value error. Now I'm going to explain what this is, and but you just follow with me. So we're going to say raise value error, and we can pass in whatever text we want. We can say you must be at least 16 to use this program. Then else, I'm just going to write an else here, and I'm going to say, I'm just going to print out something generic like your age is valid. Let's just say something like that. Now let me explain what is happening here. So we're first of all checking if the person's age is less than 16, then I want to raise a new value error exception. Now this value error is actually an inbuilt exception that comes with Python, and we can actually just call it anytime we want. We can invoke it anytime we want. If I head to the list of exceptions which I spoke about earlier, here it is called value error, and it says it is raised when there is a wrong value in a specified data type. So we could just decide to raise a value error saying you must be at least 16, you must be at least 16 to use this program. So this is why I actually encourage you in the previous section to check out this list. So this error is just raised when there is a wrong value in a specified data type. Here, the wrong value is the age that has been entered because the age is not up to the required age, which is 16. So we're trying to raise a value error. Now, there's something I want you to notice. Here, the exception that we are throwing is called value error, and the message that is assigned to that error is what we have actually passed into this program. Now, remember that in the last, in two sections before, when I ran this program, we got an error being printed to the terminal. So we see the exception and we see the error also being printed out, the error message. Now, that error message is actually coming from here. So when we run our own program and we enter an age which is less than 16, we should see this error being printed. So what I will just do is I'll clear my screen right now and I will run this program. So for the age, let me just enter 12, for example. Now, once I enter 12, notice what we get. It says value error. You must be at least 16 to use this program. So we can see now that our program is capable of throwing its own exceptions. So it says value error here, which is the exception which we had decided to throw by ourselves. And it said the message is you must be at least 16 to use this program. And that is the exact message which is here. And if I hover over this, you can see it says class value error, and it accepts some arguments. So the argument that we can pass in is the message or the text that we would like to be displayed when this error is thrown. Now, because we are capable of raising exceptions or throwing them, what we can now do is we can now make use of try and except blocks inside where we are throwing this value error. So what I can just simply do is I can write a try block here and indent all of this. Now, what I can then do is write an except block, and I can say except value error. And what do I want to do? I'm just going to except value error. I'm just going to print out. Okay, so what we're actually going to do is we'll say except value error as E so that we can grab that message which is being printed out. So except value error as E, we're just going to print E out. Or instead, let's print a formatted string. So I'm going to print out error occurred, and inside there, I'm going to pass in E. So let's clear this program or clear the terminal and see what happens. So once I run this, it's asking me for my age. I'm just going to enter 12. Now, instead of the program crashing like the way it did last time, the moment I press enter, you see what happens. It just prints out error occurred. You must be at least 16 to use this program. So what that tells us is that we can explicitly generate or throw a new error by ourselves, and we can catch that error in an except block. So you could also add a finally block here, but I don't think there's any need. I'm sure you already understand how the finally block works now.
So what that means is that we can just throw an error and we can catch that error and display what message has been, you know, passed into that error. So this essentially helps us to make sure that our program doesn't just crash anytime there's an error that occurs. It means that we can actually handle errors that may be generated. Now, the next thing that we're actually going to talk about is how to handle multiple exceptions. So sometimes multiple exceptions might be generated, or sometimes we might want to check for multiple exceptions that might occur inside a try and except block. What that means is that if this line doesn't crash, let's just imagine I have 10 lines inside the try block. The first few lines might not necessarily give an error, but the next few lines after the three lines might generate multiple errors. So what we can do is we can actually make use of we can actually handle multiple exceptions in Python. So that way, we're able to catch multiple exceptions if we're able to check for multiple exceptions that could possibly happen during the course of execution of the program. So it's a very beautiful way where we can execute programs and ensure that the entire system doesn't just crash, even though an error occurs. So if the error occurs, we can handle this. If the exception occurs, we can handle this gracefully, like how we did here right here. So we're going to look at that in the next section. So in this section, we are going to talk about handling multiple exceptions. So I want you to create a new file inside chapter 11 and call it handling underscore multiple underscore exceptions dot py. Now once you do that, I just want you to open the file. So right now we're going to talk about how to handle multiple exceptions that could potentially be generated during the course of execution of the program. Now I want us to try and do something. Let's say age is equals to a string and it is 12. Or no, not even 12. Let's say age is equals to ABC, for example. If we try to convert this into a string, into an integer, it's going to give us an error. Now let's just create a new variable and say new age is equals to int of age. Now, if I save this, once we run it, what do you think it's going to give us? It's going to give us an error because anytime we want to convert an integer or anytime we want to convert a string into an integer, the string has to be alphanumeric. That is, it has to be a value that can be converted into a string. So it has to be a string, sorry, it has to be an integer which is actually enclosed in a string. So it must be something like 3, like um like 3 or 35 or for example 78. This can never be a character like a string character like A, B, or C. If not, it's going to give an error. And we actually spoke about this in, I believe it was chapter 2, where we did type conversion. Here, I showed you exactly how we can convert different data types. Here, we converted a string into a float because it was actually an integer value which was wrapped in a string. So if we try to do this now, we are going to get an error. So let's see what error we get. Let me just run this program. So you see that you see the error that we get. It says value error, invalid literal for ints with base, invalid literal for ints with base 10 ABC. So what it's essentially telling us is that I can't convert this item into an integer because it's not even a valid value under base 10. So what we're going to do is we can just change this to like 67, for example. And then when I run this program, we should see that it will run smoothly without any error. So as you can see, no errors were generated. Now, let's say, for example, we want to execute multiple lines of code. We have this value here, ABC equals to age, and we want to convert it into an integer. So let's say in a following line, we want to divide two numbers together. Let's say we want to divide 4 by 0. Now, what we have here basically is two lines of code that could potentially generate errors. So the first one is just going to generate an error because we're trying to convert ABC into an integer, and that is an invalid action. And the second one is we're trying to divide this value, which is 4, by 0. Now that is invalid because we can't divide any number by 0. If we actually try to execute this program, line 4 wouldn't even get executed because the program is going to crash at this line. And I'm going to prove that. Let me just run it to show you. So you see, the moment I ran it, it just immediately crashed at this line, line 2, where it said invalid literal for int. So what we can do is we can actually use try and except blocks to handle multiple errors that could potentially occur. So what I will do is I'm going to put a try block here. I'm going to say try, and I'm going to execute these two lines. Now, the first error that got generated was a value error when we tried to convert this value into an integer, and that was invalid. So we can write except value error as E. I'm just going to come back here to raising exceptions and copy this so I don't have to always do it. Then I'm going to print out error occurred and print out the message which gets generated. Now, the way we are going to check for the second error which could be generated here is we are just going to again simply say except zero division error as E. Then we're just simply going to come down and print it. So we can write as many except blocks as we want, and we can check for some certain kind of exception that could be generated or thrown based on the code that we have in the try block. So here we see that we have only two exceptions that could be generated, which is a value error when we're trying to convert this value into an integer, which is not correct, or when we're trying to divide a number by 0. So let's say, for example, I just clear my screen right now and run this program. You see that we are able to handle the first case gracefully, meaning that the moment it tried to the moment it tried to convert ABC into an integer, Python immediately threw a value error exception in the background. And what we are now able to do is we're able to catch that exception using this except value error, and we're able to print out the message. So we see error occurred, invalid literal for int with base 10 ABC. So what we can now do is let's just convert this into a valid integer. Let me just say 9, and then let's try to run it again. So once we run this program, it's going to successfully convert this into an integer. But when it gets to this line, it will throw a zero division error, and we should be able to handle that error here. So let's see what happens. So let me just run this program. So you see right now, it says error occurred, division by 0. So what we can actually do is we can just change this text to something like you can't divide okay. So we're having an error because we're trying to use single quotes. So let me just change this to double quotes right here. And then I'm going to say you can't divide a number by 0. So once I save it, we are able to just print out some customized text. Let me clear my screen, and then I'm going to run this program. So you see what we get now. It says you can't divide a number by 0. Then it says colon division by 0. So that shows us exactly how we can handle multiple errors that could be generated during the course of a program. So thank you for watching this section. And if you have any question, please don't hesitate to ask me a question in the comment section. Now, I want to give you some activity that you can actually try to do on your end. So the activity is ask a user for two numbers. Now, once you've collected the two numbers from the user, that is, ask them programmatically using the input method. So once you've collected the two numbers, try to divide the first number by the second number. Now, I want you to handle two exceptions that might occur. Now, the first exception that could occur is a value error. When when a user enters a value into the input that is not a a number, like for example 17. Because if, for example, we enter like ABC into if we enter ABC into this input statement, it would fail input function. It would fail because we're trying to wrap that ABC inside the input method, because we expect that the user enters an integer like 17, not ABC. So what I want you to do is making use of exceptions, try and except blocks, as well as error handling. I want you to try and handle and listen to when a user actually imputes the wrong like details. Even if they input the wrong details, we can use the value error to check. And if the user enters the second number as 0, that is if the program tries to divide the first number by the second number and the second number is 0, then I want you to handle that exception using the zero division error. And then at the end of it, you should make use of the finally block, which will always print complete. So I know that might be confusing. I will just go ahead and paste the question right now so that you can see it properly. So this is the question right now. It just says write a program that asks the user for two numbers and it tries to divide the first number by the second. Handles the following exception: value error if the input is not a number, and zero division error if dividing by 0. And at the end, it should always print program complete. So this is the activity that I would encourage you to try and write or practice with so that you can solidify your knowledge in error handling. We are going to moving into a new chapter now. So I want you to go ahead and create a folder called chapter 12. Now in chapter 12, we are going to be talking about working with Python modules, packages, or libraries. So they can either be called libraries, packages, or modules. Now, first of all, I would like to create a file inside this chapter 12, and we are going to name it modules.py. And I want you to press enter. So I'm just going to explain what a module is or what a package is. So a module, package, or library is simply a file that contains some Python code. Now this code could either be functions, variables, or classes. So this is some code that has been written already and we can just import it into our program or into our file. So when you're working on very large applications, imagine you're trying to build a website, the backend of a website, or let's say you're trying to build a mobile application and the amount of lines of code required for this mobile application is, let's just say, 200,000 lines. Writing 200,000 lines of code inside one file is just going to be very messy and very difficult to handle. So sometimes what we can do is we can actually break code down into different modules or into different modules or into different files, which we can then import into each other. Now that's like the first explanation of what a module is. Now the second explanation is a module or package is actually some code, some Python code or some Python file that contains Python code like functions, variables, and classes, which has been written by someone else. So we don't have to always manually write everything from scratch by ourselves. Now it's just that saying that software engineers or software developers like to use when they say do not reinvent the wheel. So what that essentially means is that there are libraries and packages that we can use and we can just import them into our program so that we don't have to worry about writing it from scratch because somebody somewhere else already went through the stress of implementing and writing this for us. So all we have to do is just simply import it into our file or into our program and make use of it. So I'm going to explain exactly what that means. Now, Python has a bunch of inbuilt modules that it comes with by default. Now, as you progress, I'm actually going to teach you how to create your own module. But the first thing that we're going to be talking about is exactly what's inbuilt Python modules that we can make use of. Now, Python gives us a whole bunch of inbuilt modules that we can make use of, but I'm just going to be talking about a few. Then I'll leave a link or I'll show you exactly where you can check out other inbuilt modules. So we're going to talk about the first inbuilt module, which is math. Now, if you want to import a library, a module, or package, all we simply have to do is type import space the package name. In this case, we're going to say import math. Now, note that the moment we type import math, you note that we are not getting any error because this is inbuilt into Python. Now, in a lot of cases, you might want to make use of a library which does not come with Python by default. Now, in this case, this is where we are going to actually need to download it. Now, I'm going to show you exactly how we can proceed with that or how we can actually download a package that somebody else has written and make use of it in our program because not every package for Python comes by default, but just some that come by default, for example, math. Now, what exactly can we do with this package? We can actually open this package. We can do it by hovering over it and pressing Control and then clicking it if you are in VS Code. It's then going to open this very big, well, not very big, but it's going to open this file for you. So you can see that it has a bunch of weird, looking syntax. It has a lot of functions and methods which have been put into the file. So this has been written, all this code has been written by someone else, and we don't actually have to even worry about writing all of this from scratch. We can just make use of it because it's just readily available. Now, what exactly can we do with this method or what exactly can we do with this package? Now, the math library actually has a bunch of inbuilt methods that we can make use of. The first one that I am going to show you is the square root. So let's say we want to find the square root of 16. Obviously, the square root of 16 is 4, but how do we do that programmatically? What we can do is we can print something out. And what are we going to print out? We are going to print out math dot sqrt. Now, before I even type sqrt, you can see that there is a bunch of methods that we can make use of right here. So you can see there's a lot of methods that we can make use of from the math module. So it gives us a bunch of methods. So the first one that we are going to talk about is this sqrt. Now, what we're just going to pass in is an integer, which is 16. So what we're simply doing, trying to say is, we're telling this library, find the square root of 16. Now, once we bring up our terminal, let me clear my screen and run this program. I want you to notice what we get in the terminal. So you see that we get 4.0 printed out in the terminal. So we never had to worry about implementing the code or writing the code that will enable us find the square root of a value. We didn't have to write it from scratch. All we had to do was import a library which has been written by default in Python. The Python developers were the ones who wrote this library or this package. All we have to do is just import it and make use of it. Now, the math method actually comes with a bunch of other, like the math library, comes with a bunch of functionality. Another thing that we can say is math.py. So this is just going to give us the value of pi. So if I save this and print it out, and run it, let's see what gets printed out. So you see that it prints out 3.14159 and so on. So you just print out the value of pi to the terminal. So I believe we can also perform other operations. So let's just see math.pow. So let's say, for example, we want to find the value of 2 raised to the power of 3. How exactly do we do that? We can make use of the POW method, which comes from this math class which we have imported, or this math package which we have imported. And all we have to do is just pass in two values. You can say 2, 3, which helps to signify 2 raised to the power of 3. Now, once I save it, clear my screen, I run this program, you see that we have 8.0 because 2 raised to the power of 3 is indeed 8.0. So we never had to worry about implementing or writing all the code for this manually by ourselves. We can just import this into our file. Now, the next thing that I would like to tell you is anytime you are working with import, it is best practice to always import your code at the top of the file instead of, for example, let's say we had some code right here, like print hello world. And let's say we had like 10 lines of code above. It is typically best practice to always make your imports at the top of the file. So what we're going to do is we're just going to move this to the top of the file. Now, I'm actually going to show you a big file right now, which demonstrates, this best practice. So this is an example of a file which a project that I had worked on, which contains a lot of imports. As you can see, it contains 30 imports. And you can see that all of them are at the top of this file. So it is best practice that you always make all your imports at the top of the file before actually making use of those imports in later places. Now, what I want you to also notice that From packages, you can import specific things. Like, for example, from that file that I had just had open, I'm sure you saw things like from this, import that. Now, we can actually import certain things from a certain package. So when we say import math, we are actually importing everything, every single item, every single line of code, which is present in this package called math. But let's say, for example, we only wanted to import this sqrt method or sqrt function. All we're just simply going to do is we're going to change this. We're just going to change this to say from math import sqrt. Now, all we just simply need to do then is we're just going to get rid of this math.sqrt, and I will comment these lines. So once I do that, what I'm simply doing is only importing the sqrt function, which is present in this package called math. So that way I don't have to import the entire file into my program. And once I run this, it's still going to run perfectly fine because we are still importing that function from, as you can see, it says 4.0. It's still going to work perfectly fine because we are still importing that specific function from the math package, because at this point, that is the only function or the only item that we need from this module. Now we're actually going to talk about a different inbuilt module which Python gives us. Now this module is called date time. So imagine we want to figure out a way to work with imagine we want to figure out a way to work with dates and time within our program. There's an inbuilt library for that which is called date time. So there's a lot of things that we don't have to worry about. So we can just say import dates time. So so this is a wrong spelling. So we can just say import date time, and this is going to help us import the date time package from Python. So what we can do with this date time is we can actually see the current date and time of the present day. So I can actually print something out to the screen. So I can say print date time dot date time dot today. So what this is essentially going to do is it's just going to give us the current date and time of this specific day of today. So once I save this program right now, clear my screen, and then run it, let's see what we get. So you see what we get. We get 2025-10-03. So that's just saying it's the 10th month, which is October, and it's the third day of the month. It's the 3rd of October 2025, and we can see the time right now, 14:35. So you can see the hour, the minutes, the second, and even the nanosecond. So it gives us the exact accurate time at the moment that the program is run. So let's say, for example, you are working on a Python program and you need to get the current dates. You can always make use of datetime.today. Now, this package actually comes in with a whole lot. It actually contains a whole lot of things that you can do. But I would advise that you just go to Google and search dates time Python. So once you do this, it's just going to return to you, the library itself of dates time. And you can actually see there's some documentation that AI gives us. So from dates time, we can import dates time, as well as other functionalities. So I would recommend that you go through the documentation. Now, there is something that we actually haven't even really spoken about as a Python programmer or as a programmer at all. When you are learning to program, there is something called documentation. Now, documentation is basically an explanation of how some certain library works. So, because we are making use of a library, which has, for example, been built by default in Python, we need to actually understand how to use that library or that package. All you have to do is just go online and Google that package. And you will typically see a bunch of resources which are going to be explaining how that package works. For example, you saw that all I did was just simply Google datetime Python, and I saw a bunch of these. I saw a bunch of results being returned to me. And if I actually click this is the official documentation for the datetime module. So you can just read through it, understand exactly what it does, and exactly how it works. So that is exactly what documentation is. It just basically explains how a certain library or package works. So you could just Google date time, click W3 schools, and they actually have an excellent explanation of how it works. Now, I also explained that I was going to show you how I was going to show you where you can check out modules. So if you go to W3 schools, you see that there is a section dedicated to Python modules, and it actually explains what a module is. It says consider a module to be the same as a code library. So that is exactly what it is. And they go down to make use of a bunch of modules like dates, math, JSON, and so on. So what we're just going to do is we're just going to continue exploring some inbuilt libraries which Python has given us. So the next one that we're going to talk about, the next and the final one which we're going to talk about is the random library. So I'm just going to say import random. Now, what the random library helps us to do is, as the name says, helps us perform some specific actions at random. So let's say I have an array or a list rather. So I'm going to say my students, students. So let's say I have a list of student names. So I'm going to say John, Samuel, and the last one is going to be Jane. Let's say I have a list of students right here, and I want to randomly select one of the students from this list. What I can actually do is I can make use of the random package or the random library which has been inbuilt by default into Python. So how exactly can I make use of it? Let's just print out something to the terminal. Let's print out random dot choice. And in here, I just have to pass in my students. So what this method does is that, or what this method from random does is that it accepts an iterable item. That is, it accepts a sequence of items. So it could be a list that it is accepting. It could be a string that it is accepting. Basically, it accepts something that can be looked through. And what dot choice does is that it's going to select one at random because the name is random. So it's going to select one item out of the sequence, out of the iterable item. So it's just going to select one at random. And let's actually clear the screen and run this to see what we get. So when we run this the first time, we got Samuel. But when we run it again, we might actually not get Samuel. It could be a random item. So we get Samuel again. Let's run it again. So you see we get John this time. So if I run it again, we get Jane. If I run it once again, we get Samuel. So it's just always going to select one item at random from a sequence of iterable items that you pass in. So you could pass in a list, it could be a string, and so on. So that's what the random library does. So we have a bunch of inbuilt libraries that we can actually make use of. So I would advise that you go to Google and search Python inbuilt modules or libraries, any of them. Now, once you do that, so we are just going to look at this documentation, the first item that says Python module index. So what it's going to show you is a bunch of modules which are possible, that is, which are available that we can make use of. So there's a bunch of them that we can make use of in our program. So you can actually just look through them. If I scroll up right now, let's see. So we see random, which we had just used in our program, which is what I had imported at the top, random. So if you ever want to see the documentation, you can just click into it. Then let me also look for dates time, which we had imported. So you can see we have dates time here. Then we have a bunch of other inbuilt methods like decimal. We have CSV. We have asyncio. We have Tinker. So we have a bunch of inbuilt libraries which Python comes with that we can make use of. So I would recommend you go to this page and explore what some of these libraries and packages can actually do and what their use and what their uses are. In the last chapter or in the last section of this chapter, I had explained exactly what modules, packages, or libraries are. Now, I also talked about some inbuilt modules that come with Python. Now, in a lot of cases, you might want to make use of a module or a library which Python does not have installed by default. Now, what we can do is we can actually make use of the Python package index, or short for PyP. Now, this is a place where people go to upload the packages that they have built. So let's say, for example, I wake up one random morning and then I decide to, let's say I wake up one random morning and I decide to make my own package, right? I decide to make my own package and I want to publish it to the world so that other people can make use of it. I can actually create this package, and once I create this package, I can upload this to a platform called PyP, which is short for Python Package Index. Now, as you can see, it says find, install, and publish Python packages with Python Package Index. That's the short. That's the short. That's the full meaning of PyP, Python Package Index. So it's basically a place where people can come upload the libraries that they have created, and other people can actually download it. And I will be teaching you how to actually download and install these packages that other people have made use of. So, for example, you can see there are 684,555 projects, and there have been over 7 million releases, 50 million files, and 963,000 users. So this is a platform that is actively being managed every single day, and new packages are being uploaded every single day to the platform. So I'm just going to show you exactly how to install a package. So the first one that I'm going to show you is request. Now, the request package is a package that actually helps us make requests to an API. Now, you might not fully understand what an API is, but we can just think of it as, it's an API is short for Application Programming Interface, and it's a way that enables two computers talk to each other. Now, this is an example library that we use to interact with APIs, and it is called requests. So you can see it says Python HTTP for humans. Now, if you ever want to install a library, all you have to do is just copy it right here. Run the command pip install request. Now, pip, as you see, is actually the package installer for Python. So it is inbuilt into Python. So the moment you install something, the moment you install a library, you have to make use of pip. Now, there are other methods that you can use, but pip is the most popular method. So all you have to do is just run pip install and then the package or library name. So I'm just going to copy this right now. I'll go back to my terminal and paste it in there. Now you have to make sure that you are connected to the internet. If not, it won't work. Because what this is actually doing is it is downloading all the source code for this specific library called request. It is going to download all the source code from the internet and put them on your computer. So once you press enter, it's just going to go to the internet and then download all of those details, or sorry, download the package from PyP, which is right here. So what you can also do is you can also take notes that there is documentation that is usually added for that specific library. So here it says requests allow you to send HTTP requests extremely easy. So all we have to do is just download this library using pip, and it's just going to basically help us install it. So now I am seeing this message saying requirements already satisfied because I actually already have this library installed in our computer. So I just wanted to show you an example of how you would want to install a library. I am going to show you an example of a package or library that we can actually make use of right now to test. So this library is called read time, and it's a library that somebody else has written. And it says it calculates the time some text takes the average human to read based on medium read time formula. So let's say, for example, you are building a blog application. Usually when you look at some blog applications, it would usually show the amount of time it would take to read the entire blog body. Now you can actually make use of this library to estimate the amount of time it would require. Now all of this has been written by somebody else, and it's actually even very nice that we don't have to always, it's nice that we don't have to write all of this from scratch. So what we're going to do is head to the terminal, clear the screen, and run the command pip install read time. Now this command came from here because we had copied it from here saying pip install read time, and read time is the name of the package. Now I also want you to note that each of these packages have different versions. So each version represents an update that was made. So it is important that you keep track with it's important that you keep track of the exact version that you're using. The last time this was, it says this is the latest version and it was released July 22, 2023. So that was 2 years ago, 2 years and some months ago. So that is exactly how, to keep track of libraries. Now, as you can see, it is currently installing this for me. So I will just wait for the installation to complete. And so right now the installation is done. So what we are going to do is we are going to follow the documentation, that is this guide that has been written for us to actually be able to make use of it. So you can see it shows us the algorithm. It says mediums help center says, and there's just some specific text. But what we are bothered about, or what we are actually interested in, is actually how to make use of it. So it says usage, import read time and pass it some text, HTML or Markdown to get back the time it takes to read. So I will just copy this. I'm just going to import this by saying import read time. So I will go to the top and paste this right here. So when I say import read time, Python is just going to automatically know that we have this library installed because we had already installed it earlier. But if you don't have a specific library or package installed, then it's going to give you an error because it does not recognize that that package is installed. Now, the next thing is we're just going to copy this and I will explain exactly what is happening. I'm actually familiar with this library because I have used it multiple times, but let's just copy it and paste this right here. So what we are simply saying here is we have results equals to request dot of text. Now this of text is a specific method which is coming from this read time library. And if I click into it, you see that it is this specific method that says get the read time of some text. And it just basically helps us to, you know, it basically helps us to determine the amount of time to take to read this specific text. So it says read time dot of text, and we have to pass in the actual text that we want to see. So what we can just do is we can print results dot seconds. So what this is going to do is it's just going to return to us the exact number of seconds that are required to read this specific text. So once I run this program right now, let's see what it gives us. You can see that at the end, it gives us 2 because it's just basically saying all it takes is 2 seconds to actually read this, the shortest block in the world. So let's say, for example, I decide to add a lot of gibberish into this and I save it. Now, once I run this program again, it should actually give us more than 2 seconds because we have added more text. So let me run this. And we see that the output is 3 because it has already determined that the amount of time required to read this is 3 seconds. So this is exactly how you can make use of external libraries that other people have built. Now, imagine you're trying to work on a project and you are trying to, think of some specific feature which you don't want to necessarily write on your own. All you have to do is just literally Google it and it is available to you. There is even a speech recognition library that has been written by someone else. So if you want your program to be able to recognize speech, that is when you speak to your program, it's able to recognize everything you are saying. There's actually a library for that. So I can actually just go to the top and search speech recognition. And once I press enter, it's going to search through all the libraries which are called speech. It's going to search through all the libraries for speech recognition. And I can see this one, it is the top one. So when I click into it, you can see it shows me exactly how to make use of this library. So there's a bunch of ways that you can, there's a bunch of libraries that you can use. All you have to do is just search up whatever functionality you are trying to build. So if you're trying to build something that you don't want to necessarily write everything for, like if you want, like for example, let's say you're trying to build an application that is able to recognize speech from a user, all you have to do is just make use of this library and to be capable of capturing everything that the user has said. So in this last chapter, or in this last section of chapter 12, now this is actually going to be the last thing that we are going to talk about in this course. So if you have made it this far, I am very happy that you have made it this far and you are completing this Python course. because this is the last thing that we're going to talk about in this course. And I am glad that you've made it up until this point. Now, the thing that we're going to talk about in this specific section is how exactly can we make our own Python libraries? That is, how can we work on our own Python libraries? I had explained that people sometimes might write a library and upload this to this website PyP, which is the Python index for Python libraries. Now, how exactly can we make our own libraries locally? So I want you to create a new file and call it, let's just create a new file here and call it my underscore library dot py. Now, inside this file, we're just going to create a very simple function and we're going to call it greet. Now, what we're just going to do is this function is going to collect a name, and what we're just going to do is we are going to return a string. Now, we're going to return a formatted string, and this is going to be hello, comma, the name of the person. Now we have created this method or this function. How do we now make use of it in a different file? So what we can actually do is we can create a new file right here inside chapter 12, and we are going to call it test underscore module.py. Now we're just going to make use of this function which we have created inside a different file. Now, how exactly do we do this? We are going to say from dot import my library. Now let's explain exactly what is happening here. So when we say from dot, what that means is we're trying to reference the current folder that this current file which is executing is currently in. Now, if we look at this file, it's called test underscore module. Now, the test module file is inside chapter 12. Now, when we say from dot import my library, we're simply trying to import this file called my underscore library. So when we say from dot, we're saying from this current folder, import this file, which is my library. Notice that we didn't say import my library.py. We just simply typed the name of the file and we said import my library. Now, once we have imported this file, we actually have access to every single line of code which has been written inside this file. So that means that we can actually access this function. So what I can now do is I can come down and print my library dot greet, and in here I'm just going to pass in Solomon. So the reason why I can say my library.greet is because there is a function called greet which is present inside my library. So when I say my library.greet, I am just trying to access this function which is named greet. So I'm just also going to pass Solomon in as a parameter. So once I run this program, okay, now we can see that we have an error saying import error attempted relative imports with no known parent package. So the reason why we're getting this error is anytime you are trying to create a package, that is, anytime you're trying to create your own module or your own package, we need to create a special kind of file inside the specific folder to let Python know that this folder is actually a package which we are trying to create. So inside chapter 12, I want you to create a new file. Call it double underscore init double underscore dot py. So it is underscore underscore init underscore underscore dot py. So once I create that file, I don't actually have to even write anything in the file. But what we're just letting Python know is that this current folder, we want to treat it as a package. As such, we want to be able to import each of these libraries. We want to be able to import these libraries anytime we want to work with them, or import these files because the files are going to act like packages. So the moment I run this program again, sorry, not this one actually. Let me just clear my screen. So the moment I run this test module again, we shouldn't see that error being printed to the screen. So the reason why we're actually seeing this error is this is a wrong way of importing it. So what I actually wanted to do was say import my library. So what we're just trying to do is we're trying to import this entire file into our program. So when we say import my library, it's just like in the in the previous section where we talked about this library. When we import random, we're importing random and all the methods or all the functionalities, functions that exist inside this random file. It's the exact same way we're importing my library. So when we import my library, it means we're going to have access to every single line of code, whether it is a function, a class, or a variable. We're going to have access to it. So that is why we can call my library.greet. So I'm just going to clear the error in my terminal. Now, once I run this program, I want you to see what happens. Now we see hello, Solomon being printed to the terminal. So what Python did was it just came to this file, took note of the function which we imported, which was it took note of the entire file. Then when we said does greet, it just ran this method. Now imagine we want to only import this specific function from this file. All we're just simply going to do is we're going to change this to from my library import greet, and I'm just going to remove this my library.greet, and all I can just do is print greet of Solomon. So once I clear my screen and run this, you are going to see that it's still going to work perfectly fine without any single error. Now, this is exactly how you can create your own Python packages. So if, for example, you create a package that solves some kind of problem and you want to publish it online, this is exactly how you can start working on your own package. And people will just be able to, download and install it using pip, like how I had showed you. So if you've made your own package, all you need to do is just go to Google and literally just search for upload. You first of all have to register on this platform. Then you have to figure out, probably Google it, how to upload your own Python package to UIPI. I'm sure it's not so difficult. So this is the last video which we are going to, this is the last thing that we are going to talk about in this course. I hope this course has been incredibly helpful to you, and I have actually enjoyed filming this. I'm happy I've been able to, make this entire course. If you have any question whatsoever from all the 12 chapters that we have talked about, please feel free to reach out to me, and I will definitely be happy to respond and help out. Thank you for watching this entire course, and I'll be happy to see you in the next one.